Martinomics.
Oh my goodness. It's the semi-Martinonic. The semi-Martinonic. He's in Ghana. I know, that's Martinonics.
That was right. So I was like,
Yeah, that's fine. Yeah, he ready.
All right.
But I know what. Okay, we're very excited about a very intense day on firms and frictions and good things. So,
All right. Thanks a lot for having me. Thanks a lot for waking up early for me. I appreciate that. So this paper, joint project with Ruben and Marty, is here. And here we're trying to understand how trade affects the diffusion of knowledge across countries. Sort of the standard or the canonical view on the literature is that trade facilitates knowledge diffusion. And many in the room have built models on that, Paco, Ezra, Martin, and others here. And the main idea is very simple. When a country opens up to trade, we get exposure to products produced in other countries using different and potentially better technologies. So sort of the firms figure out by reverse engineering those products, the technologies used behind them, and then learn and adopt those better technologies. Because of that, knowledge flows across countries, right? And that is a very important insight, because if that is true, that means that when you open up to trade, you lead to knowledge diffusion, and then you lead to larger growth. That matters because that means that the gains from trade should be even larger. So it has important policy implications. And sort of the main empirical evidence for this view comes from two different sources. So the first one is that there is a correlation when you look across countries between the adoption of frontier technology and openness to trade. And the second main evidence is that the fact that we know that trade increases firm level TFP. However, none of these facts is a direct support for the view that trade leads to more diffusion, because as we know, correlation is not causation, and trade could increase firm TFP for many reasons. Diffusion is only one of them. So because of trade, firms have more competition, they have access to better inputs, they have access to foreign markets, and all of those could also increase firm level TFP. So what we want to do in this paper, we want to isolate the effect of trade on diffusion, all right? So we want to know how trade policy affects the diffusion of technology across countries. But to answer that, we're going to study the case of Brazil. And Brazil is interesting because in the 90s, there was a large trade liberalization. Import tariffs went from around 30% to about 10%. All right, so we're going to study that event, and I'm going to have two measures of diffusion. So the first one is technology transfers made by foreign firms to firms located in Brazil. I'll be more precise about what technology transfers means, but for now, just think about a patent. All right, I create a patent in the US, and then I transfer that patent to a firm located in Brazil. That's a technology transfer. That's important because that measures whose technologies Brazilian firms are using, all right? And the second measure of diffusion is citations made by Brazilian firms. That is also a relevant measure because it tells me whose technologies Brazilian firms are building upon. And then I'm going to show two main results that comes out of that. So the first one is that an increase in import tariffs leads to an increase in technology transfers and an increase in citation. And more than that, it looks like these two things are connected. Because the tariff leads to an increase in citations to firms that are transferring technology to Brazil. If you have never transferred technology to Brazil, when tariffs goes up, you do not receive more citations. And citations are made by firms that are on the same zip code of firms that receive technology transfers. And we think that these results matter for two reasons. So first, less tariffs, more trade, less diffusion. It's sort of the opposite of how I started this talk. And the second, it looks like these two things, citations and technology transfers, they are connected. And to give you a bit of an insight on that, let me tell you a story. Yeah.
Before that, I'd like to know how you think about technology embedded in capital. That would seem to me as diffusion as well, if you increase the import equipment from.
Yeah, I won't be discussing that part of diffusion at all.
Again, what is patent transfer, is the transfer of the owners?
Yeah, let me give you this example. Then it's gonna answer that question. So Nippon Steel, as the name suggests, is a Japanese steel company. And this is where you can see here the Japanese flag. And then before the trade liberalization, they signed a technology transfer agreement with a Brazilian company, Gerdau. That's a steel producer in Brazil. That technology transfer had two components. The first component was the licensing of a set of patents owned by Nippon Steel to Gerdau. Now Gerdau is allowed to use those patents. And the second was the application of the knowledge in those patents to the production of round steel bars. Nippon sent a ton of engineers to Gerdau, and then they went there and taught them how to design the production line to produce round steel bars. After this technology transfer, another company, CSN, created a set of patents on round steel bars that cite the original Nippon Steel patents. That was before the trade liberalization, when import tariffs in Brazil was very high. In the 90s, import tariffs decreased a lot, and Nippon Steel has never made another technology transfer to Brazil. The way we're going to rationalize that, and explain that, is we're going to take the model by Buera and Oberfield, and they're going to add one element to that model, just technology transfer. And firms, they have to make the following choice. They have a trade-off between exporting to Brazil or licensing their technology to a Brazilian company. When import tariffs are high, the profit of exporting is low, because you have to pay a lot of tariffs. That means that companies like Nippon is going to prefer to transfer the technology rather than exporting to Brazil. And that's great for Brazilian firms, because one of them is going to learn directly from Nippon, going to become more productive, and the others around it is going to learn from the technology transfer, seeing the labor using a better technology. When import tariffs decrease, Nippon is going to say, well, I can't export directly to Brazil. I don't need this Brazilian partner anymore. Then when they export to Brazil, that's harder for Brazilian firms to learn, because they have to learn from seeing the final product, which it has different learning rate than seeing their neighbor using that technology. And this is very important, we believe, because it has implications to policy. What this means is that to reap all the benefits from trade liberalization, you need to subsidize technology transfers, because technology transfers have at least spillover that firms are not taking back. That's the paper in a nutshell.
So what do we know about the citations and the relationship between citing firms and firms being cited? I mean, this is recent work in the US that most citations are done by firms that are related through the input-output chain. In which case is, I mean, the fact that there are less citation it could be just that they're producing less locally. But
So we are going to try to isolate that component.
Do you know that whether firms are related as suppliers, clients?
We are going to look at firms that are in the same sector. So I'm citing another firm, like the Nippon Steel case. I'm not counting the citations that goes up the supply chain or down, I'm going to cite citation to the same guy in the other side.
The motivating statement you used at the beginning was reverse engineering, but this is a different channel.
Sorry, I think that was me. I'm not sure what that.
So was a different channel?
This one you described now is not reverse engineering. It's that they
No.
like direct.
They're learning.
Yeah.
Yeah, from technology.
But so that motivating fact you started with the beginning would still be going on regardless. Right?
No, yeah, on the model, that's still going on regardless. That's also there. It's just another force pushing in the other direction. And what you're gonna say is that when you calibrate this model, that other force is dominated. I'm not saying that doesn't exist, I'm saying it's dominated by learning from technology.
So that's in the model too.
That's the model.
Okay.
Yeah. All right, so let's see how I do that. Let me describe the data. The two main data sets. PatStat, the data set that has citation for patents across the globe. We're gonna use that to measure sort of whose ideas Brazilian firms are using. All right, so the main left-hand side variable is gonna be citations by Brazilian firms to firms in other countries. And then we're also gonna use this data set that has technology transfers. So that is the universe, industrial knowledge transfer to Brazilian firms. That's important, that measures whose technologies Brazilian firms are using. So now, let me tell you where this data comes from. So PatStat, it's obvious, we're there by it. Now, the technology transfer is less obvious. So what happens is that since the 70s, the patent office and the central bank in Brazil records all international royalty payments that are associated to improvements in production. That has two parts of it. The ones that are associated to intellectual property directly, like patent transfers, patent licensing, trademark transfers, and all this type of things. But also the know-how transfers, which are transfer of knowledge, which are not directly protected by copyright. What is that? Technical consulting. So the engineers that Nippon Steel send to Brazil, they have to be paid, and that is a type of royalty, and that's a technical consulting. R&D support, trade secrets, and other type of things like that. And the important thing here, it has to be associated with production. So for instance, a finance consulting, not gonna be here because that's not associated to improvements in production.
Are there any tax implications of what payments are being declared under this category?
Yes, you have
Not
to,
like tax deduction.
there's no tax deduction, you have to pay taxes though. There is you have to pay taxes on this royalty that you're paying. The foreign firm usually has to.
What I'm saying is that if this is something that you would put in your input costs, then this would potentially reduce your tax liability in Brazil. So maybe there are tax incentives.
Yeah, I don't know if you reduce the tax liability of the Brazilian firm, I know you have to pay taxes on the royalties, because the type of income as well. So what I did, so this is the same data set I used on my job market paper. So I was worried about that as well. So what I did is I ran a survey, the people that they helped design this type of technology transfers. I have a set of lawyers that just write the contracts on that. So what these lawyers told me is that firms have a very strong incentive to do this right. By right, I mean registering in the patent office and the central bank. Because let's say we sign an agreement and I steal your technology, I stop paying you. If that's not registered, you can't go to the judge. The firms have very strong incentive every time they make a technology transfer to go register them. And when they register, observe their data set.
So just a clarification.
Yeah.
But these are transfers within firms. So
No, not necessarily. Only 50% is within firm. Most of them is across firms.
so you gave the example of Nippon, so
Yeah, but Nippon is not part of their DAO.
thank you.
All right, so let's see how I'm gonna use that. To the left-hand side, YOST, that is an outcome of origin country O in sector S and year T. And I'm gonna run that a regression. So this is sort of gravity equation in which the only country that I have there is Brazil. In the import tariff imposed by Brazil on country O, sector S, and year T, and then I have a set of fixed effects. The most important left-hand side variables are going to be technology transfers that sector S received from country O in year T, and then I'm going to aggregate that in the next 3 years. That's for 2 reasons. So first, to take time for firms to adjust the technology transfers. You need to go outside, you need to find someone to teach you how to produce something. That takes time. And the second is that this is very lumpy. You should think about this sort of capital, should think about this type of knowledge as sort of capital investment. So it spikes up and then goes to zero, then zero a couple of years, then it goes up again. So you need to deal with the lumpiness of it. We do that by aggregating the next 3 years. Another measure is the citations that Brazilian firms in sector S are making to country O. In the next 3 years, we also aggregate that. And then we run that, as I explained before, the import tariff the Brazilian government imposed against country O, sector S, and year T. And then we have a set of fixed effects. So one of the fixed effects is going to be a sector time. And the goal is to capture like productivity shocks or the level effect of trade openness on sector level outcome. For instance, trade affects competition, and that should affect competition the whole sector. So then we capture that with the sector time fixed effect. And then we have a country time fixed effect, should capture things such as intellectual property agreements that these countries sign from time to time. And beta here is the coefficient of interest. So if the canonical view that trade leads to more diffusion, then what should happen is that beta should be negative because an increase in import tariffs decrease imports and decrease the learning rate from foreigners. All right, this is what we're going to test in the data. The problem is that you might think that this is an endogenous regression because usually you have a lot of political interference on the import level of import tariffs. And we think that it could be the case that it's the other way around. Trade leads to change in tariffs rather than tariffs leads to change in trade because of political interference. What they're going to do is going to use the same instrument that Bohem, Levichenko, and Penlai recently used in their paper. And the idea of the instrument is that to compare small MFN trade partners to countries that are trading under preferential trade agreement. And the idea is that you have this political interference only on large MFN trade partners and not on small MFN trade partners. So we're going to compare these 2 groups. So let me give you the intuition on how it works. Suppose that I'm plotting in the y-axis citations, and then in the x-axis we have at 0 a change in MFN import tariff. So then I'm plotting what happens to a preferential trade agreement partner, in which tariff didn't change. If tariff didn't change, nothing happened. But then you could think that if you have a large MFN trade partner, like the US is to Brazil, what's happened is that the US is lobbying in Brazil to decrease tariffs. And then because US is lobbying, because something's happening in the US, like US is growing fast, US wants to export to Brazil, so that's endogenous. You cannot compare the US to the preferential partner. What we do, and that is Levchenko's and co-authors' idea, you drop the large MFN partner, and then you just compare the small MFN partner to the preferential trade agreement partner, and then the difference in difference, so the change in the change of the growth rate would be the effect of tariffs on citation, which in this case would be this margin here. So that's the idea of the instrument. And the way you implement that is very simple. So the left-hand side is the actual import tariff. The right-hand side is the MFN import tariff interacted with a dummy if the country's sector time is MFN partner. And then you have all the fixed effects, including a fixed effect if you're MFN partner. And then you sample select. You remove the cases that you think there is endogeneity, which is the top 10 exporters and the top 10 exporters within each sector. And in the paper, we go through a large set of exercises to show that this makes a lot of sense. We show pre-period parallel trends, exogenate to other policies and exogenate to the exporting country growth as well, which is the main idea of the instrument. All right, so let's go to the results.
Just a question, in practice, what are the countries that have this ardent discrimination in the case of Brazil? Do you have examples?
The large ones that dropped to me.
No, the ones that you're not dropping, what are the treated countries in this case?
Oh, I can give you the,
Example of treated countries.
oh, you have other Europe, they're still there. US and Canada, they are also MFN. So Brazil has very few preferential trade agreement partners, so the Mercosur, to South America basically, and there is also Egypt,
So the countries
Israel.
that are used for this identification are small European countries.
Would be, we drop the top 10, so there would be small European countries, yeah,
So those are the ones that they are treating.
that we are comparing, exactly, oops. That we are comparing here, yeah. Good question. All right, so let's show what comes out of that. And this is the first result. So what this table is showing is that tariffs leads to an increase in technology transfers. So the first column here is the effect of tariffs on the inverse hyperbolic sign, the number of technology transfers received by Brazilian firms, right? Remember that I'm aggregating in the next 3 years. So an increase in import tariffs by 100 percentage points lead to an increase in technology transfers by 15%. Here, column 2 and 3 help us understand what is the margin of the adjustment. Here I have the number of unique licensees. So these are companies in Brazil receiving technology transfers. And these are the number of unique licensors. So these are the foreign firms sending technology transfers to Brazil. What I want you to notice is that these two numbers here are very close to this number here. And what that means is that what happens here is not that you have firms sending more technology, you have more licensors and more licensees. It's more of the extensive margin rather than the intensive margin. Right?
And here things are clustered at the,
Scenarios, you mean?
yeah, the sector.
Sector, country, yeah, sector. And this is the impulse response function. So here's the pre-trend. If there is something, is a downward trend. But then after the MFN tariff change, you see that there's an increase in technology transfers. It doesn't seem to survive forever, but here the sample becomes quite in use.
That's a flow or cumulative?
This is the flow. You aggregate to 3 years.
I was just curious how the results would look like if you didn't do the sample selection. Of course, like you would compromise the causal interpretation of the results, but
Yeah.
presumably a lot of the flows that would be coming from the top exporters. So I was just curious how the magnitude would change if you did the less clean thing, but presumably a perhaps more interesting quantitative magnitude.
Yeah, wouldn't change that much.
So it's great, right?
Yeah,
Like,
yeah,
great.
wouldn't change. So people, we didn't want to do this claim, but people said that a lot of the tariff change in this period is sort of random, depends most on the level that it started. Because what happened in Brazil since the Brazilian liberalization, they started very high, the military dictatorship, and all of them went down, sort of the same, arriving all of them almost around 10%. So what really matters, the change is, what matters for the change is where they started, and where they started, people have art, it's kind of random. So I guess it's my interpretation of why these two results deliver very similar things, because the tariff itself seems to be a bit exogenous tariff change in this period.
So just to clarify, because I want to make sure, so if you were not doing any kind of, if you were just running that regression without any instrument, the
Yeah.
coefficient still would be positive.
Yeah.
So overall, that means that technology transfer has been falling, citations from abroad has been falling to Brazil.
No,
Tariffs are falling over this period.
no, but then we're thinking about, we're thinking levels. Remember, we have a ton of fixed effects here. That's not true. Tariff change, technology transfer in Brazil have moved in various different ways in this period, went down and up.
So I think, you run a like static regression in a way, but what I think matters more for technology transfers is actually the expected path of the policies. right? Because if it's just one period change in tariff and we don't expect it to last, that's basically a fixed effect interpretation, then it doesn't seem like, you know, Nippon still would actually be willing to go in such hustle to do the transfer. But then you argue that the tariff movements are quite random and
I wouldn't say no, just it's random. I said the change in tariff, the change in tariff is random, not the level. So what started is that the tariff, it happened in other countries as well. The tariff started very high in the military dictatorship, and all of them went down to about the same level, 10%. But where they started was sort of random, so it means that this sort of change is kind of the exposure to the change is kind of uncorrelated with other stuff happening in those sectors. I would say, I mean, I don't have a way to say what these people are thinking about the tariff changes, if it's persistent or not, but looking at the data tends to be persistent. Tariffs are only going down mostly in this period.
Then the elasticity you're measuring are not really like a deep elasticity. It depends on the specific trends in Brazil.
I don't know what's a deep elasticity. I mean, I would say that when we go to the model, we're going to feed in the path that we observed in the data. We're not going to use the same procedure to calibrate the model. Don't know if that answered your question.
I'm saying that, you know, the autocorrelation of the taus is sort of matter for how large or small the beta is. And different countries, if we want to extend the model globally, they have different autocorrelations of tariffs, and that could change.
Yeah, I possibly, yeah. We're gonna go to the model, we're gonna treat we're gonna reproduce this on the model, we're gonna feed in the same tariff path or observe the data.
You have two types of technology transfers. Do you observe the same pattern for these two types?
Oh, great. As a fact, there's in fact only one, which is know-how transfer. Yeah, so you don't observe any effect in the ones that are associated to patents or trademarks. You only observe an effect on know-how transfer. All right, so let's look at citations. And this is what happened in citations. So an increase, 100 percentage point in tariffs leads to about the 60% increase in citations to that sector country there. Here is a dummy, takes the value of one, but at least one citation. The sector country receives at least one citation.
And here a sector will be, what is the level, what's a sector?
It's 4 digits. We have, now you got me. We have a lot. I want to say around 200 sectors.
And in what sense you say there's no, it's all horizontal? No, and steel will be, what will be the sector?
So it's steel in Brazil, and then we're regressing. The left-hand side here is the steel
That's
tariff.
the thing, whether they could be suppliers or.
No, that's a good point.
In what sense is that just producing the same product, or it just includes some supplier clients?
I guess, yeah, this is part of bit of my guess, is that it hasn't to do much with supply. I'm going to show you exercise on that in a while, because when you control with input tariffs, results do not change. But there's also another piece of evidence, which is technology transfers. About 95% of them are firms in the same sector. It's not suppliers transferring technology.
No, the transfer for sure, but then the citations across firms in Brazil, that's what I was curious about.
Yeah, there we can check. There we can check. Yeah. All right.
But it's also kind of surprise. If it was to be purely horizontal, that would be kind of surprising relative to the BI literature that doesn't find much spillovers horizontally. Because I can think of this transfer to Brazil as some sort of FDI in a sector. And you tell me that it used to be a lot of horizontal spillovers, and now there is not. But we don't see a lot of those in at least one reason of the literature is.
Yeah, we can test that for sure. But I'll mention a test for you, which kind of make me think it's not about suppliers. But let me show you in a while. All right, and this is what happened to citations. So this is the impulse response function. Before, there isn't much happening. Then when the import tariffs increase, slowly but surely, citations that only sector pair increases. All right, so what we learned so far, 2 important points. Tariffs increase technology transfers and tariffs increase citations. It looks like the more trade is actually leading to less diffusion, right? So now what we want to do is to understand why. The first step to understand why is to understand who is citing. And then the next part, maybe the next version of the paper, we're gonna break it down as well by this second. Here is the citations to the licensors. So those are firms that at some point made a technology transfer to Brazil. Those are citations to non-licensors. So those are firms that never made a technology transfer to Brazil. The effect is only on licensors. You don't find much in effect on non-licensors. All right, so firms that are transferring technology to Brazil are receiving technology transfers. Now let's see who are the firms making these technology transfers. So let me show this here first. Here, I'm breaking down by 2 groups of firms. Firms that receive technology transfers, firms that don't receive technology transfers. Citations are being made by firms that don't receive technology transfers. Now let's look if they're importing inputs or not. Those are firms that are not importing inputs. And also those are firms that are not exporting goods. So the firms making the citations are mostly firms that have no connection with international markets. Now let me show you this, which is where these firms are located. Column 1 is the effect on citations by firms that are on the same zip code of licensors. Column 2, same different zip code of licensors. So they have no neighbor that received the technology transfer. Column 3, on firms on the same city of technology licensors. Column 4, firms that are in different city. So what this result shows is that most of the effects are on firms that are neighboring a technology, firms that receive technology transfer. Yeah.
Do you know if these areas of where firms are exporting or not?
Sorry, what?
Exporting or not in exporting firms and how these changes?
Yeah, I showed you the table before.
Okay.
Most of the effect on firms that are not exporting. Yeah.
Related to the work of Jennifer Poole, with the rice data, you can see if this is explained by working ability.
Yeah, I tried that. It's not. It's not explained by work mobility. No, it's very surprising because I tried many things. It's not explained by worker mobility. It's not explained by researcher mobility. It's something about being near these firms that are receiving technology transfer, which is not necessarily embedded on workers. I tried that. My usual example is, these guys will play soccer together. And then they say, look, we're letting this technology from this Japanese company. And it's great. And it's not much about workers. All right, have a ton of questions. Let's start there.
So I guess one of the direct impacts of the target growth is input competition. So that's affecting the extensive margin of firms a lot. Like is there kind of just an exit margin that's explaining why tariffs fall? You get a lot of trade, you lose a bunch of firms in that sector, and so you just sort of as a result get less citations.
Yeah, remember that this regression is sort of gravity equation. So we have a sector fixed effect. This force is probably there, and I guess it's captured by the sector fixed effect.
Some examples, cool. Can you look at employment flows?
Employment flows, I haven't looked at. So it's difficult to look at employment flows here because you cannot link employment flows to a particular country.
No, in Brazil. Like the firm to firm.
Oh, yeah. Oh, so this is the same question. Yeah. Yeah, I look at employment flows. I don't find any difference there. So it's not really employment flows. Yeah.
Can importers stop importing next year? How do you classify these firms into different samples?
Oh, here is if you have ever made a technology transfer, if you have never made a technology transfer to the whole sample. So keep so that is just so we keep it constant. All right, so what we learned. The citations are direct to firms transferring technology to Brazil. And they are made by firms that are on the same zip code of these guys receiving technology transfers. I didn't show you this, but this is another interesting result. Markets meaning country sector pairs that send more technologies, they are the one that receives more technologies. What surprises is that country sector pairs that do not receive technology, they do not receive citations, which suggests really that these two things are connected. And then there is evidence that this transfer technology are spreading among Brazilian firms. What we want to do now, all right, now I want to address alternative explanations. I was expecting you guys to ask about FDI, but it could be the case that tariffs are affecting FDI, and that's what explains the results. The thing is, we find no effect in FDI. So here, the first column is the number in each sector, the number of foreign partners from that particular country, all right? No effect. This is the number of firms owned by people from that country owned. No effect. This is if we have at least one firm on that sector owned by someone from that country owned. No effect as well. And say, well, let's aggregate the next 3 years like I did with the other variables. We also find no effect. So it doesn't look like tariffs here in Brazil are affecting FDI.
This one, this one survive also the events.
It does. It's still not significant, even if there are less.
But you would just,
So
Yeah.
I would imagine that the tariffs that have fallen are in major countries like the US and, right? So you're saying then I would have expected at least there would be some FDI flows from major countries, because again, in the countries that are treated, the local average treatment rate is for a very small country, so maybe we did not expect them to have started from, because what's happening is that tariffs, the language you're using is tariffs are going up, but in practice tariffs are going down, right?
Yeah,
So there was no FDI from these countries to begin with, probably, would want for them to want to lose, but for the US, it's very surprising if they say that, okay, I cut the tariff over this period and there was no increase in FDI.
Yeah,
will increase.
that's true. They remove the instrument, have all the samples that could be true. But remember, really thinking about levels, but here we have a ton of fixed effects. So it's not right to think about levels here. It's true that tariffs going down overall,
In relatively more.
but you have to think everything in relative. Remember, have sector fixed effect, have country fixed effect. So you have to think a double relative. All right, what else? Well, you could think that the key thing here is sort of diffusion because of the input-output connections of firms. So then it could be the case that the results just coming from the fact that the tariff on my output is correlated with the tariff on my input. So here what we do is we add input tariff, average input tariffs as controls, I still get the same thing. That's not what explains the results. I also could think that the results are being driven by tariff against Brazil and not Brazil tariff against other countries. Also add that as control, doesn't change anything, right? So what yeah.
But you cannot rule out the possibility that after trade liberalization, the more knowledge is embodied in goods. So the way of transferring knowledge gets changed.
Yeah, we are measuring here a particular one, that what shows up in citations and technology transfers. Yeah.
Do you observe productivity or anything that looks like productivity?
We observe average wage, which should be correlated with productivity, but the difficulty here is that there's no country of origin in average wage, and this is a gravity equation.
No, the Brazilian firm.
Yeah, for the Brazilian firms. We observe that, but we can discuss that further, but the difficulties here is that cannot assign a country of origin to an average wage of a worker in Brazil. Cannot write a sort of a gravity equation for that, which is very important for the identification here. All right. So given that results, what we want to do, we're going to write down a model to rationalize these findings, explain where they're coming from, and make some aggregate counterfactuals. We want to know how important this is. And this model is basically, we're going to take Buera and Oberfield, and we're going to add one channel, which is this technology transfers. So this is how the model is set up. There are 3 countries, Brazil, a high-income country, and a low-income country. There are K sectors, small k, and S in a continuum of varieties. there is a representative consumer in each one of these countries that consumes all the goods. And production follows this linear technology. So you have labor use in variety S, and then you have the productivity of that variety in country I, sector K. So the main trade-off here, the most important one, is the one that firms in the developed country are making. So those firms, they have to choose between transferring technology to Brazil or exporting directly. If they export directly to Brazil, they have to pay a nice back trade cost. And then they have some productivity given by QX to produce. If they transfer technology to Brazil, they have to pay an iceberg transfer cost, which is given by the cost PQ. And then they have a productivity given by Q, T, KS. And they capture all the profits of the service. So they make a take it or leave it offer to the Brazilian firm. And these two productivities, the productivity of exporting and the productivity of a technology transfer, they are joint free share with coefficient given by whole. So the distribution of the highest productivity follows the standard functional form. You have lambda here, which sort of the level of the productivity is very important parameter. You have Z, and there's a free share theta parameter there. And then the price that firms are facing follows the standard two-stage pricing, and it's going to be given by the minimum of these four options. So it's either that variety is produced in Brazil with Brazilian technology, so its wage is Brazilian and the technology is Brazilian, or it's produced in Brazil, but using a technology transfer to Brazil, a foreign technology. Or it's produced in the high-income country, exported to Brazil, so then it's facing the wage of high-income country and the productivity of exporting, or it's produced in the low-income country, all right? And lambda here, which is that parameter over there, is gonna grow according to the exposure of Brazilian firms to foreign ideas. So Brazilian firms are learning from foreigners.
And they're learning from sellers, from the story you tell in the data, you're learning from.
Learning from two ways. They're learning from exporters, and they're learning from technology transfers. If they learn from exporters, they have a contact rate with exporters given by this expression. So you have, this is some parameter, and this is the share of varieties produced by exporters in Brazil. Now, so they might meet, might have a contact with the technology licensor. In that case, technology licensee, the Brazilian firm that has a foreign technology. In that case, that meeting rate is going to depend on the share of varieties that are produced with technology transfers, with foreign technology in Brazil, and this omega T. This omega T is sort of how much more you are likely to learn from firms using foreign technology in Brazil.
The second one, I would think it more broadly, you're learning from domestic producers. The domestic producers could have domestic technologies, foreign technologies, that's it.
Yeah, we have played with that before.
In which case it would be trying to have to affect one, maybe there's less transfers, but maybe the selection of domestic might be better.
Well, we thought about that, but we decided to go with this simply to highlight our channel, which is this technology transfer channel.
But your channel would be a subset
of learning from everybody.
From domestic. In fact, domestic gets better because they get to license foreign technologies.
Exactly.
And maybe if you only learn from domestic producers, the only reason why you will learn it because there's transfer. If there's nothing with the transfer, you're never gonna learn the Nippon technology.
Yeah, that's another way I think to write it. Then you learn technology transfer good because it shifts the productivity of the guys that you're learning from. That's another way to model it. Yeah. All right. And then you have the arrival rate of insights, which is given by this functional form. And then you have the new idea or the new productivity, which is given by the combination of the old productivity, beta, and some insight. And when you solve this model, you get to this expression, which tells us how lambda is growing. And that's very important because it's directly related to the growth rate in the economy. And here shows our contribution. So we have two terms in here. The red one is the one related to technology transfers. This is new, and this is Buera and Oberfield, basically. All right, so what we have there, this term depends on three things. So the first one is the omega t, which is the meeting rate with firms that receive technology transfers. And then you have here pi t, which is the share of varieties produced with technology transfers from the high income country. And the final one, this expectation, is sort of the average quality of technologies transferred to Brazil. So what happens in this model, when you increase import tariffs, or increase the iceberg trade cost, and then technology transfers to Brazil are going to increase because firms are facing that trade-off between transfer and exporting to Brazil. So the share of technology transfers increase and the share of exports decreases. How that affects growth rates is going to depend on parameters, omega t and rho, be more precise. And what we do to calibrate these two parameters, fortunately, I cannot go in detail, but what we do is we take the model, we generate in the model the same tariff change that we observe in the data. We run on the model the same regression that we run on the data of the effect of tariffs on citations and on technology transfers. And we calibrate rho and omega t to match these two numbers. The effect of citation, the number of technology transfers, and the effect of the effect of tariffs on the number of technology transfers, and the effect of tariffs on citations. And beta, which is another important parameter, we take from Buera and Oberfield. All right. So what comes out of that?
One thing about the model,
Mhm.
does the licensing reduction, is it fair to say that it looks like just like greenfield FDI in this model?
Yeah, you could say that. So a way to think about FDI, I would say is this. FDI, so you could open up these productivities as the technology, management, and sort of ownership. Here is in the location. Here is produced in the high income country with high income country technology and high income country management. This would be produced in Brazil with Brazilian management. FDI would be produced in Brazil with high income management. There is that aspect of it. But other than that, sort of more conceptual difference, you could call this FDI, everything would go through. I would just think that the parameters that you should calibrate this model to should be different. Yes.
Is it obvious to be the same for licensing and for trade?
No, it's not. I don't think it's obvious, but you know, we have a limited set of targets that we can get from the relation, so we have to tie our hands.
And is it worthwhile going through the trade volume as well? You go from tariff to technology transfer directly, but from tariff to actually trade volume, is that?
So what do you mean on the?
No, like the tariff changes, but in the data, the trade volume.
Also change. Oh, yeah.
Away, and then here you are not talking about.
Yeah,
trade volume.
I didn't talk about that on the paper. We calibrate. We take the trade losses from some number that people have used before. So we are reproducing the standard effects. All right. All right. So what comes out of that? So let's do the following counterfactual. At 0, we are gonna do the full the trade liberalization that we observe the Brazilian government doing, right? So this is the effect on welfare. So what happens here at 0? Now all the imported products become cheaper. So there's a welfare gain from that. But remember, technology transfers goes down, and Brazilian firms, they learn a lot from foreign firms and from technology transfers. So slowly then, they learn less. They learn less because technology transfers decrease. So then, in the long run, the gains from trade are smaller than they are in the short run. And that's very different from Buera and Oberfield, which would be setting omega t to 0. Here, what happens in their model is that you have the gains from open up to trade. Now imported products are cheaper, but also you learn more from foreigners because you learn from exporters. But here in our model, that's going to differ because you have taken into account the fact you are learning less from technology transfers at the same time. So then there is a sizable difference. And this is a final exercise that we make, which is what happens if together with a trade liberalization, we subsidize technology transfers. Technology transfers have a spillovers because other firms learn from it. So it's underprovided. So it should subsidize. So at 0 here, we have the trade liberalization only without any subsidy. In green, we have this liberalization with the optimal subsidy to technology transfers. So it's costly at the beginning because you have to pay for the subsidy. And in the short run, we have no gain because firms haven't learned yet. But then slowly but surely, firms start learning from the technology that they see around them, and they become more and more productive. And here's what happens if you only subsidize technology transfers. And then you can see that this is where most of the gains are coming from. So this is the effect of optimally subsidizing technology transfers.
So are you financing these subsidies or?
Yeah,
Okay.
you have to finance it. For lump sum.
Tax.
Yeah.
I have questions. Can you observe the outcome level, for example, from sales in your data? Because it seems you assume that if you have technology transfer, you can have better productivity increase, but this is your assumption. You can learn more from exporters.
No, I agree with you. So we have no way in this paper, we do not test that, but we build on some other papers, like my own paper, that shows that when you make it difficult for firms to get technologies, foreign technologies, there's a large decrease in firm size. And also other papers studying technology transfers in China and Russia, and they find the same type of result. Every time they impose barriers to technology transfers, firm TFP goes down. So we are building on that idea. All right. So why do I think that when you get to referee this paper, you should say accept? This is why I think that. Because before this paper, the insight that we have was that when you open to trade, you get exposure to foreign products, and then you sort of reverse engineer, and then that leads to diffusion of ideas. So that was our main way of thinking. Probably you guys had as well 1 hour before. And that's extremely important because it has implications to policy. Because that means that trade openness leads to growth. What I tried to convince you in this last hour is that maybe this is not the full picture. Because one other thing that's happening is that when you increase import tariffs, firms are going to jump that import tariff using technology transfers. And that matters for local firms in Brazil because that leads to diffusion. So then if you want, that has also implications to policy, which is if you want to reap all the benefits from trade liberalization, you need to subsidize technology transfers together with the trade opens.
And there are a set of evidence that you may want to look and explore, like the work by Shake Clean or with NAT and their previous paper in the US, Canada trade. They have a set of implications of learning from sellers. They are talking about the global view of trade destruction. The effective is an exploration of learning from seller channels. And they look at churning of sellers, churning of exporters and not, and that models of idea flows from sellers or from exporters, as you call it, has very strong implications on those patterns. And they argue that if you move away from those channels, you will have very counterfactual implications. So we'll explore those implications, that they rely more on the identity of who is selling where, and whether those sellers or those exporters are very persistent and not.
So which paper is that?
No, there are two of them. The last one is the global view of the
Pretty
structure.
small.
Ah, all right,
Shifting and mass,
all right.
and literally they're like. Yeah,
So I have more 5 minutes, so you guys have more questions?
Yeah, I was just wondering from a policy point of view, your counterfactual of subsidizing technology transfer, how different would that be relative to providing subsidies, incentives for foreign firms to come and locate in Brazil and then rely on that diffusion mechanism?
Sort of FDI, you mean?
Yeah.
Yeah, so I don't have much to say about it because I do not find an effect on FDI in the data. But others have shown that FDI leads to diffusion, so I imagine that it's a similar application.
Yeah, no, I guess that's sort of maybe, so I can just rephrase, like, I'm wondering, like, could you, with your model, create that counterfactual? Because I'm just thinking that's probably an easier policy for a government to try to implement, is to provide FDI subsidies as compared to providing subsidies for technology transfer. So I'm just, are you able to incorporate that in your models and additional counterfactual?
So yeah, so the model doesn't have FDI, and the way I think, you could potentially do that on the model, but then you have to assume that the diffusion of a technology transfer and the diffusion of FDI, sort of the same. So there is an omega T on the model regulating the diffusion, calibrates the diffusion of technology transfers. My belief, and I don't have any evidence for that, but my guess that it should be different than the diffusion of FDI and the diffusion of technology transfer should be potentially different. Because technology transfer, you teach a local how to use your technology, and is your technology being used by someone else, maybe they don't care as much if it diffuses or not. So I cannot do that.
So if you're just focusing on patent citations and the outcome, you could do this for all countries, right?
You
There's no
could.
reason to just focus on it.
Yeah, technology transfers I do not have for all the countries, but I'm working on exactly that and getting that data, and yeah, maybe in the future I have another paper on that.
If a firm learns by reverse engineering, do they have to cite?
I imagine so. When you create a patent, you have to cite the patents which are most associated to it.
What does it mean by reverse engineering then? Because you could just look at the patent.
Yeah, I mean, I don't wanna get stuck on the reverse engineer part, so that's like, I mean, I think the idea of people working on that was like, you just figure it out by looking at the final product, how they create it.
Because I only ask, because if the alternative is they reverse engineer, if that doesn't show up in the citations, then.
It could if you create a patent, right? It could if you create a patent and then you cite the ones that are most associated to you. And the way you learned how to do that technology by, taking a car, breaking it to pieces and figure out what goes inside. So I would say you should cite the ones that are most similar to you to show up there. All right, so we're finished early. Thank you guys.
I'm saying we will take a while to set up.
I'm sorry.
Yeah.
Again.
Yeah. I could also say. Yeah, that's going on, living around. Yeah, all right, so I think that because we receive, I think this. As an empirics, it's like.
Okay, let's keep going, so we go. We haven't got, Felipe? I think you have to touch it. Why not? No?
No, have to touch it there. Click in the.
No, here.
Click, yeah.
Okay, well, first of all, thank you guys for putting the paper in the program, and it's a pleasure to be here. The paper is joint work with Laura Alfaro and Marcela Slava, Martí, who's here, and myself.
as a believer in division of labor. You have a guy who's very skilled at answering questions. Okay, so here we go, jobless industrialization. So there's this idea, and many of you guys in this room have documented these facts, that there's in these developing countries that are entering late to the process of modernization, there's been an important inability in scaling the creation of modern jobs, okay? There's these countries that only have a low or middle income, but there's prevalence of high degrees of informality and self-employment. And the firm distribution, even the big firms, are relatively small compared to what you observe in rich countries nowadays. And this is quite acute, especially when you think about size in terms of employment. And the middle class is rather fragile. It's not very resilient to shocks, in part because we don't have this large mass of modern employment in these countries. And our take on this is, this has been a common thread to what we call, or the literature calls, late starter countries. When I say late starters, I want you to think about countries that are embarking this process of this process of development relatively late compared to the pioneers of the Industrial Revolution. And we argue that these features do trace back in history to this idea of jobless industrialization. And I'm going to show you what I mean by that label in a graph. But there's this idea that unlike early industrializers, unlike Great Britain and the US and alike, late industrializers have had this process of industrialization without creating as many jobs, and in particular, many modern jobs. So here is one of the main stylus facts that we're putting forth. So here in this plot, what you see is the employment and value-added shares of early starters. Again, think about these as the pioneers of the Industrial Revolution. And what you see, and this is something that has been documented in the literature of structural transformation, is that where you measure structural transformation via employment shares or value-added shares, you get, roughly speaking, the same figure, okay? Whereas when you think about late starters, okay, conditional of having this take of now these countries be embarked in this process of industrialization, what you see systematically, this is an average of late starters, but if you break this into countries, you do see these patterns quite well. It is that there is an important size of the value added, and importantly, it is just comparable in terms of shares as what we had in late starters. So 26, 27% is not off, but when you look at employment, there's a big gap, a big divorce between the employment shares and value-added shares. And then these late starter countries in their path of development are having fewer employment and employment shares in the manufacturing sector relative to early starters. So our take is, let's think about Colombia, which is, there's two important reasons for choosing Colombia. One, it is really a representative country for this phenomenon. Okay, it is a late starter country that has had an important rise in the manufacturing value-added share, comparable to the stylus facts of early and late starters, and hasn't had much more employment in this path. So you see that there's this big gap between employment and value-added, what we call divorce, and it is about twice. It's about the value-added share is about twice as big as the employment share. But very interestingly, and reason number two of why Colombia is an interesting place is that we have very good data going back in time to this peak of industrialization to dig in on this idea of what's happening between this dimension of production between traditional and modernity. And in particular, what you see here is across sectors. So first of all, this comes from the household surveys. Sorry, I forgot to say something very important. We're very grateful with STEC for funding these because we were able to get these numbers by using the resources. So what you see here is that, think about modern as where a firm operates with 10 or more employees. Modern firms are predominantly in the industrial sector, okay? 71% of the value added in this sector is in modern firms. And you see an important gap between the value added and employment. 53% of the employment takes place in more sectors.
Sorry, is it household survey? You have like, did you compare it with the firm level survey? Because from my experience, household survey focus on measuring welfare indicators. And when you compare it to firm level survey, especially on economic activity, you see like right difference.
So we don't have firm level data for services or agriculture. And that's part of the reason why we just go and look at these numbers in household surveys to be able to have a picture of the entire economy. But we do have all data on industrial, in particular manufacturing firms, more manufacturing firms, and we do have some complement evidence, and that's exactly the evidence we're going to use to estimate the production function. Okay, they're very similar. It's not one-to-one, of course. And if you think about the shares based upon the annual manufacturing survey, the picture you get is roughly similar, but it's not 100%. So in that sense, you're right. But there's just no way of doing that here or here.
Formality defined as.
If you are not operating in a firm that is below in a small firm. Okay.
Size.
Yeah, it is based upon size.
If you were to, I mean, an issue here is that you're using employment as size, that would be more of a measure of value added. Right? Or considering
like sales and
you're looking at the gap between value added and size and and employment, and you're truncating using employment as size. So really you should do an alternative figure where you truncate using value added as size.
Okay, that's a good suggestion. Yeah, to the degree that we can do that, because unfortunately, the annual manufacturing survey as well truncates starting from the employees and above. So we cannot do that in that, okay?
Yeah.
But we could do that, something like that from household surveys. Yeah, thank you. Okay, so jobless is happening, and it is predominantly happening in the modern part of the economy. And in particular, if you see like the numbers in agriculture, you do see a little bit of jobless as well, a little bit not substantial jobless in the modern part, not so much outside in traditional. And services, you don't see much in traditional. You do see this aspect in modern part. So the main takeaway of this plot is that we focus on manufacturing because it is really the most important part to think about modernity. But it's really a story about dual production between traditional and modern firms that happens to be anchored substantially in manufacturing. Okay, so now we have this fact of jobless. We go on about trying to figure out this in many ways. And now the question is, how can we understand this fact specifically for late starters? And there's many options. One way to think about this is that there's so many distortions, and in particular size correlated distortions that affect predominantly born firms, okay, particularly highly productive firms. But also there's other type of distortions that are independent of size. Think about minimum earnings requirements, okay, that really bring some important segmentation. Now, probably all of you already have the tentative answer to this path, which is, well, naturally, as these countries start late, the stock of ideas and the stock of labor-saving technologies available are out there. So there's no reason for them to create as much employment compared to their early starter counterparts. Okay, and also whether their human capital endowments are inadequate for this modern employment. Our takeaway is that all of these are plausible, but we really need to think about it in a quantitative form, which are where the mechanisms are operating. And in particular, if you really want to think about the role of distortions vis-a-vis the role of technology, you do need microdata to be able to estimate parameters of production and disentangle what's technology and what's.
So how would you think about selection due to foreign competition? Like maybe for early starters, they're mainly industrializing to satisfy their domestic needs. There's no, like they are the work frontier, but for late starters, they have a work frontier to catch up. And if we live in an open economy, only the best firms could produce.
So let me answer that we don't live in an open economy in this setting, industrialization by substitution of imports. So we don't have to tackle that openness part and that selection via open, and I'm not going to have that. maybe we can talk a little bit about that in general and how this selection is going to increase productivity. But if you think about selection, basically is going to even deepen this. So if you are exporting, you have access to broader markets, number one, but also you have to be very productive and those, you need to figure out which one is there. But there's nothing happening of that here. It's a closed economy setting, correct? Okay. So in this paper, well, the first part is we document this job list industrialization, which is happening in late starters, and it is driven by larger, more productive firms. Then we developed a general equilibrium occupational choice model where we have multiple sectors and firms operating in either in traditional or in modern settings. And with this model, this occupational choice, our objective is to provide a quantifying margin on several channels, where it's productivity, technology, or the endowment of human capital. And a key aspect of this paper is that we leverage our findings by going into detailed historical microdata from Colombia that happens to go all the way till 1971, which help us to really disentangle these forces at the peak of the industrialization, okay? And to estimate idiosyncratic distortions and let's not use this word right now, and discipline model parameters, okay? So this is still work in progress, and I don't want you to get out here with some order of magnitude, but mostly with the size and the direction of the mechanism. But what we're finding is that distortions are really, really important to understand this divorce between employment and value added. And in particular, so a country that starts, this is the basic intuition, a country that starts late has access to these labor-saving technologies, but also is embarked in all these regulations and all the distortions and all the social policy, okay? And we find that those are very important in order to understand this gap. So, but importantly, if you shut that down, if you shut down all these distortions, you still have some capacity for technology to explain something about this market, okay?
The distortion is not necessarily a feature of the lateness. The labor saving is more a feature of the lateness. The fact that there are distortion is a feature of the country's policies. That doesn't come necessarily attached to lateness.
Yes, we agree. And for instance, if you think about the case of South Korea, it is a country that started late but had a completely different array of distortions and policies. So it is a policy choice. But in this case, it was highly distorted.
Happen to be correlated with lateness.
Yes, exactly.
Historical reason.
Yeah, it's not historical determinism that you're late, you're distortion.
The distortion is the late thing, still, right?
Yeah, that could be called.
Sorry, can you repeat that?
I mean, the causation could go, it could be that the distortion is too late.
Due to lateness.
The
Dynamic model,
Yeah, we've been playing with some ideas with Hansen and Paretos and barriers, but none of that is here. Yeah, that's a good point. But yeah, it's a policy choice for sure. It's not like determinism by being late. Let's go with the model and see how far we can get. So the idea is we're going to have a model that helps us to understand allocation across resources, both in agriculture, manufacturing, and services, and in modes of production, where production takes place in either traditional or modern settings. Okay, it's going to be driven by technology. We're going to be specific about what we mean by that, and distribution of talents and institutional environments. So think about these endowments of the draws in the occupational choice, production function parameters, and regulation, distortions, and alike. And this choice is going to be constrained by the setting that we have in the occupational choice. And we're going to use this model to provide a horse race of what's the role of productivity, the technology parameters, what's the role of the distribution of endowments, and the role of regulations and allocation. I'm not going to talk about this today. So very briefly, we have three sectors, the broad sectors of the structural transformation: agriculture, manufacturing, or industry and services. And agents' occupational choice is independent of the economic sector. They care about working, but they don't care about where to work or where to operate. What they do care is where they operate a traditional technology, which is self-employment. Don't think of this as the quintessential entrepreneurs in rich countries. Think of this about someone selling food in the street on a livelihood, self-employment. Or salaried work, this is an employee with all full firm benefits, or you become a technology operator where you become an entrepreneur and you hire people, right? You hire. And if you enter modernity here, you're gonna abide by regulations, and in particular, you're gonna abide by minimum earnings. Think about minimum wage requirements, which are independent of size, and size correlated distortions that really depend on how big you are. I just said the same thing twice. All right, endowments and occupations. This is what I'm talking about. The agents are endowed with two types of abilities. One, it is this heterogeneous, think about productivity. This is the Lucas span of control, all right? But the new part here is that there's also a heterogeneous ability to produce different more varieties. So think about all these discussions, we're talking about entrepreneurial capital and this capacity to sell more. And that's gonna be only useful provided that you become a more entrepreneur. Other than that, there's nothing there. And if you become a more entrepreneur, you're gonna face labor and revenue distortions, all right? In a more complete setting, you're gonna have also capital distortions, not in what I'm gonna show you today. And each agent is endowed with 1 unit of time to either become a self-entrepreneur, earning a self-employed, become a former worker, and then you're gonna work so long as your command wages are above this bound restriction, which is the minimum earnings, okay? This is what drives you into formal employment or keep you into traditional technology. Or you become a more operator, and what you get is the profits of this firm, right? There's some monopolistic profits here. We are going to play with distortions, and we're gonna collect these distortions, and we're gonna trade them back via lump sum to the agent, because that's basically the fairest way of allowing distortions to play some role rather than throwing to the ocean. But you can do both, and we actually are playing with both ways. So here is the setting. This is the preferences at the aggregate level. So very basic CES with gross complements in agriculture, manufacturing, and services, okay? But here, each broad sector has this capacity to be producing either with more units or traditional units. And these are substitutes, and the degree of substitution is going to be governed by this parameter rho. And these are, there's not much, there's no heterogeneity in the production of traditional goods, but in modern goods now, we're going to have this broad range of variety where there is this capacity to produce more technologies here, more goods. But here comes that appeal that I talked to you about, that draw of the literature calls it appeal, but you can think about quality. It's going to be part of this modern production technology in the differentiated varieties within modern sector. And these, of course, are substitutes. These are substitutes, and within this one, goods are substitutes as well. Okay, technology. For now, we don't have capital, but you can think about this in a capital setting. Here is the modern technology that has decreasing returns to scale. So this gamma is going to capture the capacity to operate labor-saving technologies. Okay. If you don't like this, well, this is really almost one-to-one to think about capital, where you have capital and labor, and the whole point is that this gamma is going to tell you the marginal decreasing, the marginal, the intensity of labor, and this is the modern production. You just eat your aim. Okay, so that's the difference.
The difference is if you have capital and your margin per labor actually is very high, it's hard to have a very small workforce. So to me, you say it's the same thing, but to me, it could be very different in the sense that this is a decreasing return on labor versus if you actually bring capital. The modern sector is more capital heavy than one force that you raises margin per labor, so you actually increase.
Yes. Yes, and what maybe I wasn't very clear, and what I'm saying is that with that you can capture that into a number for this gamma here. Okay, and that's exactly how we discipline. Like think about there's a production function with capital and labor that's going to tell you okay, this is almost as if this is a decrease in returns to scale technology and labor. But yes, exactly, you're absolutely right, yeah.
But just I will argue that you may want to, the gamma here, dimension return is more a statement of an entrepreneurial input, not a, because capital and labor can be adjusted in the long run.
Okay.
The fact that you choose to have diminished returns, that you're thinking about there being an entrepreneurial input, not about there being a fixed entrepreneurial input.
Okay.
Not about reduced form for capital.
Okay.
Because capital and labor are variable factors. It's fine to have diminished returns, but the diminished returns are a statement of a fixed factor. We say that a statement of either a fixed entrepreneurial factor, a fixed land factor.
Okay. Whereas with capital, you capture, you go back to returns.
You just it's a variable factor.
Okay. Okay.
I thought about having like intermediate inputs.
We do have in the estimation and we have materials.
In the model.
But in the model, these are value add.
Because that might have that could have implications of how large the impact of distortions would be and not
through materials.
Through
intermediate input. Okay.
Or through capital if capital were to be produced with the final aggregate.
Okay. Okay.
That would make a difference.
So
and they might have a role in terms of M and T technologies.
Okay, so that's
whether they will be different in terms of the intermediate input share.
Yeah. So with capital, we've solved this model with capital, and we have distortions for capital. In this position, we just throw everything into here. But that we can go back to easily have this position with capital for these reasons, for the constant returns to scale. Thank you. The other stuff I need to think more about the inputs. Okay. So running out of time. So let me just skip this part. So the idea is you're gonna have from inner to outer-ness, you're gonna be able to solve the demand for agriculture, manufacturing, and services, and you're going to be able to increase entrepreneurial function, and then you solve this with a market equilibrium that determines the W. Okay. Let me just show you how do we quantify this model? Well, the first thing is using the annual manufacturing survey that has all these modern firms in manufacturing. We're able to estimate this gamma using the capital and think about this thing, and this elasticity of substitution using this AM. But that only gives us to the extent that talent is allocated into manufacturing. So to supplement for the rest of the economy, we discipline the overall distribution of A and D using the workers from the household surveys to find the entire economy. Then we make this calibration. We make guesses for the CS weights and the parameters to be able to discipline the equilibrium until we get convergence. And we're after mapping the jobless industrialization and the aggregate moments of employment and value added share, and some moments of income distribution that I'm not going to show today. So just in a nutshell, this is the revenue function, okay? And this is what I was telling that I'm not using to a capital, but then the key part is that we can disentangle this quality adjusted productivity into what comes from this entrepreneurial ability and what comes from this TFP as we think about, and then the size related distortions on revenue, capital, labor, okay? And then this is gonna be able to map what's distortions and what's productivity. And one comment is that, sorry, these parameters, we cannot identify their levels, but their variation. So we can identify the parameters in green, okay? but not the parameters in red. So we can, the dispersion of A, but not its level, the dispersion of B, but not its level. Okay, that's a technical aspect here.
What exactly does the dispersion of these D's do? What do you need those D's?
Oh, let me show you in a second. The next slide. So here, these are the estimates of production function, which is the gamma is capturing this idea of decreasing returns to scale. It is labor saving technologies, or if you think about the capital saving, it's just the marginal, the input elasticity of capital, of labor. Okay, and we find that goods are substitutes here.
Just so I know, which of these parameters is time varying? Does it seem like any of them are time varying, is that right?
We don't think of this as time variant, but we think we can estimate them across different periods. And what we find actually is that this gamma seems to be similar, even if you use 1 decade or these 5 decades, but we're not thinking of them as time variant.
So the thing that varies, the gap between value added share and labor share in industry has to be the composition between modern and traditional. And then the distortion is going to sort of move that. Is that kind of what's going on?
Yes, exactly, yes. Okay. Now, to answer your question, so when you have this residual, it's very it is correlated with the dispersion that you observe in A. Here is the correlation between the residual of the productivity, the broad productivity, and this A, but it's much more strongly correlated with this D, with this quality appeal. So this dispersion is help us to think about the selection that entrepreneurs are getting into more jobs because they have this big D and they can profit out of that. Okay, and it is quantitatively, it is very important. Okay, and also in these cross correlations, what we find is, I'm running out of time, is that although when you do the capital, labor, and regulations, the capital distortion seems to help big firms. Firms are, they have this capacity to rely more on capital markets, but that's nowhere near close to compensate the negative distortions that they face by employing and the revenue distortions. And the composite distortion is negative. So firms, big firms are heavily distorted against. All right, the calibration, so, and some counterfactuals. This is the summary of both parameters. We do a non-parametric fit of the distortions. Basically, as a function of this A and D, we discipline the revenue distortion and the labor distortion. And I think I already mentioned all of these. Yeah, I'm gonna skip this. These are the external parameters. We've been down this epsilon, the complementarity, 0.2, exogenous the fixed, and we have this calibrated rho of 1.25, which seems to be a little bit small compared to the literature, but we're still playing with this. And now these are the parameters to think about the allocation between agriculture, manufacturing, and services. And once you have that, how you allocate within modernity and traditional inside of agriculture, manufacturing, and services. And obviously, this is a very important weight as discussed in the status facts, because there is an important prevalence of modernity in the industrial sector. Okay. And with that, the only thing that I want, I'm running out of time, let's focus just on this part. So on the baseline, we captured this gap between more unemployment and more value added, which is about 2 to 1. And we play where we just lift all the distortions in the economy, and indeed we close this gap. Okay. In our work that other numerical examples, we don't close the gap entirely, so we're still working on this. But it is very sensitive. Once you lift up the distortions, you increase substantially the employment labor. Okay, the employment in modern sectors. And very interesting is the bulk of this distortion really comes down to these minimum earnings. When you really shut down these minimum earnings, what you do is you have the selection channel shut down, whereas the other ones have an important effect, but not nearly as big. So these minimum earnings distortions quantitatively seems to be very important. And yeah, that's what I was going to talk to you. And last, why so important these minimum earnings? Because that really is the one that operates through a selection channel. So essentially, when you don't have minimum earnings, you have people earning exactly as much in and out of traditional sectors, as you can see here. All right. But then when you have this monitoring, then you have this selection where only the people that are above the threshold are going to be able to operate the modern economy. And then you have this mass of the lower tail distribution in traditional sectors, okay? Earning less and that creates this distance. So 1030, let me just replace this by saying this is still work in progress, so I don't want you to hold me accountable for this slide, other than we do find that distortions seem to be quantitatively very, very important. This is not just a late starter, access to labor saving technology, end of story, okay? And going back to your point, and that's a policy choice. That's a policy to really think about differences in late starters.
You guys will go back to how much of these distortions account for these sectoral patterns, how much they feed into the overall development gap of Colombia?
We've not done that.
It would be nice to have a sense of how much of these patterns or these differential patterns relate or support living by policies feedback into development gaps.
Yeah, we've
the
not,
large part, the small part.
Yeah, we've not done that by this time. I think they I don't know if you recall, what we've looked upon is how the distribution of human capital and what was that gap on that aspect. And but yeah, we certainly can put all of them together. Yeah. Well, thanks for listening to this thing, and
we have a break. Quite a bit of time for discussions now, so hopefully.
If you change the distribution of human capital abilities, I think that there's a bunch of people who don't have a human capital and just have low ability. Would that replicate these numbers as well? Would it work like, would it show up as a wedge?
Yeah. The distribution, of course, matters. Okay, both where is located the distribution and how dispersed it is. They do matter. We play with this current factor. We increased the human capital endowment distribution by 25%, keeping the distortion fixed to be able to get out, but that's not nearly enough because the gap between it's like 3-to-1 between the US and Colombia. So it needs to be much more, and certainly we just do this, but this would lead to a much more interesting set of results. But yes, it does have an effect to the point that you can really shut this story by just endow this economy with much more human capital. Yeah.
Sort of missing it. So what did you use to separately identify A and B? Use prices or something?
Oh, yeah. So this comes from the annual manufacturing survey, which has prices at the establishment level. I'm not 100% sure that I'm saying that right, but you have idiosyncratic prices to be able to capture TFPQ, okay, and to disentangle. Once you have the TFPQ, and once you have, when I use this question to say something interesting, the labor part, okay, we have how much people get in their pocket, their earnings, and how much it is the cost for the firm. And the distance is the labor distortion, because you have to pay a lot of extra gadgets to the worker to be able to operate more. So with that, we can discipline the labor distortion, and then via personal conditions that gets the capital distortion and the revenue distortion. And once we have all of that, then with the residual, we get the D. Okay? But again, the dispersion to the extent that we can discipline this.
Of course. I mean,
yeah.
you repeat back. How do you separate aren't KNL, so you have three distortions, right? It seems like you have two movements, which is like ARP and ARPK, right?
Yeah, exactly what I just told you. From the data, we have the gap on the payroll, how much the firm
Okay, I see.
pays to the worker and how much the worker receives.
So that gives you the third.
That's it, exactly, yeah.
Let's continue discussion over.
It's gonna be a long break now, but it's very vital.
Yeah, thank you. Does that answer your question?
Yeah.
Okay, it will be bad. So some people will give a chance. Yeah, over here.
Not very interesting. Danny, what did you ask to? Yeah. You see my stuff. You see what else? Probably. Oh, I agree, but not just for technology. For this, yeah, that would be the, because to some degree, yeah. What are you gonna do? Use less inferior technologies? That genie is out of work. But then when it comes to regulation, now from the development path of Africa, well, you see these Latin American path, you don't want to follow it, but it was heavily regulated with good intentions. Like many monarchies are. Yeah, yeah.
So the bill started this way.
Because our point is, you do this without microdata, go to national accounts, do the capital income share. Everything you're gonna assume is technology. And our point is like, no, because inside that stuff, there's gonna be a lot of regulation aspects of that.
No, what I'm saying something else, it's like the different is. Yeah.
Thanks for your question.
You see this difference between also family, but it's good that for the quantification you use for the. I thought you were going to use
we do, but to the extent that we don't have firm level data. Because we wanna track down the entire economy, not just where we find.
Don't have the basic.
We continue to invest in technology.
Yeah, I would like to stress is we have data, maybe not the best data, but household surveys, they teach us a lot. Yeah.
Hi, yeah, Jordan. Really quick question, the first figure you showed, that was for many countries, right? You had a line for each set. I wonder if you could show it. Like there, would show the distribution of each set of countries. So that they go, that'd be more telling to see. But for all these low,
Think about the poorest of the poor are not there.
So if it's the case for like the whole group, their share is less. Do you know what I mean? 'Cause right now we're just being the average, there could be a lot of overlap.
Yeah.
You can show that in there.
So, because there's not that many countries, I think it's more insightful.
I couldn't put all the lines on one, right?
Something like that, but the problem is that, yeah, you can do that. I've done that, it's noisy, you don't get it. But the pattern that you see in Colombia, when I have the figures in the computer, if you want to see it.
That's relevant. Our productivity is going up, but then when you do the counterfactuals, like I didn't include that. It's like, we have to take this opportunity. So it's something to do with ideas, it's something else that we're not really modeling.
Because maybe you can help me.
Yeah.
I would like you to.
I see, or present it. It's just like we don't.
Yeah.
So the average is something that.
If you cut it down.
It's a nice message, I want to take two exporters. We have.
By non-exporters, or importers.
I'll show you
Export.
So
Brazil.
So right now,
You see? So the value add. Yeah. Okay, so
With tariff.
more about. Yeah. And I go look at emission. I have to think about like, the average that sometimes takes where the moment. Then
There's a particular code.
it's not calendar time.
Within.
All of that. Like the narrative, when I like about it. I think it's quite fair. So you see, it's systematic. The Japanese, yes, because it's late. But then I said, we don't think of this as a structure, because yeah, they need to, our first one is 20%.
Yeah, because that's a particular country.
Yeah.
You can tell me.
But again, it's like,
That
how much?
Because you can think that there's a ton of.
20%. It's not enough.
And it's not right, like a graduate.
This is the early starters in Ireland. I wouldn't hold this.
Would also pick that up.
But
The fact that you're writing about it. I always say tariff, particular country. Right now, citation.
And this is very close because this is one of the early starters. Okay, Denmark, France, you see? So Italy is the best example of it because it's really one of the first countries
I think
that version called.
it's because, we still have a saying in Brazil,
Late start.
which is Brazil is not for
What is late
beginners.
start? It is
Means that
adopting.
There's so much institutional complexity in Brazil that
And you
if
see,
you're not Brazilian,
like they're
you cannot deal with it.
some
Very high barrier.
kind of like
That results wouldn't be true.
absolutely, and smaller than Colombia.
That's why I'm working
Now, but let me just finish with the most interesting stuff. Rising points like Colombia. But then at some point, they're just dropping points.
Without showing the regressions without
These guys really play the game in important points. They have the everything else available. But they make the wages, they kept them super low, and they have a massive exodus of workers into manufacturing. And it's like almost the same story that we're playing, but with the opposite side. Okay? Which is how distortion really helped this industrial growth for this whole thing. But then I don't want to.
They kept the wage low and in the long run it's helped the margin.
I don't think it's a good thing or a bad thing. It's a thing because the question is whether you really wanna spur industrialization or it's just jobs. When you ask this generation, right? It's like, yeah, we need you for the future generation. And basically take away all the productivity gains and put it into factories production. So that's what I'm saying. It's good thing, but I think that it is certainly.
They always have like one of the labor savings.
It is.
We have more time.
Or it's more efficient way of doing it. But remember that's always relative to the labor cost. So there's this idea of the container capacity to produce with certain range of inputs. And the more when the economic factors have costly. So certainly with the prevalent technology that is in Colombia and the seventies, which if we make more and more cheaper, certainly you're gonna be able to. Is that a good thing? That's That's a different, it's a normative question. We don't have that here.
Citations are there to be small.
But again, this is why, let me answer this question. On doing more than the simple average, because it's more insightful to just see. There are not that many.
Even like error bars, the average trend.
Yeah, we can do that, yeah, that's good, that's to show that they're not
Together, yeah.
So that's your, that's, now I understand what you're saying.
That would work, yeah. I was thinking that it'd be even more powerful to see the distributions separate, but they would look messy. I don't know how you can do it. Yeah, like the error bars every now and then.
Yeah.
That's what it's.
That's a good point. Yeah, that's a really good point, yeah. Like, you can pull it up, yeah. Steve Warish and. You're asking error bars to 100 lines, so that's. But I understand. Well, thank you, thanks.
Standard micro.
Yeah.
No, I understand. We did some validation exercise.
All right, thank you.
From that.
My name is Martin. My name is Martin. We just hired the technologist last year.
But because I am so like,
Oh, okay.
We are the original USC.
No, but the government
Still not enough.
Yes, very interesting talk. I was wondering this, your quantitative section seems to suggest that most of these things are broken down to languages. And I'm just wondering, do you like do anything just empirically to say, first of all, how large the burden of weight is compared to hypothetical, competitive scenario. I think secondly, maybe how well, like reality, how well the simulations are enforced.
So we have some stuff like that in terms of the distribution and how close or far from percentile the median, which is the very standard way of thinking about and nowadays in Colombia they're 95% of the median. This moment in history, it was like 20 or 40%. So it can speak. It is binding, substantial. With regards to enforcement, that's very. So there is some enforcement and not perfect, but mostly enforcement takes place in much more places.
But I guess you have the household survey, you get to see how much people are earning and you can calculate whether it's.
Yeah. Oh, I see.
And household income, like individual income?
Not too sure.
Like if you have income at the personal level, you get to see if this person works in what you call market.
They do have firms.
You can calculate whether they earn market wage.
From household service.
Right.
Okay. I never thought about doing something like that because we always like to see it directly from the firm.
I know, yeah.
You're right. Yeah. We may be able to get away talking about this.
But actually, you just said you had data on how much firms pay versus how much workers.
From the firm.
From the firm, okay.
And the other manufacturing.
I see.
We do, yeah.
Yeah, that's great data. Very interesting. Yeah, I was like.
You like to walk me together?
Yeah. So.
But then you have to think like, no, it is a subset.
First off.
Have export. That's very, very clear because the data is a bit crappy, but it goes back to the, it goes back to 88. And import has got set the next trend. I have and goes before the organization goes up to 2007.
I don't know.
Foreign firms.
So they want.
For Brazil, I don't have feedback, it's also the same in my email. More recently, you go back to dates. You want to go back to dates.
It's a tighter project, but well, I think we're gonna get any other questions. What's that? No, well, I mean, like these. Things are very surrounded with the roll call, and with thinking like either, but, you know, like. You have to get. But then for the one day, I mean, like, part of the money.
Obviously, without coordination.
Yes.
How the results, which are when you have. It was like, yeah, it was like, I don't believe anything you're saying because the back side of
But then later.
Stopped everything.
No, I'm working on that. I can tell you what happens. The same thing. Expectation goes up, if the concentration goes up, but if the concentration, I don't know what content transfer zone. Because for the globe, you don't have this, final citation goes up, but the elasticity is much more. Here we got a point.
May not be.
It's much smaller.
So it opens up, which I.
Goes up.
Or that, I think for like which time is the one I make.
My guess is that our countries each other's zero. Doesn't
That's
matter.
part of the stuff.
You don't even if I don't have a family, they're gonna expect any credit. I somewhat
Not yet.
This is my guess.
How far of the I.
But actually, don't have zero.
They're potentially single variations and potentially much more accurate.
Yeah, I'm now I'm visiting all this year, the summer, and next year I'm going
And the effect is very similar. Yeah, and then. You do the last 2 years, whether you do the elements that we
So I'm getting somebody was unbelievable
the modern technologies.
when the market is not developed technologies.
So how does that affect? Actually, you're talking to me.
The modern technologies are
The fact is that starts like.
Use them with some
That's another thing, right?
I think that's, but no, that's, I think, okay, that's, you know, getting there, which are certainly more involved in. So, I think technology.
We're like something else.
But I can show that Mark started working. Marcela has looked at those, we compiled.
Do I have to look at that, or am I going to something?
Not using yet.
I should
So
look
it
at
was more about the.
I think, yeah.
With the price became one.
Practically negative. So A people.
But I have some sense that they were becoming more regulated. So I think the key difference is that there used to be like a regulation of and then which exactly maps like. You start to see.
Right, yeah, that's the main word.
Yeah, I'll give you.
You think those people have been really willing to spend like tons of money? We don't do really negative.
Yes. But
Now it's just for me to say, Paco said, so.
You go with that first slide. And immediately my thought is that just kind of automatic? Once you start to see the gap between the value added and the labor. In our paper, in our, you cited like JEA paper.
Yeah.
But there's been a lot of people that are covered.
Now, it's a little bit different because this
We need, I
discussion
think we need
about
to
how
be
people
also the dynamics
think
of
it's
more
too
than
much.
on the giving more subsidies. And it's now like,
You know,
you know,
it's
legislative
illegal,
and
but
the market.
you do something,
And
you have to do something, wedge between that one.
Or I think that's what you can mean by the technology. Are getting more capital.
Because it still could be a factor intensive difference.
But I think.
So batteries.
That's what I told you, we want to put some.
Like this talking
I think,
use electricity.
we want degrees
to.
wages.
Yes,
And
that's
to what
the
degree
main
it's
kind
labor
of
intensive
like
you're technology doing, because those are. Maybe they give us.
Yeah,
because there's no time variation, that's what I was just figuring out.
And there's no
materials to
there's
more
no
than a lot of
factory
things.
business.
I want to say.
By estimating the capital intensity.
No, there is, it's either gamma or
The gamma.
labor is everything or labor is one.
No, but that gamma, I would argue that's not have nothing to do with capital intensity.
Are there sacrifices you can make?
Well, but that's how you-
About how quickly you can withdraw the energy?
I don't know how you do it,
I mean, I guess you
So this gamma, the number is the same
It's more.
that
you
you
want
basically think about the whole
Like
capital.
there are
thrown
different
into-
prices of
into-
plastic.
No, because
depending on the
you have the
choice.
model with
So if
capital,
you
that's a variable factor.
want to
That is-
for many hours, then.
But only in the very short run.
I'm kind of curious, my younger brother in Chicago has a.
Where you get some.
It's not a labor, it's not. Which is basically a logistics company in disguise as a waste management.
You're just saying it's return, you're saying it's returns to scale
Is,
and then
is making
It's
one
not
that
that
it's all electric vehicles.
Once you have a.
At a certain point in the United States, you have a large base of electric vehicles.
Solve out for how much.
But that's because you would have a very small.
Yeah, of course.
It's an Amazon. Like,
No, but when you saw
Yeah, but
that,
then
you do
that's all
start.
returns to
You
scale.
make a big
It's
much
only,
larger.
I think, catalyzed.
no, but it's all the equilibrium with all the capital of the
Trust.
sectors and
It's
so
not
on.
electrical capacity, like we
It's just.
we don't think a whole lot about it.
The
We have
most
like
capital that like was here.
60% of our.
I know what you're
my
saying.
state.
But,
Which is a lot higher.
So that's what we're doing.
But even because we were thinking of,
I live in the States.
now we wanna think of the
Nuclear at all.
equilibrium and the level of technology, and we are already maximizing our capital.
Yeah.
Imagine it's
So it's
small,
still,
yeah,
yeah.
so just as a fixed cost.
I've been making maybe the electricity more expensive to understand, because if we look at the numbers,
This is what we
the
call
average
with
cost of
what we're
water
working
has
with.
been going up.
You just get
The
an
US
A of
because
R.
bigger,
Yeah.
by the from renewable.
You get,
has
but
been
the,
going
then
down.
labor
Yes.
is taken to the.
Some power.
I mean, it is a cost return scale. Then labor is, got the one.
Exactly.
Yeah,
but I think when you get
The only reason we have a curvature on labor was to maximize our capital because.
Yeah, I don't know.
Returns.
That's what I was saying, that's what I was telling him. We were all saying the same thing.
Yeah, so the curvature,
There are many
at the end of the day, one reason why you have the immediate return. The curvature.
Yeah.
in capital and labor.
Yeah.
That's the same thing.
Well, yeah, that's-
So
I mean, I hear you,
you
yes,
need a lot
yes.
of space, right?
And then you say, well, for the labor will matter a little bit the capital intensity. That one I.
But you need to locate in different areas. Relative to where the power plants were today, so maybe that's one of the great.
The can be. It's an intermediate with intensity.
We do have intermediate with the commercial function. but-
No, just more in the, I'm interested in the model for the optimal we are using to make kind of factor for the value. That's what I, part of what this is interesting to me because eventually all these patterns, you think they might have something to do with
so you're gonna be.
what Colombia is behind.
Well, you've done it more than.
Or that's what really cares about this.
Yeah,
We all care about this.
Here's
because
the-
we are-
I thought that's.
Are these late patterns
Oh,
altogether,
going
so,
good. No, no, I don't
to
mean
do
so,
with-
but like in
with
in the
the
Oxford,
development project.
I think.
And to what degree is really given by policy, not just.
Or the lack of policy. There's.
Yeah, so we have to figure out.
All I can. Push story points.
The question is how trustworthy are
Or
these?
whatever, people may have the
Online.
sense of, oh, they're coming out on track doesn't work.
So far as I saw the forgery has an early morning and then Black Friday starts.
Okay.
No, it's Black Friday.
So,
Yes, it is. So Black Friday's prior.
again, now it's gonna easy for me to.
It's
say,
just
so
like-
said, we have to do this.
Yeah.
No, thank you.
Yeah. I mean, it's the demand.
But you were saying, so.
So it might be nice to have a benchmark.
Yeah.
Thanks.
There's a lot of things like, you know, London. Stuff like.
Yeah, I think it's just that we're limiting. And new Black Fridays is there, is their
Capital intensity different.
journal.
So yeah, we have to figure out a plan.
So are we all on the same flight?
Yeah, but I think we have, no, I think it's like.
145.
I do think.
That is the, yeah, that is the residual and the.
Or these
Oh,
are,
really?
discussions will do it.
Well, distortion would show up in.
So if there's enough.
Yeah, and I show them like the right, we show.
Right.
Well, yeah, I don't know.
Yeah, so what's, so if you, in just in the. data,
There are definitely options for this if we're not leaving before 10.
Manufacturing. You say about employment, but I want.
Well, I mean.
And leaving that, I
Okay,
calculate.
let me look at what I'm finding.
What we see in the data is you have famous to label going to the employee. And then some cost for labor.
Down.
And there's a gap between both. So infer that you pay to the employee and then you put like in social protection.
It's just I had that.
Yeah,
Yeah, it's still cost.
and we think of that as a distortion.
Wow.
Because it makes making labor more expensive, probably like this formal.
The labor's getting.
Yeah, and we actually give them in rebate, but it makes it more expensive. Yeah.
But if I get.
There should be AMSs
We
or Black Friday.
yeah,
So that's ample time.
put it as a cost to the firm and then we.
Yes, we're gonna say.
Yeah, it's not obvious.
In principle, if you bring your stuff.
You don't get it. If you're not employed.
Yeah, even if it wasn't.
Okay.
Yes.
I guess.
Okay, yeah.
We can be sure, right, so. And that's it.
I hate to say this, but it's absolutely right, and then we think about this is like a part of being.
Although it's just like, I don't know if that's.
But now.
The trains are,
I don't know.
the trains are pretty free.
But maybe
Buses are.
Train,
Like maybe when I work with, like, I get healthcare, like, you know, permanent, would only be.
Yeah, that's what I'm saying. Yeah, that's it.
But you also pay taxes for health to support.
Yeah, I'm not saying.
The capital tax.
Yeah, well, it's a distortion, so you.
Buses.
It wasn't clear to me, it wasn't clear to me that the buses were free.
Yeah, but the data, what you see is, okay, here is this big part that's called.
Okay, so
So
I fly out it, actually, no,
The
I
pay-
fly out
But it's
12
one
to 1.
time.
So you think it's gonna be
No,
hard?
we see that in the
You should go fast today.
No,
in the data,
I
No,
understand, is it? Should I be-
So
You guys are at 155.
that is.
So where is it here?
Yeah, I see what you're saying.
Okay. Oh,
In
I
reality.
was, mine was
reality? in reality, workers get some benefit from
No, no,
this,
no,
but not to the full extent of the cost, because a big part of this is funding
Yeah,
the pools.
yeah.
Yes,
So let me-
exactly.
It's easily 1220 and I'm on the 145.
Yeah.
What are you leaving?
So you guys can possibly.
Maybe.
The.
Are you on the United flight?
United at 1:45.
I think, is Michelle on here?
1:35.
1:35, okay.
Well, mine is 1:35. It might operate 2 flights and it is part.
And think about our real interest rate and then.
And then.
I'm happy to go, yeah, I'm happy to go with other people with the bus. I'm happy to go early with you. We'll check out the.
That would be fun.
You've been
telling me about the last.
It's
sort of like with the other side of frugality or something, it's just
It's free. So I have
the value derivation, yeah.
The Oxford Oratory.
Yeah, so you have to.
So you can learn that directly.
I can see that. English.
That's.
Okay, so basically, the distribution is value added.
I can see that on the website.
Okay, so maybe that's not right.
And even.
There's also an 8 a.m.
Capital
College.
yeah, we assume some interest rate.
Hey, man,
You can do that as an example.
No, just being.
Is this the, is it National Express or what is yours?
Well, we were thinking if there's a group, it might make more sense just to make a car. Just to get a van or something.
Yeah.
What's the advantage?
Yeah.
What's the advantage?
Yeah, and we computed on that, so yeah, we should be able to show that.
Exactly. Well, I don't know. I mean, what exactly what's the advantage of just all?
One is it could be cheaper, the other is you could be on our schedule, the other is you could pick us up at the.
Events now, these ones. Yes.
Flexible.
How do you want to go to Sunday night?
It looks like we.
Oh, look at, no, it's not true. So this is. That's a Saturday.
That's a Saturday.
Well, that's Saturday at 6:30. I mean, that's where I'm gonna have to go.
The value of this is.
Well, how early do you have to leave if you guys to get there? Yeah.
And then leaving and you as well.
If it starts at 9:30.
Oh, you know what?
That was the development game.
It's this.
What is?
When they said 6:30,
And then 6:30 p.m.
they meant 6:30 p.m.
That's wonderful. Yeah.
Okay, yeah.
It's not wonderful.
I like maybe
It's clear.
Yeah,
I might have to go tonight.
that might be right.
Which means missing.
And so like.
You guys can do your you guys can do your Protestant worship. Right?
Discussion.
Well, I'm gonna see what that's.
Oh, you're going to, yeah. Oh, that's too bad.
No, thanks for bringing it up.
No, I'll go to the dinner. I mean, I'll be a little
I
bit.
don't know how long,
A little.
Lamass is what, an hour?
Not too much.
An hour, but they said ladder. No, that's,
Yeah.
Nobody's.
Older form.
You might go.
Older form of Latin. Latin mass.
The even songs of the hour.
Oxford's.
That's not, you're not being recruited.
I have to get over that.
Just trying to.
Yes, yeah, well, very bad one.
Okay, let's figure out, so I think I'm gonna go to mass at 6:30 and I'll join you guys.
Okay.
You'll all be nervous, because if I don't show up, then you're on a hopeful bill.
With the level of marketing Michelle is doing.
And I'll get.
I'd be scared for my spot if I were you, and I'll be opposite.
And when I come, it'll be like, guys all be eating caviar as your appetizer.
Gold flights.
So wait, let's figure out how much.
Blackberry also probably has one too, I don't know which one is closer.
Okay. I had no idea.
Joe, may I
Blackfriars was,
sit next to you? if you don't mind?
So you do Blackfriars prior, you have to put in priority each time.
I had no idea, because a lot of these things, they keep the name.
Yeah.
And then they probably.
I only knew about it because during the pandemic, too. So. What about getting on a scarf or something?
And what?
A scarf.
For on? Yeah, I thought we were.
She ever wore a scarf?
Yeah.
She has?
Yeah.
She wears scarves? I don't even know people buying clothes.
I thought when we go to the commercial area, we walked by yesterday, something would. Mention something.
You thought yesterday your imagination would be sparked, it wasn't?
Not yesterday, but when we go again to this place, we'll find something that catches our eyes, but that's a good idea. Thank you.
This is new.
This is new.
Yes, yeah, I saw the.
I see, so they have a vigil mass at 6 p.m. which would be better for me, because I could just meet you roughly,
Yeah.
you're meeting your buddy right?
At 5. I mean, it's really, it's a friend of my friend. This is Catholic who lived in the apartment of the.
Oh, and how far is Blackfriars?
Real close. 50
That's
minutes.
a confession right there. Like, okay, let's go to maps.
15 minutes. Well, actually 20.
That's not a real place. What? That's as far as you can get in this town. Okay. Blackfriars. Oh, sorry. So we're at St. Catherine's. No, we're not. Oh, we are at St. Catherine's. This is actually the accounting.
I just want to say, I'm Kelly, I work at IGC, and I saw that you guys had applied for funding.
Yeah.
For this, yeah.
Yeah, oh, thank you.
I was just wondering, I mean, obviously Colombia isn't one of our main countries. Do you guys have any plans of looking into this in Eastern Africa or other places that are also really interested in industrialization and jobs?
In your opening statement, that's a hard question to ask. So, I'm not gonna speak for the group.
Yeah.
As a whole.
No.
My answer is, I don't think we will do that for these.
What's that?
You said once again, because.
Yeah,
I see a lot of stuff going on.
Foolishly.
But personally, I'm super interested in trying for these
It was a
because
good game, yeah,
I
but
think
it was bad.
if you really think
life
about
decision.
policy.
It wasn't a life decision either, I was like, I'll put it on for a few minutes.
Countries that are.
And then, I was like, still out doing stuff, like, oh, the game started, we'll see it then.
My father's second policy advisor, I don't follow like in American patterns. But if you.
No,
want to
no,
see
no,
if
just
there's
sleep
aliens that
deprived.
they're, the African
I think I
countries
would have been
are,
able to sleep.
they industrialize even one more premature stage.
Yes.
So.
But they're all worried about this, they're all
When's
worried
the-
about, I'm just not seeing jobs.
Yeah, I presented this work in Morocco.
Yeah.
I
don't know.
It was super humbling because of all the papers in the program, the minister of.
You have time, maybe not, we're almost starting it, but you have a couple of minutes, because I have a snake funded project on, I don't know what they preference is,
I'm not.
Role.
I said they weren't.
And it's very related to paper, I think it's a bit of a different story, maybe like kind of,
The job is.
not be ready for the smallest.
Yeah, I would love to.
Let's, Yeah.
Because. The picture that I showed you.
So May.
If I put this
Jeremy.
one-
Nice to meet you.
Yeah.
Contrasting.
So what kind of data
Yeah.
do you need for?
So. We. Level data. or we can- We can compare some of the. Perfect. Because we already have all access to. So many databases. So the question is, national accounts. Anything that can help us to distinguish the dual in production, national account. Where is production taking place, and the reason is just technology, or there's some. Maybe speech regulations.
Yeah. Okay, great, I'll keep that in mind as we.
Oh, well, yeah, thank you. Yeah,
If you want to reach out, if you have any ideas and things you want to work on, just shoot them out to IGC.
Oh,
With you guys.
yeah,
Yeah.
well, thanks for coming.
Yeah.
But again, I spoke by myself off the record, because I don't know the rest of the things, but some of them are gonna say, yes, I'm.
This one. It starts 15 minutes. Starts at, no, it starts at half hour, half past? I know, 15 past.
You don't get your Didn't need your hour updated, that's interesting.
I do it intentionally. So that I know what time I was at home.
Yeah, that's cool, that's cool, like. Yeah, 12:15. The other one would be. I've seen this paper too. Do you wanna go to the room? It's about coffee in Uganda, we should really go.
Just alerting to that issue. Yeah. Jeremy. I know this one, right?
I don't have a problem.
Maybe. I've seen it before, right? This isn't a new thing that you're just going to.
I think you've seen this.
You know.
It's all the SED.
Yeah. Sometimes, you know, people work on. I'm like, oh, that's the same paper I've seen. They're like, no, this is a new version, we do stuff.
Jeremy was hesitant because then you're just about to leave my. No, I see.
Yeah, I
So
saw.
he knows how antagonistic I can be, especially this saying something for the second or third time.
So is the same in Chile, the same?
Yeah, you're welcome to leave as well.
No, because well, that's a good time to say I had to leave for a phone call in the middle of your presentation.
Ah.
So now it's my time to.
Well timed.
No, now it is time to catch up.
I told my wife to call as well.
Okay. People start late.
Should I get started or another one more?
Then collecting coffee mugs.
They do come around
And
and
they clean it?
yeah, like in that big lecture theater, there were like 5 mugs.
Look, I actually want to-
And then disappear.
They were gone. All right, thanks everyone so much for being here. Thanks to the organizers for including me in the program. This is joint work with David Hughes at Boston College. I'm going to be talking about measuring misallocation with experiments. Great. So I feel maybe in this setting, I don't need to do as much motivation as I might do otherwise to tell you that like misallocation is important. I have like a Chad Jones quote. If you like Chad Jones quotes, Chad Jones thinks it's important. Shan Klenow also think it's important. Shan Klenow has a big paper in this literature on measuring misallocation, and they claim that Indian manufacturing TFP would rise by about 50% if India were as allocatively efficient as the US. So misallocation is this big theory of differences in output per capita across countries. It's also really important for policy. You know, what sort of development policies you want to consider are going to drastically change depending on whether you're in an efficient economy, in which case, you know, really you shouldn't be doing all these subsidies or, you know, microfinance, oh, that's all silly. If you're in an economy where inputs are misallocated, then you start to get into a world where maybe you do want to have a development bank or microfinance, et cetera, because you could actually increase allocative efficiency and increase output rather than just redistributing. So misallocation is very influential, but it's also very controversial. And the reason is that previous work has largely relied on very strong functional form assumptions about production functions in order to estimate misallocation using a cross-section of data on firms. In particular, Shan Klenow and lots of work that basically follows on that framework assumes that everybody has a Cobb-Douglas production function and everyone has the same coefficients as each other on the different inputs in that production function. And so the only heterogeneity that's allowed in that framework is heterogeneity in a Hicks neutral productivity shifter. Well, any productivity shifter for Cobb-Douglas is the same. So where these methods have found large losses, it's not obvious is that suggesting that there's a rejection of allocative efficiency? Or is it suggesting a rejection of Cobb-Douglas with homogeneous coefficients across all firms? And so in this talk, I'm going to be talking about what are the costs of capital misallocation first off in a particular setting. And then how can we measure misallocation with minimal assumptions about the firm level production function? And the answer is going to.
Very quickly, could you share the screen? We just see the video. Sorry.
I keep talking and Paco will do his best with Zoom. Probably have to click the Zoom share. Let's see if I have the slides devised. So the way that we're going to do this is we're going to connect the macro literature on misallocation. Control Alt Shift. Yes, that. Great.
Yeah. Does it work?
It works.
No.
Do you see it?
Let's say yes.
Okay, that's okay. So the way that we're going to do this is by connecting this macro development literature on misallocation with a parallel literature in micro development. And that is this large literature first summarized by Banerjee and Duflo, and then with lots of later follow-up RCTs, finding that there are high and dispersed returns to capital in developing countries. I'm going to focus in particular on an influential experiment by Denell, McKenzie, and Woodruff, where they gave cash and also in-kind grants to Sri Lankan microenterprises, and they used that as an instrument to estimate the average returns to capital in that setting. They found monthly returns of about 6%, so that's super high in and of itself. The innovation we're going to add is we're going to show how you can also estimate the variance of expected monthly returns across firms. That's going to allow us to sidestep those functional form assumptions that Shan and Clino have to make, because instead of having a functional form and then backing out the marginal product from the average product, we're going to be able to directly measure marginal products. We're going to use and extend some recent advances, maybe not so recent anymore, in the macroeconomics of aggregation to show how misallocation depends on the variance of returns to capital across firms under arbitrary firm production functions. And the key idea in this whole paper is going to be we're going to measure that heterogeneity in marginal products with a micro experiment, and then we're going to use a flexible macro model to aggregate up to a cost of misallocation. So the paper, I would summarize with this somewhat cheeky diagram. We're going to start from this macro question: what is the cost of misallocation in general equilibrium? And then we're going to work backwards and develop a methodology that will allow us to answer that with microdata. So the first part of the talk, I'm going to talk about how to represent misallocation as a function of the variance of marginal products across firms. That's going to be extending Bucay and Fari a little bit to arbitrary firm level production functions. Then I'm going to talk about how you can recover a lower bound on the variance of marginal product of capital across firms. And I'll talk more about exactly why it's a lower bound later, using the Denell, McKenzie, Woodruff experiment. Another thing that we do is we provide new tools to do valid inference on the object that comes out of that IV regression. It turns out it's a little bit non-standard. It's very nonlinear, potentially high dimensional. And so we need a new method to get accurate confidence intervals for that. Whether I talk about that much will be time permitting. And then finally, I'm going to show how we bring those tools to the data and get estimates for the cost of misallocation among these Sri Lankan microenterprises. So preview of the results. As I said, we provide a new methodology. We have results on aggregation, on measurement of marginal products, on doing inference for that object. The method we're going to develop is going to allow us to have arbitrary and heterogeneous production functions across firms. It's going to allow us to separate misallocation from risk. I'll talk a little bit more about that later. And it's going to be robust to measurement error, which has been a very important issue in the standard methodology for measuring misallocation. Using this Denell, McKenzie, Woodruff experiment, we're going to find a standard deviation of monthly returns of 9.8%. The 90% confidence interval rules out, values that are too small of that. That also means that the standard deviation is larger than the mean. That's going to imply that optimally reallocating capital is going to increase aggregate output in this setting by 22%. And we actually get estimates that are not that different from what you would have gotten using Shan cleanout, what I'll call Cobb-Douglas. With some caveats I may talk about at the end, but I don't view that as a general result. I view that as, in this setting, they're actually not that different. In principle, in other settings, they could be different. There's big literature on a lot of these topics. So what are we doing? We're connecting this misallocation literature on the macro side to a micro development literature on dispersed returns to capital. And we're showing how to bridge those two literatures. There's a lot of work on measuring misallocation. I see Martin in the room. We're contributing to that literature and showing one way that you can measure misallocation without Cobb-Douglas and in a way that's robust to risk and measurement error. And then we contribute a little bit to this literature on how to aggregate in a more non-parametric way in macroeconomics. All right, so what's the environment we're going to study? We're going to use the same environment that most of these misallocation papers use, which is a horizontal economy. So what do you need for an economic model? You need preferences, technologies, and endowments. The household is going to aggregate differentiated products into some final household utility. We're not going to talk at all about redistribution in this paper. It's just one household. There are a bunch of technologies. So we have a unit mass of firms. Each firm has an individual production function, and its output is a function of capital. In this paper, we're only thinking about reallocating capital. So think of everything that I say as holding fixed labor. And then you have an aggregate capital constraint, which is your endowment of capital. And again, here, we're thinking about reallocating capital, holding the aggregate level of capital fixed. And so any counterfactual we think about is going to have capital equal to the same level of capital as it is in the distorted equilibrium. The horizontal economy is the benchmark in the literature. I also think in this particular setting, it's a pretty good description of the real world.
Can you specify what you mean by holding other factors constant? Because if you do the DeMel experiment, they give capital, but then they do allow firms to adjust other inputs, right?
Sure. So that's getting a little bit more to the measurement side of things. In principle, what I want is the partial derivative with respect to capital, right? I don't want other things moving around. In practice, what this is, what we're going to do is think of a value-added production function. So obviously materials are going to move around. We are not going to allow, in theory, labor to move around. It's very conveniently in practice, labor does not respond to that grant. So that's one of the results in DeMel, Mackenzie, Woodruff is just the labor response turns out to be very small. And so if you try to do adjustments for how much does labor change and how does that affect profits,
So that's in line with this, but it wouldn't be in line with Cobb-Douglas.
Sorry, what do you mean?
So in the Sinclair or Cobb-Douglas, that labor wouldn't respond, that's not in line with the Cobb-Douglas model.
Oh, yeah, you're saying in a Cobb-Douglas model, you would expect labor to respond as capital moves. Yeah, probably. I think part of what's going on, which is very helpful for us here, is that the micro enterprise setting, these firms largely do not hire labor, so it's just owner operated.
Okay.
And so in practice, the response is very small. But yeah, that could be a potential concern if you wanted to try to extend this methodology to larger firms with many employees. I've seen basically no experiments with larger firms anyway, so in practice, it's not an issue, but maybe in the future when we get even more money to do RCTs, we have to have two instruments. All right. So what's the planner's problem? The planner's problem is what you expect. The planner maximizes household utility subject to the endowment constraint and to the technological constraints. That's going to yield a first order condition, which may be familiar, which is that in the first best, the marginal utility of good I times the marginal product of capital at firm I, which produces that good, is equated across all firms. It's going to be equal to this Lagrange multiplier, which I've called R. In an economy with an interest rate, R would be the interest rate. We can't measure marginal utility directly, and so we're going to introduce prices so that we can measure something that is proportional to it. We're going to assume throughout a price-taking household that optimizes its consumption bundle. We're going to normalize the price of the final good to 1, and then the household's first order condition is going to give us that the price of good I is equal to the derivative of it's equal to the marginal utility of good I. And so that's how we're gonna get that marginal utility. And instead of marginal utility times marginal product of capital, we're gonna start thinking about what we call the value of the marginal product of capital, VMPK. And VMPK, which is the price times the marginal product of capital, is what has to be equalized across all firms in an efficient economy. So when VMPK is not equalized, what's the cost of misallocation? We're going to define something we call a wedge, mu I, which is going to rationalize deviations from everyone having the same VMPK. Think of this equation here as just a definition of the wedge mu I. So different firms have, if they have different value of marginal product of capital, we're saying that means they have different wedges. The wedges can come from markups, they can come from taxes, credit constraints, etc. We're not taking a stand on where they're coming from or on the form of conduct on the firm side. We're just saying the firm has chosen some level of capital. That level of capital is not equalizing VMPK to everyone else. We're going to call that the wedge. Yeah.
You just want to understand your train of thought. So first social planner, then you show the supporting prices for those allocations. And now you're going to show the distance between those supporting prices, the social planner, with these wedges.
Exactly. And the planner, you can think of the planner's problem as choosing the wedges, right? I could write the planner's problem that way. The planner would choose all the wedges to be the same.
Exactly.
So what's the cost of misallocation? Let's start in partial equilibrium. Let me get everyone's favorite economics graph, 2 lines and a triangle. The upward sloping one is the supply that the firm provides of good I in the undistorted world. And that supply, it slopes up. What is the slope? The slope is what we're going to call, the slope is 1 over phi I. But phi I determines the elasticity of marginal product of capital to the output of the firm, or equivalently, you can think about it as the returns to scale. So the more upward sloping that is, the more the marginal cost of the firm is rising as the firm tries to produce more. If the firm had constant returns to scale and constant marginal cost, then this would just be a horizontal line. The demand, I've already skipped ahead a little bit, and I'm going to assume CES with an elasticity of substitution of theta. The demand for the firm's output is going to slope down because households have a taste for variety, and the slope is going to be determined by the elasticity of substitution. Now, the deadweight loss is this pink triangle, and the area of that deadweight loss is going to be determined by the base of the triangle, log mu I, times 1/2 times the height of the triangle. The height of the triangle is epsilon I times log mu I, where epsilon I is the elasticity of output with respect to the wedge. And that elasticity is going to be determined by the slopes of these 2 lines, and is going to depend on, as the firm tries to get larger, how quickly are its marginal costs rising, and how quickly does the price fall. It turns out that in general equilibrium, misallocation is still a sum of hard-working triangles. The only difference is that the wedge has to be demeaned by a particular weighted average of all of the wedges. And that comes from the market clearing for capital. And so we get our main proposition, which is in a horizontal economy with CES, the aggregation, the cost of misallocation is given by this formula. So the potential gains from optimally reallocating capital are equal to 1/2 times the sales weighted average elasticity of output with respect to the wedge, times the weighted variance of log wedges, and the weights in this variance are sales share times elasticity. This whole formula is a 2nd order approximation. So there's some 3rd order term floating around there. I'll note that if you have Cobb-Douglas, with everyone having the same coefficients in their Cobb-Douglas, and if you have joint log normally distributed wedges in productivity, and that's kind of a slightly specialized version of the standard Shanklina model, then the squiggly equal sign becomes just an equal sign, and the weights all fall out.
So Shanklina world, but the correlation with productivity and the skewness of the wedges also matter. Is that kind of embedded in the sales weighting in the variance here? Like,
So I would say two things. In the Shane cleanout world with log normal, the correlation doesn't matter.
Yeah, sure.
Yes,
Also,
and
also the weighting doesn't matter.
yes, exactly. Whether the correlation might get embedded somehow in the weighting or the skewness, you know, to some extent, yes, but eventually, you know, it's a squiggly equals not an equal sign. So we have some simulation results where we try different distributions of the wedges. And within the range of misallocation we're going to find, it's a very accurate approximation. As you get larger and larger, eventually that approximation breaks down in exactly the way that you expect for a second order approximation. So this extends Bucay and Fari's result mainly by allowing for arbitrary firm production functions. So they assume constant returns to scale. And the main insight here is that misallocation is going to depend on this variance, the variance of log wedges. And of course, on the elasticity as well. We'll have less to say about that. We'll do a calibration in line with the literature, and that is at least consistent with what you can estimate in the data non-parametrically. I mentioned this Cobb-Douglas log normal special case. I mentioned the accuracy of the second order approximation. You can extend this somewhat to allow for multiple inputs. Once you allow for multiple inputs, though, you need to worry about different firms having different, say, capital shares. And so the straightforward extension that you can do to multiple inputs assumes kind of a Cobb-Douglas inner, you generate some input as a Cobb-Douglas of your different inputs and everyone has the same coefficient, and then you can allow for arbitrary returns to scale in the Cobb-Douglas. The other thing I'll mention is that this cost of misallocation is inherently going to be a lower bound on the total cost of misallocation, because if I optimally reallocate capital without moving any other inputs around, that's going to give me less output gain than if I optimally reallocate all inputs. All right, so how do we go from a variance of log wedges?
So I just wanted to ask that if you go back in the C plano, you usually have like multiple nests of the CS, right? Whereas here you just have one CS aggregator, right? Is this important or?
Well, in the original Shannon cleanout, you have Cobb-Douglas across sectors and then one CES.
Yeah.
And then they study, I think, my recollection of that paper is that they're studying misallocation within sector.
Yeah.
In which case.
But then they aggregate across sectors. I'm just saying, is this important here or?
I think that in principle, you could extend this to have, say, nested CES.
Right.
And I'd imagine you get some, weighted average of the variance within and across nests. But I don't have a result.
Okay.
So.
Sorry, another question I have is that, so the Bucay and Fari style formula depends on the weights, right? And of course, if you change the distortion distribution across firm, gonna change their sales shares for their donor weight as well. Will we be able to capture that?
Well, this does capture that. So I don't go over. I don't want to click on the proof sketch. That's always a big time sink. But the way that this is proven is you use something that looks like Bucay Fari, just extending slightly to allow for the elasticities to be different. I take the derivative of output with respect to the wedges in the distorted equilibrium. I take the derivative of output with respect to the wedges in the undistorted equilibrium. Conveniently, that is 0. And then I do the trapezoid rule. And so that's how you end up with a triangle. But so the point is, yes, it's the shares are changing along that path from the distorted to the undistorted. But that's getting captured in the way that we're doing the derivation.
Oh, will this also be measured in your experiment?
No, we observe the distorted equilibrium.
Okay,
For curiosity, if you allow for time to build up capital, do you have extra terms or the?
Sorry, if I allow.
Time to build up capital is predetermined instead of.
I see.
Valid choice. Do you have any different results or just a simple extension of your current?
I'm not gonna have anything to say about that for the first 30-something slides. There's a follow-up project that we're working on, which has a dynamic model and does build in time to build. You end up using very similar formulas. You just have to take the expectation of the marginal product of capital at the right time. You know, the expectation you take it at the time that you're making the investment. Okay. So we want to go from the variance of log wedges to something that's a little bit more observable in the data. So it's trivial to show that the variance of log wedges is equal to the variance of log VMPK, because that's kind of how we define the wedge. Ideally, we would measure VMPK directly, but in practice, you don't have separate data on prices and quantities. And so you can only measure the MRPK, the derivative of revenue with respect to capital. Under CES demand, which we're sort of assuming anyway, MRPK is going to be proportional to VMPK. And so the variance of log MRPK is going to give you the variance of log VMPK. And that gives you this result, that under CES aggregation with a price-taking consumer, the variance of log wedges is equal to the variance of log VMPK is equal to the variance of log MRPK. That's not the only way that you can get the second equality. You know, if you have a fairly competitive market, then the MRPK and VMPK are also going to be basically the same, but we're just going to, use CES throughout. All right. So the key takeaway is we want to measure this. Easier said than done. So how are we going to measure heterogeneity in MRPK across firms? The answer is we're going to use this Duhamel-Mackenzie-Woodruff experiment. So the setting of that experiment is 3 districts of Sri Lanka. They took a representative sample of microenterprises. They randomly offered grants through this RCT to fund capital. There are a bunch of different treatment arms. So there's a 10,000 and a 20,000 rupees. There's cash versus in-kind grants. There's a control group. They end up rolling those different treatments together, and the instrument ends up being the cumulative amount of grant that the firm has received. There's also some staggered rollout in this experiment. So nobody is treated in wave 1. That's very important for us because it allows us to measure baseline variables. And also none of the participants know that they're going to get treated in wave 1. Some are treated between wave 1 and 2. The rest of the treatment group is treated between waves 3 and 4. And which of the 2 timings they're in is random as well. And then the control group eventually gets 2,500 rupees after wave 5 as an incentive to keep them in the experiment. Duhamel, Mackenzie, and Woodruff estimate this regression. They regress profits on capital, a firm fixed effect, and a time fixed effect using the cumulative amount of grant received as an instrument. And they show that that is going to estimate the average marginal revenue product of capital. Yeah, Gustav?
So on the figure that I showed, that has the nice triangle, what this will be informative about, the 2 parameters in the model, which is the demand elasticity and the wedge. So you assume that the demand elasticity is sort of constant and wedge varies across firms. And this is why you can identify the wedge from this. But to me, it looks like assuming that the demand elasticity constant looks like a very strong assumption. Or I'm wondering if you could allow the demand elasticity to change by sector, for instance. You take this beta and allow the beta to be different by sector, something like that.
Sure. So I will say, I don't think I have it here, but there's, depending on how you define it, 1 or 2 sectors in this experiment. So it's all micro enterprises. They're basically split about evenly between making food and, small retail shops. We could do the whole thing separately for those 2 groups and allow things, the demand elasticity to be heterogeneous by sector. We're not going to estimate the demand elasticity. We're just going to take an off the shelf number. All right, so we want to do something that's a little bit more difficult than just measuring the average return to capital. We want to measure the heterogeneity in returns to capital. So we want to run the same regression, but have beta vary across firms. How are we going to identify this? Well, there are 3 challenges. 1 is exogeneity. You need an instrument that provides exogenous variation in capital. Duhamel, Mackenzie, and Woodruff did that for us. The second, a little bit more subtle, is this excludability issue. This instrument, it's moving capital around. Is it also moving around other inputs like labor? In practice, this profits regression is going to isolate the MRPK by subtracting off the cost of materials. And labor in practice is just not moving in this experiment. This argument is really from Duhamel, Mackenzie, Woodruff. Our contribution is heterogeneity. If we think that the homogeneous version of this is identified, how are we now going to identify the heterogeneous coefficient version of this? And the answer is that we're going to project beta I onto ex-ante characteristics. So we observe a bunch of things, which we'll call xi at baseline. And we're going to have a regression that has heterogeneous coefficients based on baseline characteristics. And in practice, what is this? Well, it's the original regression, but now with an interaction effect with xi. And xi can be a scalar, or it can be a vector of different characteristics.
Does profit not subtract off capital, cost capital?
It seems the way that they answer the question is no. Because it's not, there isn't really a market for the capital, right? You know, I give you the capital, you didn't pay a cost, and so when you ask them what was your profits, it seems that they include, you know, R times K. So you're going to need also these interactive time fixed effects when you run this regression to control for the staggered rollout. But the point is that if you run this regression and you use as instruments your cumulative amount of grant received, which was the original instrument, and also a new set of instruments, which is the interaction between that instrument and the covariates, then you can identify this regression. If you do that, and you can estimate not just beta, but also gamma, which is the interaction effect, then you can back out the variance of the expected marginal revenue product of capital given the covariate.
And to do it weighted by sales?
We have a version where you can do it weighted by sales. The numbers are noisier, but you get similar results. We can't do weighting by sales and the elasticities because we can't really separately estimate the elasticities. But
which elasticity?
The epsilon, the elasticity value with respect to the range. So that is not observable.
Given that, you can do this weighted by sales.
In principle, yeah, if you observe that, you could do this weighted by sales as well. Sorry, if you observe that, you could do it weighted by sales times elasticity. We observe sales, so we can do it weighted by baseline sales. But everything I show you is going to be unweighted unless I click the sales weighted button.
But the weighting should be giving you potentially bigger effects, no? Because
not necessarily. I mean, in the Cobb Douglas,
it depends on the correlation.
It depends on the correlation and on higher order terms. No,
but it's more about this distribution of wages that you identified.
In the log normal model,
no,
the correlation doesn't matter.
No, yeah, no, but it's away from the log normal model for which it matters. The weighted by cells give you a larger variance when the more productive firm has higher wages, they have higher sales.
It's more complicated than that. If the larger firms have higher variance, then weighting by sales will give you. But if the larger firms just have higher wedges, that doesn't necessarily increase the size of the weighted variance relative to unweighted variance. That's why the log normal model, the weights fall out and the correlation doesn't matter.
No, I understand that statement. But when it does matter, it's kind of because of that intuition.
I think that it can go either way depending on the distribution. All right, so we can decompose, what are we identifying? You can use the law of total variance to decompose the total variance of MRPK into the predictable component, going a little too slow, into the predictable component of the variance and the unpredictable component of the variance. We're identifying just this first term, which is going to be a lower bound on the total variance of MRPK across firms. We think that that's actually a feature, not a bug. And the reason is that it's really important to distinguish between misallocation and risk. So if you have ex ante differences in returns, that's misallocation. If you have ex post differences in returns, that's going to mix misallocation, something the planner could have corrected, and just risk. It wasn't known up front what was going to be a good investment or not. The world is stochastic, sometimes things don't play out. Our method is isolating misallocation because it's looking at the predictable component of the variance. To quickly compare to the standard approach, what do Shan-Klenow do? They make a set of assumptions, this homogeneous Cobb-Douglas plus CES assumption, that make it so that the variance of log average product of capital is going to be equal to the variance of log marginal product of capital. In general, outside of exactly that set of assumptions, the NPK cannot be inferred from the APK. So if you have fixed costs or if you have heterogeneous returns to scale across different firms, then that's going to break the correspondence. We're measuring marginal products directly with an RCT, and that's why we don't need to make the same functional form assumptions. What we want to measure for misallocation is heterogeneity in NPK, and that's exactly what we're measuring. Our method is also robust to measurement error. So a lot of work, including some of Martin's work, has shown that measurement error, A, shows up in the standard approach for misallocation, and B, turns out to really potentially drive a lot of the results. It's work also, it's up here as well. Classical measurement error is going to inflate the variance of the log average product of capital. Our method is going to be robust to that for two reasons. One is that we have an IV-based method and classical measurement error does not affect IV estimates. And two, because measurement error in inputs and output is not going to affect things once we project onto observables. I'm going to skip the econometrics angle in the interest of time and just get to the empirical estimates and may or may not mention the follow-up project. So to summarize the results that that's our methodology. To summarize the results that we're about to get, what we do is we estimate returns heterogeneity first with a single baseline covariate. And we have a bunch of different baseline covariates from the data. The one that stands out is baseline average product of capital. That turns out to be really a powerful predictor of your marginal product of capital in the later waves. The next thing that we do, which is our main specification, is we take those covariates and we do principal components on them to generate some standardized principal components. And we take the first K principal components. So we do it for all the different values of K, and it looks pretty similar. I'll show you K equals 5 just as a representative number. What we get from that is a mean monthly return of 8% and a standard deviation of return, predictable standard deviation of returns of 9.8%. That implies a ratio of the standard deviation of the mean of 1.23, and the 90% confidence intervals can rule out low values. In principle, we could also estimate this elasticity of output with respect to the wedge in a non-parametric way, but in practice, that estimate is going to be really noisy. And so what we do instead is we use standard calibrations as in Shan-Klenow. So if you took the Shan-Klenow model with Cobb-Douglas, with a CES elasticity of 3, and you focus just on capital, then what you would get is an elasticity of output with respect to the wedge of 3.7. So how do we construct a confidence interval? We have a Martin.
Does the fact that it doesn't matter that much how many inputs of components you use, does that tell us something about the nature of this allocation?
If it does, I don't know what it is. But if you have any thoughts, I'd be interested to hear them after. Yeah.
I mean, I miss what are the sectors of what are the outputs that are being produced? Like how homogeneous or heterogeneous are they? And like
so
relevant for thinking about whether or not.
Yeah, half of these people are, so they're all micro enterprises. Half of them are doing retail. So they sell little stuff that you would buy in a small store. The other half are doing food. They're mostly selling, Sri Lankan food, hoppers and string hoppers. I went to a good Sri Lankan place in London recently to find out what that is, but it's basically, it's like a dosa. How heterogeneous they are, I don't know. That's what the CES elasticity is for. Okay, how do we construct confidence intervals? We have a hypothesis test, and then for each level of our object of interest, this is the standard deviation over the mean. We construct a p-value. This is saying, how do I get my 95% confidence interval? Well, I take all of the points where the p-value is above 0.05, my 90% one, all the points where the p-value is above 0.1. When I'm using baseline APK to estimate returns heterogeneity, I get a point estimate of 1.5 and a 90% confidence interval that goes from 0.84 to 2.48. So all of those are saying the standard deviation is quite large relative to the mean, even though the bottom of that confidence interval says it's 84% as large as the mean. Then this is our main specification, which uses the principal component, the first 5 principal components. We're going to get a point estimate of 1.23 for the ratio of the standard deviation to the mean. The 90% confidence interval has a lower bound of 0.47. And once you get into multiple dimensions, you end up with this feature that usually the upper bound of the confidence interval is infinity. Given that we're estimating something that is lower bound anyway, that, you know, if anything is kind of good for us, you prefer to get one-sided confidence intervals if you can. This is the key result of the paper. So what is the cost of misallocation? We're going to take those numbers that we estimated and plug them into our formula. So we have a standard deviation over the mean of MRPK. Our point estimate is 1.23. That implies, using a log normal approximation, that the variance of log MRPK is 93 log points. And plugging that into our 1/2 times epsilon times that variance formula, with epsilon of elasticity of 3/7, tells you that if you optimally reallocated capital across microenterprises, you would increase output by 22% in this sector. Of the 90 and 95% confidence intervals, the bottom of those intervals, and then a comparison here to what would happen if you instead used the Sheklina methodology to measure the variance of log MRPK. And you actually get a number that's not that different. You know, are 22% and 34% different? I guess it depends on your perspective. But my view, at least, is that it's not crazily far off. So the point estimates imply these large potential gains, and actually that the Sheklina method doesn't do that badly in this setting. But again, that may not be true in other settings.
Right, two clarifications. The first one, when you do the Cobb-Douglas, you don't actually do the full CEPR, but you do Cobb-Douglas and then you plug it into your formula, right?
Yes.
Okay, but if you do full CEPR, you would get maybe to a different number in the end, no? Because the formula is different, or?
I think that the log MRPK is pretty close to log normally distributed, and so you would get something very, very similar.
And the second one is just on this step. So you do a log normal approximation there in the very end?
Yes.
So that's exactly, because this seems
You can do it
seems
directly.
fairly.
That's to go from the standard deviation over the mean to the variance of the log MRPK.
But yeah, but you have to do that because you frame it in the beginning as being very general, and then in the end you use a log normal approximation that seems.
Yeah, so one of the things that we look at in the simulations is how much does that estimate take? It turns out that is actually the step that is the least robust. So you have other distributions, you still get basically the same estimates. Fortunately, in the other distributions that we've looked at, it all looks like we're underestimating misallocation if we use this log normal approximation. I think log normal is probably close to the truth.
But you can do the sales weighting.
It's not about the sales weighting, it's about going from the standard deviation over the mean to the variance of the log. Whether you use sales weighted or not, you still have to do it.
For the second approximation work that technically you should do it sales weighting. And that's the object that you wanna, and then you say, well, if the model was its productivities and distortion were happen to be not distributed, then you can skip the sales weighting.
If you have the log normal distribution and Cobb-Douglas, then you can skip the sales weighting. If you have the log normal distribution alone, then even if it's not Cobb-Douglas, you'll still get that this and this is exactly right. So it's two slightly different things.
And what do you get when you do the sales weighting? I would say that's the most robust.
It's a little bit hard to see, but so our estimate for k equals 5 for the unweighted was 1.234 for the for the standard deviation over the mean. The estimate for the unweighted was 1.234. Here it's 2.3. The key thing that happens when you do the sales weighting, standard deviation is relatively stable and looks similar to what, if a little bit higher, to what you got in the unweighted case. So the unweighted case would have given you a standard deviation of 9.8%. Here ranges from 6 to 12%. Once you start including a decent number, it's around 12%. The key thing that moves around is just your estimate of actually the mean is noisy. And so sometimes you get these very low values for the mean, but the same really high value for the standard deviation. And as a result, the ratio of the two is unstable. It's unstable again in a way so that if we had done the sales weighted, we would have gotten even, this would give you a really huge estimate for misallocation. It's just, I defaulted to the unweighted both because of just path dependence, but also because I trust these results a little bit less just because when you do weights, it becomes noisier.
But as you just covariance terms claim.
Yeah, I guess I would just say it's not the covariance term, it's the difference between the weighted and unweighted variance. Okay. I think I'm about out of time. So
15 minutes. 15
I have 15 minutes. Oh, okay. Great. My timing is perfect because I plan to have 15 minutes to discuss the follow-up project. So that was great.
You can give it to coffee about your choice.
No. I'll take 15 more minutes of your time. Perfect. So hopefully I've convinced you that experiments are a useful way to measure heterogeneous MPKs. But obviously the approach has a bunch of limitations, some of which you guys have outlined, but some additional ones, which often come up, are you need to find or run an experiment. And that is either very hard or very expensive or both. The method also does not actually allow you to observe individual level MPK. The way that we set things up, you can only observe conditional averages. I can say you have these covariates. I can tell that this is what your marginal product on average is going to be given your covariance. And as a result, you get this lower bound. Maybe you want a tighter bound. And it's very hard to get coverage across different sectors and sizes. It's hard already to run an experiment with a bunch of microenterprises. It is somewhere between extremely hard and impossible to do that with, Apple. Like, I'm not going to get enough money to give a grant to Apple that would affect its investment decision. So this potential solution, which is some work in progress with Miguel Faria Castro and Julian Kozlowski, they're both at the St. Louis Fed, so I have this disclaimer in the middle of the presentation, is to use the firm's first order condition. And this, by the way, is an idea that's in Banerjee and Duflo's handbook chapter as well. There's heterogeneity in the interest rates or the cost of capital, which I'll define in a moment, that different firms face. Firms are going to set their marginal revenue product of capital to be equal to the interest rate plus the depreciation rate. And if they face heterogeneous interest rates, that leads to heterogeneity in marginal products. And that's going to lead to misallocation. To the extent that you can more easily measure the firm's cost of capital than you can run an experiment to manipulate it and measure its marginal product, this is going to allow us to more easily measure the misallocation of capital. An important thing, which I'll talk about, is that you need to correctly adjust for default and for floating rate issues if you have a loan that's going to change interest rates over time in order to get the true cost of capital. You can't just read off the interest rate and say, well, this is the cost of capital because if I'm going to default on that, then my actual cost of capital is low. So what I mean when I talk about the cost of capital, yeah, Mark?
That means that the source of distortion is variation in interest rates.
Yeah, here this is a model in which the only distortion in marginal products or marginal product of capital is coming from being offered a different cost of capital from the bank.
Do you know in the Demel experiment, do they ask if they borrow and so what the rates are?
I think that the answer is that they're not really borrowing, but I would have to check. But there is some, Banner Chain to Flows Handbook chapter is citing some earlier work before Development Mackenzie Woodruff that shows heterogeneity in the interest rates that people are getting in, Pakistan and other areas. There's this Aleem paper on Pakistan, yeah. I would say that one of the innovations here relative to that literature from like the 90s is, they assert, well, this can't be driven by default or by other, things, but they don't really prove that. We're going to have a methodology that allows us to directly say, this is how much of the heterogeneity in interest rates is explained by default. And once you adjust for default risk and some other things, this is the heterogeneity in cost of capital. But, going back to some of these surveys and seeing if we can apply a methodology would be an interesting thing to do next. So I'm talking about this cost of capital row. What is that? We're going to define it as the lender's internal rate of return. So you go to a bank, the bank has some break-even condition, and it offers you a loan of size B0, and then it expects to get repaid over time. And we're going to say that the net present value of repayment has to be equal to the loan size that they give you to begin with. That's how they break even. And the cost of capital is the internal rate of return that rationalizes that break-even condition. We're going to measure this in the FRY14Q. That's the closest thing that the United States has to a credit registry. It was started after the Great Financial Crisis. It's a quarterly panel on all loans, business loans greater than $1 million. That start as greater than $1 million. It covers the top 30 to 40 banks, with the exact banks being included, changing a little bit over time based on which banks are deemed systemically financially important. But you should think of this as covering like 85% of business loans in the US. The measured row is going to depend on the interest rate, but also on default risk and expected future rates if they are offered a floating rate loan rather than a fixed rate loan. And we'll show, and I guess I have time to show you the model, that if you have a dynamic firm model, the marginal product of capital is going to depend on the cost of capital plus another term, which is an agency friction. So maybe I should have mentioned there's an agency friction here as well, but there aren't, say, directly credit constraints.
So within this framework, or you're viewing this framework, does the compensation for risk, does that come as exactly one?
Not yet, not in the results that we have yet. Definitely that's something we would like to try to incorporate. But at the moment it's not there. That's why it's work in progress. So we have a dynamic model of firms and banks. The firms, both are going to look very standard. So the firms produce using a production function that's a function of capital and productivity. This is totally general because productivity could be a vector. And none of the results are going to depend on scalar productivity. The firms invest in capital K. They do 1 period ahead investment, so there is time to build in this model. They issue some long-term defaultable debt B, and there is limited liability. So if they default, they just get nothing. Something I didn't mention here, but which enters too, is you have operating costs each period. And one of the reasons that you close is because you get your draw of the operating costs, you get your draw of productivity, and you see, it's not worth it anymore for me to keep operating. The bank side is pretty simple. So each firm gets matched with a bank. Each bank firm pair has some discount rate row, which is going to vary across those pairs. What's the reason that it varies? You could think of multiple micro foundations. One explanation could be market power, but in principle, you could have other ones. Based on this row, the bank is going to price loans to a break-even condition. And then the bank recovers phi of K in the case of default. So in the case that there's default, the bank is going to liquidate the firm and get some, amount that is potentially much lower than the actual amount of capital that the firm has. So this is the firm's problem written out as a bunch of Bellman equations. So the value that the firm gets in the state of the world where they're repaying, V of K, B, Z, those are the state variables, is going to be determined by this profit function down here and by the continuation value. So in the next period, the firm is going to get its, realization of productivity, including the operating cost and any other things that go into productivity. And it's going to decide, do I continue or do I just take zero and exit forever? Profits, pi, are production, f of kz, plus 1 minus delta k, so that's the capital you bring in from the previous period, minus the depreciation, minus the amount of capital that you pay for, minus theta b, so the debt is geometrically being paid off at rate theta. So this is the debt payment that you have to make. The price of debt is Q. And then in order to buy debt for the next period, you're gonna have to pay B prime minus 1 minus theta B, which is the debt that you bring in for the previous period after making your payments. The price of debt, this may be slightly confusing, so I'll just give the intuition for what this is saying. The price of debt is being priced according to this cost of capital rho. And so the price of debt today is going to be determined by probability of repayment times the value that you're going to get in repayment. It's theta plus 1 minus theta times the price of debt the next period, plus the probability of default times the value that you would get for a unit of debt in default, which is phi of k prime over b prime. You can show in this model that what we call 1 plus r social, so this is the social marginal product of capital. Why are we calling it the social marginal product of capital? It's because it's what the planner cares about. The firm's incentives are not quite aligned with the planner because the firm doesn't care about phi of k. The planner cares about phi of k because the firm defaults and gets no profits, but the bank and by extension society is going to get the liquidation value of that capital. So the social R, 1 plus that is going to be equal to 1 plus rho times this m term, which I'll explain in a sec, plus leverage minus the m term times the probability of default times 1 minus losses given default or the recovery rate. This price feedback term m reflects the fact that the firm is taking into account when it makes its decisions that if I increase my capital or if I increase my debt, the price of debt is going to change. We're going to calibrate for everything that I show you right now, this term to just be equal to 1. And you can think about that as kind of shutting down that channel of misallocation and just focusing on these two terms, which are the cost of capital and what we call the agency friction. So this agency friction, it reflects the fact that equity holders and debt holders have different incentives. In a fully debt financed firm, so that would be leverage equal to 1, the agency friction goes away. But when you don't have a fully debt financed firm, the firm is going to make some decisions that if they were taking into account the interests of the bank, they would not make. So what do we get from this? Okay, so slides maybe a little out of order. We go and estimate this row in the data. All of these things are observable, so we can observe the probability of default. We can observe losses given default. We can observe the interest rate. For loans that are floating rate loans, we observe the spread, and then we use the yield curve at that time to back out what the expected future interest rates are going to be. And we do all that and the payment schedule of the loan to get what is the cost of capital that rationalizes this loan. And similarly, we can observe leverage, probability of default, losses given default to estimate the agency friction. In this data set, the probability of default and the losses given default, those subjective expectations are reported by the bank. And so that's what we're going to use, and that's what's going to allow us to observe this firm by firm and get around this issue of only being able to do conditional averages. So first, what's the mean cost of capital? That's the blue line here, rho. And that seems to be fluctuating in very much the same pattern as the 5-year treasury rate is fluctuating. And 5 years is not exactly the median, but it's close to the median duration of the loans in this data set. There's roughly a 1.5% spread. So the cost of capital is higher than the treasury spread, even when you account for the risk of default. So that in and of itself is a little bit interesting. But the other thing that's interesting is we can take our misallocation formulas and this formula for R social as a function of the cost of capital and this other agency friction, and use that to back out what is the cost of misallocation using the loan data from each quarter of origination. And so what we see is that in normal times, misallocation coming from this channel, and this is all in the US, is really small. This is saying that if you were to optimally reallocate capital across firms in this time period, you would increase aggregate output in the US by 0.5%, which in my view is not very much. For macro development, that's nothing. There is a rise during COVID, which comes down afterwards, although not quite back down to the previous level. So now it's saying, the cost of misallocation now is about 1%. This rise turns out to be driven a lot, not actually by heterogeneity of the cost of capital, but by the agency function. So I think now I'm out of time, so I'll just conclude by saying, what did we do today? We show how to measure misallocation without making auxiliary assumptions about firm level production functions. We have this formula. We can plug in the variance of log MRPK that we estimate using the RCT. Another thing that I showed you work in progress how to do is how to instead plug in the variance of log MRPK you get from heterogeneity in the cost of capital from loan data. We find substantial dispersion of MRPK among the Sri Lankan microenterprises and large potential gains from optimally reallocating in that setting. Thanks so much.
Let's move to the next talk. We're gonna have shorter time. Sharing.
I don't know how to.
Yeah, so it's let me do that. You can start.
Okay.
So you don't have.
Thank you everyone for being here.
It's shared.
Sharing, no?
Today I'm going to be presenting survey evidence from India, where we essentially survey large firms in India. This is joint work with Mert Khan, who's a pre-doc at Stanford, with Shelby Buckman, who's a PhD student there, Nick Bloom, who was my previous PhD supervisor, and Mark Wheatley. So we've been discussing this over the last few days, that the size distribution of firms in most countries, but particularly in developing countries, has a high share of small firms. And these small firms would be the ones who are lowering aggregate TFP. Now, the thing is that in a country like India, the number of firms is very high. So if you think about the number of employer firms in the US, it's about 6 million firms, whereas in India, it would be about 65 million firms. So even if you look at the 100 employee plus firms, you still get about 100,000 firms at the top of the size distribution of firms. So what we want to ask in this question, in this paper, the question we want to ask is whether the large firms in poor countries are considered world-class and what implications this will have for aggregate TFP. So would the largest firms in India be comparable with large firms, for example, in the US? And if they're not, then what amount of misallocation can be accounted for at the right tail of the firm size distribution? If they are different, we also want to try and understand the underlying fundamental characteristics, in which sense these firms are different, to try and understand what are the drivers of aggregate TFP in firms and overall in firms and development. So to study this, we conduct a primary firm survey, which focuses on firms in this right tail of the firm size distribution in India. Now, although these firms aren't many relative to the total distribution, they do account for a lot of the output, the value addition,
And if you track them, you can track GDP trends as well. What we plan to do, which I'm not going to be able to show today, is that we plan to compare firms on underlying characteristics with US firms of similar size using census data sets, which is why I won't be able to share much on that today because we have our first disclosure still in progress. So what are the characteristics of firms that we're going to be looking at in our survey? The first is going to be innovation. This audience doesn't need convincing that most firms innovate in product space, but they may not be patenting their innovations. Even in the US, you'd find that only half of the firms who have product innovation would be filing patents. This would be higher for firms in developing countries where you might think that technology adoption is the primary way in which firms move on the technology frontier and grow. The second thing we want to look at is customer importance. So customers account for a large part of sales variation in the US. But we don't know much from developing countries where there's very limited data compared to, for example, the US, where you'd have credit card data to study such questions. The other thing is that in developing countries, you'd find that access to customer markets might be limited because of infrastructure being weaker. And so in this sense, we want to understand what the role of customers would be in this setting. The third thing we want to look at is management practices. Specifically, we also want to understand the relationship between management and innovation. So previous work that we've done in the US has focused on measures such as patenting and R&D, but we don't really know about product innovation and the relationship with management practices. Managerial skills might also be important for adopting existing technologies to local environments, which would be relevant in developing countries as well. So what do we find for India based on our survey data? We find that bigger firms tend to sell more products. They sell to more customers. Most products that firms sell are not improved from one year to another. And in the case that innovation happens, it happens in the form of the firm improving its own products rather than introducing brand new products to the market or imitating products which already existed in the market produced by other firms. Looking at management, we find that better management practices are associated with more products, customers, and innovation, both in the product space as well as patenting and R&D, like we saw before in the US. And we find that on the product frontier, management practices are correlated with introducing new products to the market, improving products, but not so much with product innovation. Okay, so the data we're collecting is through a survey that we set up ourselves in India. We're working together with the Center for Technology, Innovation and Economic Research, where we have our team of enumerators sitting and essentially taking a closed form survey that we developed in the US that I'm going to show you the questions for and calling up firms. And since we're tracking firms, we also track enumerator progress. So we have a little board saying how the enumerators and teams are performing as well. So right now, we're still in the process of data collection. So we have about 2,400 firms in our sample. We basically validate all the data and go back to the survey agency to check if it needs any changes. So right now, I'm going to be showing you data, showing you results from the validated sample, which has about 2,200 firms. So we started with a sampling frame of manufacturing firms in India for which we already had financial data because firms typically won't be answering questions on financing on a phone survey. So to get accounting variables for the same set of firms, to estimate TFP and so on, we use a sampling frame for which we already have financials, and these are going to be relatively larger firms. The reference year for our survey is 2021, and now we've continued to 2022 for the most recent observations, and we're closing the survey in these couple of months. The response rate is yes.
Sorry, just a clarification on the sampling frame, because before you were saying the big India accounts for 60 to 80% of output. Now the big India you have here is big India manufacturing.
Yes, so we're only looking at manufacturing.
And so the 60-80% that you had before, that is also just for manufacturing, or that's for all firms?
Actually, I should be clear about that.
Anyway, sorry.
Yeah.
It's manufacturing, no?
Yes, it is manufacturing, but it should be essentially value added in manufacturing. Yes, so if we wanted to track GDP manufacturing, we could track these firms over time.
Do you have any sense if these are multi-product firms or just a single product? firm?
Yes, we measure whether they're multi-product or single product, and we actually ask them the number of products they produce, so we could use that as well.
Do you know their political connection?
No, I don't know their political connections, and I can't ask them on the survey.
Ownership,
I have family ownership, so essentially, especially as these are larger firms, so you can see their board of directors, you can see their ownership structures, whether they're owned by other companies, so whether there's a pyramid of ownership. So I can see all of that. Is there something specific you have in mind?
We can talk about.
Okay, thank you. So what we collect, so typically the respondents are going to be top managers, CEOs or CFOs. And the firm characteristics that we collect from the survey are going to be on employment, which is not in the accounting data, family ownership, management, exporting activity, whether the firm's headquartered in India, whether it's standalone or a subsidiary. And then we're going to link the survey data, like I said, with firm financials, so sales, capital, salaries, profits, expenses, and also I'm going to be able to link it to patents at the firm level using the Orbis intellectual property data set.
So one of your results in the introduction, the last one, was something about imitation.
Yes.
So why don't you, so I imagine now seeing what data you have, that you infer that from the patent data that you have?
No, we asked the firm.
Oh, you asked that,
We
okay.
asked the firm.
All right.
No, the response rate, it does correlate with obvious characteristic that you observe from the ProWest data.
We are looking at that, so I'm waiting for the whole data set to come in, and then I'm
Then you
going to
will
check
try
the
to-
sampling selection for sure. Thank you. So the kind of questions we have, so we have 3 modules in the survey, one on products, one on management, and one on customers. So on products, we ask what's the number of unique products sold by your business. So if you're selling cars, then 2 different models, 2 different colors, but the same model would count as different products, and we make this clear in the survey. Of these unique products, how many does a typical customer purchase? Then we try to understand the concentration of sales in different products by saying what percentage of sales from your products was coming from the top 1 to 3 products, 4 to 10 products, and so on. And then on your question, what percentage of your sales comes from products that were identical versions of previous products, improved versions of previous products, products which were new to you but existing in the market, and products which are completely new to the market that you've brought in.
So I wonder if you can say something about imitation of foreign firms. There is some research that shows that firms in developing countries that tend to imitate products or technology from developed countries.
Yeah.
So here you're not precisely saying, existing in the market or new to the market. You don't know if that product was being imported before, or if that product existed already in other country, and then you sort of found out and then imitated.
Yeah.
Do you have something that can speak to that?
No, we let the firm define what they think is their market. It could be domestic market or international. We do know whether the firm is an exporter. So we do have some sense of whether, firms which would be in the domestic market would, think differently about saying that a product is new to the market, whereas somebody working on a global scale would have different understanding. So I understand what you're saying, so I'll think about that. Then what share of products were introduced because customers requested them, so innovation driven by customers, or you thought customers would purchase, or your competitors had similar products and that's why you introduced them. Then we also look at product discontinuation. Typically firms don't report discontinuing products. We also ask about the share of sales to products discontinued if they discontinued any products. The next module, the second module in the survey is on customers. So we ask what's the number of unique customers in the firm's order book? What was the growth rate of the number of unique customers of the previous year, and what share of sales of the firm in a given financial year is coming from these new customers. And then we also asked, what's the average distance of your customers from your manufacturing plant, if you have multiple, then from your largest manufacturing plant, to understand the issue of infrastructure in developing countries being a barrier to accessing customer markets. The third module is on management practices. So this derives from the standard management survey that we started first implementing in the US, and now it's been implemented in about 20 different countries. So this is a standardized closed-ended questionnaire trying to measure management practices in the firm. So it's not really about management, but it's about how the production works. So for example, one question can be, what best describes what happens at this business when there's a problem in the production process? So for example, if you find a quality defect. So you could fix it and not take any further action. You could fix it, take action to make sure it doesn't happen again. You could fix it, take action to make sure it doesn't happen again, have a continuous improvement process to anticipate such problems, or you could do no action. And in this case, for this particular question, if the firm says no action was taken, that's a score of 0. If they take this response, then it's a 1, and then it's equally scored in between, so a third and 2/3. And we have 8 such questions in the survey on 3 dimensions of management: monitoring, targets, and incentives. So monitoring is monitoring the production process. Targets is how targets are set in the firm. Are they long-term targets? Are they short-term targets? Who knows about these? How often you review them? And incentives is whether you promote, hire, and fire based on performance rather than tenure or other characteristics of employees.
Sorry, I have a question. Maybe it's a bit dumb, but so in the Fed every year I have to report, self-evaluation. I have to evaluate myself.
Yes.
And every year I go there and say, I'm excellent. I do all my job.
Yes. Yes.
And here you have a feeling a bit that's like that because you're asking the managers how well they're doing their job.
Yes.
And then if it's me every year, go there, excellent, I'm so good.
Yeah. So absolutely. So we were worried about this, especially the first time we introduced these questions. So there is that some questions don't have such clear answers. So it's not clear that your short-term targets are perfect or long-term. It's a combination of short and long. Second is that finally, when we take 8 different questions and we aggregate, we still get a distribution. And in all the different countries that, the survey is being done, there is a distribution. So everybody does not, there's a, as long as this is not done by your manager evaluating you, there's no reason to lie on the survey to make yourself look better. So we do find, I don't have, the backup slides don't have a link. I wouldn't go there, but we do find that there's a distribution of management, not only in India, but also in Mexico, Pakistan, all kinds of, even in the US and France, we do see a distribution of the responses aggregated up to the score. So we basically ask these 8 questions, and like I was saying, we calculate one aggregate score, which is the unweighted average of responses to these questions, and we normalize it. Low scores means you don't implement these standard practices, which are established broadly in manufacturing to be associated with productivity, but and a higher score means that you do implement a lot of these. Yes.
Here's a related question, especially for the earlier modules, is do they know the answers to these questions? Because it's an easy thing for me to do.
No, I don't. They don't know the answers. I mean, they could have done separate trainings on management.
No, sorry, like you ask them, how far away is your typical customer?
Oh, yes, exactly. Oh, you mean for the other questions, for the other modules? No, that's the point of having them in the survey, because it's not something that the firm collects anywhere in the accounting data. So they don't immediately have an answer, but often we can call them back if they want some more time and so on. So the point of having questions in the survey is because we don't have those metrics from anywhere else. So there's a trade-off that the manager doesn't have those answers immediately, or there might be some kind of measurement error, but the benefit is that you don't get this measure from anywhere else.
Do you keep track, like how long it took them to look at like some sort of quality, like you said you did some.
Yeah, so for example, we do have that at multiple respondents. So one person from HR would answer 1 second of the survey, then they would pass it on to the sales head to answer a different part of the accounting. So we do have it, multiple people answer the survey. So I think that's what I would use as a metric of the quality of response. Okay, so this would be an example of a management practice, which would just be that it's a well-displayed board saying that so this is from a factory visit to a gearbox factory, and it said to Tata, to Mahindra. This company was also supplying to Tesla and Jaguar. They were making gearboxes, and they were just tracking on a big board at the entrance of the factory, as soon as you come in, how much you had to produce by when. And so this is ideally, you can kind of see these things, and the survey attempts to capture those. So what do firms in our sample look like? They're relatively large. So in terms of the sales of the firm, on average, it's about $48 million. The mean, that's the mean, but the median would be about 14, as you can see here. In terms of employment, the median employment in these firms would be about 250 employees. 70% of them are family owned, despite being relatively larger firms. 60% of them export, and very few of them are headquartered outside India.
Those firms have 200 products in average.
Yes, so this is something I'm looking at because it might be, how they understand the, so I don't have any other measure, so I'm looking at an alternative measure of products from the CMI prowess data where there's a, coded measure of products. So I can see if, they're reported differently. Okay. So if we wanted to understand the importance of products to a firm's sales, what we could do is decompose sales into sales per product times the number of products. And then what I'm going to do is take logs and regress each of these components on log sales to get the elasticities. So when we do that, we find that both log products and log sales are significantly related, as well as sales per product and log sales. And if we look at the coefficients, then what this would mean is that essentially the contribution of products towards sales would be about 10% of the variation in sales, and the remaining comes from sales per product. And eventually what we want to do is compare this with manufacturing firms in the US. But right now, we're just able to do preliminary comparisons with the US, focusing on data from retail. And there we find that the elasticity is going to be lower in India for the number of products.
Just a clarification on how exactly you do the comparison with the US, because you take
So
this prowess thing, like it's not
we would
obvious
just
to me
take-
what is the number of firms you're gonna take in the US.
We would take the census of manufacturers,
Right.
and then what we would do is we have the sales, firms report sales. And in, I think 2013 was the last year, now we're waiting for 2023. Firms, if they report the number of products, then we could do exactly the same.
And then you would do all US.
Manufacturing, no, we would take large, so there's different ways of taking large firms. So for example, we could take the set of firms for which the median is 350, or we could take a cutoff of 300. So we want to look at large US firms. So it could be either based on size or the percentile of the distribution or the share of value added, for example. Yeah, not all firms, we would take a cutoff.
Yeah.
That's what we're doing.
Assuming, especially since right now you're doing this comparison to retail, like what do different packages or different numbers in a package, are those different products? Because I know that in the retail data,
Yeah, so-
they're different UBCs.
Yeah, so we basically defined the survey question based on what we had available in the US. So we basically said that, okay, if this is the level of granularity, we want the firm to respond the same way. That's the best we could do because we don't have exactly the same thing in it.
Sorry, so you guys were aiming for a UPC level as a product, or aiming for like a 10-digit category as a? That's what
Yeah, we were aiming for the skid, like the.
So you can like
Yeah,
the market.
yeah, exactly. We were aiming for that. And then as we started doing the questionnaire, we basically said that we have to be very careful in how we describe the product to be able to get to that. Thank you. We do ask, so I did include some questions in the survey just to validate the survey quality. So we ask about sales in the previous year in the survey, as well as we get it from accounts. These elasticities don't change that much if we were to use different sources of sales data. In terms of product innovation, the question we ask is what percentage of sales for your products comes from each of the following: identical versions of products that you had before, improved versions, products new to you but in the market, and products which are completely new to the market, where we let the firm define the market. So here we can see that most firms, irrespective of their size, don't have much of a high share of sales coming from products which are completely new to the market. Most of the time, firms have sales coming from identical products. When they do have any kind of improvement, it's mostly happening, any kind of innovation, it's mostly happening from the firms improving their own products rather than introducing products that competitors had or that's new to the market. We could do, yes.
Does this not vary between the growth of the firm? Because in France we found that firms that are growing really fast, those firms, they're a much larger share of the growth.
Yeah, I haven't, no, I know it, but I haven't looked across growth. So right now we're just looking across size, but I guess what we could do is just replace this with sales growth and then see. Yeah. No, I have to validate that as well. Thank you. So similarly as for products, what we could do is we could do the importance of customers to a firm sales with a similar decomposition. So we could take sales, break it down to sales per customer times customers, and find out the elasticity of sales to customers in particular, and what remains is for sales per customer. So when we do that, we also find that the results are fairly significant for customers and sales per customer. And in terms of the magnitudes, we could say that for India, for large firms in India, the number of customers account for about 27% of the sales variation, whereas most of it for 28% of sales variation, whereas 70% of it comes from sales per customer. We're still looking into this. This is low relative to the US based on what we could compare. That was for retail data, and I have to do also a comparison that we could do with manufacturing data for France as well to understand what's the importance of customers for sales variation. It doesn't matter whether sales is measured from the survey or from financial accounts or whether we do an instrumenting, the numbers stay roughly the same. The next thing, how am I on time?
5 minutes.
5 minutes, okay. So the next thing that, I'm sorry, I'm going forwards. Okay, so the next thing we wanted to look at was the role of management. And the first set of results was just validating the relationship between management and size that we know from the literature, management and firm performance based on value added per worker, profitability, R&D per worker, and exporting activity. What's new that we can do here is look at customers and products as well. And we find that better management practices are associated with a larger number of customers as well as a larger number of products, significantly so.
Sorry,
yes.
On the last result, is that controlling for size? Is that through size, or is that like even controlling for size, you still see that there's a
No, we haven't controlled for size, but this one we can control for size. But we think it's kind of the mechanism, so it's a bit hard. Okay. Also for patents, we find that better managed firms have a larger number of patents, but mostly what's happening is that it's on the extensive margin that firms who patent are going to have better management, whereas if you're already patenting, then on the intensive margin, we don't find these effects. Yes.
Clarification, what does it mean to have a customer? Does it mean you're planning to sell to someone?
You already have, it's based on the previous financial year, the number of customers. Yeah. what we could do in the survey is also ask about product innovation, and we found that management was associated with product innovation as well, not just patenting and R&D intensity. So this is just to summarize the results. The next thing that we're doing is working on how to compare firms which are large firms in the US on these characteristics, and then essentially work towards understanding whether those firms are comparable or whether there's something fundamental, and then quantifying the misallocation.
Can you give us a informal review?
They're not as good, but we have to quantify how much they're not as good. And then, one can think about whether it's family ownership in large firms versus diverse firms. Large firms in the US are diversified.
But you already have the results, but you cannot report them.
No, we don't have the results exactly because we have to do all the estimations with the comparable year of data. So we did some stuff for 2013, but things are different, and then we need all of these. But essentially, we don't expect them to be the same. And if they're different, then we can try and understand if there's something about the economic environment, or is it that there's something intrinsic.
And some of these variables, there is information in the ASI, although it's sort of at a level. Can you look at that? No.
Yeah, no, I was thinking about that. So we don't have the share of sales to different products. We just have the number of products.
In the ASI or
in the ASI.
Okay.
Yes.
No, I'm just curious, like, since you're doing this data from your own survey,
yes,
what's preventing you to go to different sectors of the economy to try to see how things happen, like dairy products and stuff like that, more besides manufacturing?
You can imagine my co-authors want to estimate TSPQ, TSPR. We can consider for management. There's been work in retail and hospitals and schools and so on.
But the thing is, the environment.
Yeah, we basically want something. Also, if you have something which is tradable, then you can kind of say that it's not something contingent on the economic environment.
I was just wondering about state ownership. So I would have expected that in India, some of these firms are, the big ones are still state owned.
We try not to include them because they're not comparable.
Yeah, exactly.
Yeah, we try not to include them because their incentive structures, everything, like the contracts that they get.
Yeah.
Okay, thank you so much.
Good afternoon, everyone. My name is Ruby, and I'll be presenting the paper on credit contract enforcement and income disparities across Indian states. So as you would know that the role of financial frictions in explaining per capita income disparities across countries is something that is being studied very widely. But there have been limited work on looking at the role of financial frictions across states within a country. And I do that in the Indian context. How are financial frictions related to per capita income? The channel is misallocation. So because of financial frictions, savings are not flowing to the most productive entrepreneurs. There are high collateral requirements in the economy. And entrepreneurs who are talented, but maybe not as wealthy, do not get capital versus those who may be, versus those who are wealthy, but not as talented, they get allocation of capital more easily. So that creates a misallocation in the economy and lowers the potential PFP and GDP. So that's the storyline. And in India, there are large disparities in income, and I'm trying to look at the role of financial frictions and explaining some part of these disparities across income per capita across states in India. And the particular type of financial friction that I'm looking at are these credit enforcement frictions, credit contract enforcement frictions. And the proxy for measuring these types of enforcement frictions, what I'm taking is the speed of judiciaries, especially in terms of resolution of civil suit cases. Okay. So that's my goal, try to look at the role of credit contract enforcement in explaining per capita income disparities across states in India. So this is my approach. I have both the theoretical and empirical approach. In my theoretical approach, I am solving a one sector version of Buera and 2011 paper, which is a dynamic infinite horizon heterogeneous agents 3 occupational type model, which has 3 types of occupations, a formal firm owner, an informal owner, and a worker. And then I calibrate this model for each Indian state. I use the data on state level speed of resolution of cases in my calibration exercise. And then with my calibrated parameters, I am trying to look at how much of these disparities are being implied by the model. And then I also do an empirical exercise where I'm trying to verify the impact on the occupational choices as predicted by the model. So my empirical exercise is a definitive exercise, a multinomial logistic regression, which tries to look at the impact of improvement in judicial speed on different occupational types. And then it also looks at the allocation. How does this improvement in judicial speed impact the allocation of talent across different occupations? Okay, and the key policy reform that I'm looking at in the definitive exercise is our amendments to the Code of Civil Procedure, which happened in 2002 across states in India, and there is a variation in the dosage each state got, and I exploit that in my definitive exercise. Okay, so
I'm gonna connect the last one with the second one.
So how do I go back? Yeah. Again?
You can also connect.
So there are results from the theoretical model on the occupational choices on allocation of talent across occupations with improvement in enforcement. And I am going to connect that with with an empirical exercise, I get the same results as
But
from the
you
model.
can get the implied change in saying external finance to GDP from the estimate.
Yeah.
See whether those
For the
magnitudes connect to the cross-country difference generated by the calibrated.
Right. So right now in the calculation, what I've done is I have, by varying fee, I have matched the external finance to GDP to the data at the state level. But then in future, I want to also directly incorporate the speed
changes.
Yeah, the actual speed of resolution of cases at the state level. So for now, I just and what I've also how I've connected with the state level data on speed of judiciary. I've looked at the correlation between the model calibrated fees as by matching with the external finance to GDP. Look at the correlation of that between the speed of resolution of cases at the state level. That's what I've done for now. But in future, I will more directly employ the speed of judiciaries in the calculation exercise. Okay. In terms of the important research work, so this is like a version of the Buera model. This is rather than a two-sector model, this is a one-sector model, but with 3 occupational choices. And I do a cross-state exercise versus a cross-country exercise. And in terms of the empirical exercise, so the identification strategy is directly from the Shemin paper. But in terms of the outcomes, it is different. So the Shemin paper looks at the impact of improvement of judiciaries on the productivity of informal firms in India. What I do is I look at the impact on occupational choices. That's the distinction from here. So how I'll go ahead is I'll first briefly describe the model, then I'll show the model results and the calibration, and then we go on to the empirical results. So as this is a heterogeneous agents model, so there are heterogeneous agents who are infinitely lived, and they come to any time period with 3 important variables, which is the amount of wealth they accumulated from the last period, their entrepreneurial productivity, and their availability of labor opportunity. So Z, which is the entrepreneurial productivity, is assumed to be a persistent AR1 process. Fancy L, which is telling whether you have a job opportunity available in the market or not, is assumed to be an IIT process for simplicity. And both these shocks, Z and the L shock, that every individual gets, are independent of each other. And so what any individual is trying to do, he's trying to maximize his expected utility over the infinite horizon. And in trying to do that, he's taking 3 important decisions every period. So he's trying to decide how much assets he should carry forward to the next period, how much capital and labor he should borrow in case he is able to or wants to be an entrepreneur. And then there is this occupational choice decision that he makes optimally every period. And in every period, he has this budget constraint. So how much consumption he has in this period and how much he wants to carry forward to the next period is bounded above by his income and the wealth that he's gotten from the previous period. And so the income comes from his occupational choice, and his occupational choices either give him profits if he's setting up a firm, and then otherwise they give him a fixed wage. So we'll look at the occupational decision. How is that happening in the model? So based on the realization of his fancy L shock, that determines whether he has a job in the market or not. So if fancy L is 1, which has a probability of chi, he has an opportunity to become a worker, in which case he chooses to become either a worker or a firm owner. If he chooses to become a worker, he gets a fixed wage, which is independent of his entrepreneurial productivity. And or versus he compares his profits, and whichever gives him more, he chooses that occupation. If fancy L is 0, that means that he doesn't have a job opportunity available for himself. And in that case, the only thing that he can do is to set up a firm. So, but in the second case, so essentially there are two. So when he doesn't have a job opportunity available for him, either his profits would be greater than the wage rate or less than the wage rate. In case they are less than the wage rate, so the idea is that he's an involuntary entrepreneur and he's forced into entrepreneurship. So I call him an informal firm owner. Otherwise, he is a formal firm owner. And in the first case, all the firm owners are those who earn more than the wage rate. So therefore, in the first case, all firm owners are formal firm owners. So that's the distinction. And the production function is Cobb-Douglas, decreasing returns to scale. And this is your expression for profit, which is revenue minus payments on rental payments minus the wage payments. And there are these banks who are allocating capital and they're not making any profit. So that's the assumption of the model. And so here is how imperfect enforcement comes in. So fee measures the degree of enforcement in the state economy, credit contract enforcement in the state economy. So if fee is higher, that means that there is better enforcement of credit contracts by the judicial system. And if fee is lesser, that means that there is poorer enforcement of credit contracts. And so based on whatever state economy you are in and what is the level of assets you came into the period with and your entrepreneurial productivity, you have a capital constraint in terms of how much you can borrow from the financial markets. And how do you determine how much is the capital constraint on any individual? This commitment constraint is what tells you that. So the idea is the following, that banks don't want individuals to run away, don't want the individuals to have any incentive to run away with the capital which is rented to them. So what they do is that they enforce a constraint such that there is no incentive to renege. So when would individuals not have incentive to renege would be when the gain from not reneging is greater than the gain from reneging. Okay. So if they do not renege, what they get is the profits that they have, and they get the assets that they deposited as collateral back to them. If they choose to renege, they can run away with the undepreciated capital. They don't pay the rental payments, and they also get to keep the profits minus the wage payments, and actually the 1 minus fee share of this entire of all these things based on the level of enforcement in the economy. So when you solve for K according to this constraint, we can easily see that how much you can borrow is increasing on fee A and Z, which means that if there is better enforcement on average, you can borrow more from the state, from whatever state you are in. If you have more assets which you can deposit as collateral, then also you can borrow more. And if you are more productive, then also you can borrow more. So that's the idea. And then there are these all these individuals are making these optimal choices. It's an infinite horizon model. You're constrained every period, and then you solve for the steady state, which is a stationary joint distribution of A, Z, and L, in which another steady state, all markets are clearing, capital, labor, and consumption goods. And so capital markets are clearing, labor markets are clearing, and the demand for capital is coming from all the firms for all the entrepreneurs who are setting up firms. Supply of capital is coming from all individuals who are saving something. Demand for labor again is coming from all firms, and supply of labor is coming from all the individuals who chose to become one. Okay. So this is just a recursive representation of the same problem. I'll skip that in the interest of time. So in terms of the solutions to the models, I'll describe the occupational choice policy function very briefly. There are two key results from this. One is, so here I'm comparing two cases, fee equal to 1 versus fee equal to 0.5. Fee equal to 1 means perfect enforcement, and this is the case of imperfect enforcement. And formal firm owner worker, so this is again fancy L equal to 1 versus fancy L equal to 0. In this case, individuals had an option to become a worker in the market. In this case, they didn't, and they both are essentially mirror images of each other. Because informal firm owners are precisely those who couldn't become a worker and they were forced into entrepreneurship. Okay, so the two key results here are the following. So one is that as the degree of enforcement becomes poorer, assets matter to your occupational choice. So in the first case, in the case of perfect enforcement, there was a clear cutoff, which was dependent on the wage rate, to determine whether you were a formal firm owner or a worker. And that decision was independent of your assets. In this case, in the case of imperfect enforcement, now assets also matter in your decision of becoming a formal homeowner versus a worker. And so the lesser amount of assets you have, the lesser you can borrow from the financial markets, the lesser profits you can earn. And so the lesser assets you have, you are more likely to become a worker. So that is one result. And the second is the general equilibrium result, which is important here, which says that as the degree of enforcement improves, your rental rates, your interest rates and wage rates also increase. And that is coming precisely because as now people can borrow more, there is more demand for capital. And because this is capital and labor are complements, there's also parallelly more demand for labor. And that effect, aggregate demand effect, is more than the aggregate supply effect. And so therefore, as contract enforcement improves, your wages, your interest rates, they also increase. And that is clearly visible as this cutoff has gone up between the two diagrams. So there is that. So these are some simulations on the various outcomes. So as fee goes up, your enforcement improves. And you can clearly see that the interest rates and wages are also going up, as we just discussed. Yes.
Is there no capital market integration across Indian states?
Yeah, this is the simplifying assumption that I've made so far.
Do you have a sense of how much?
There is variation in terms of interest rates across states in India. There is this Linenfield and Mukherjee paper, which actually predicts the same result on the interest rates across states in India. That if enforcement improved, then the better the enforcement, the higher the interest rate of the state.
But you can compare the implied interest rate with the data.
Say again?
You could compare the implied interest rates.
Yeah.
So,
yeah. I could do that, but I haven't done that. Yeah.
But also, the integrated case at some level, it will be, you will have to solve jointly for all the.
Yeah, I mean, I can try to do that. I mean, I may do that.
I mean, it's not like it will not be that, but now currently you're solving.
There are a lot
how many
states
are there? Like
28 states.
28. Which is, if I say 20, you solve the equilibrium. In integrated case, you will solve for get one capital market equilibrium and 29 labor market equilibrium. So it's, in some sense, one could argue it's simpler.
I can try that. Okay. So, and if you look at the per capita output and capital, they are also increasing as the misallocation in the economy decreases with improved enforcement. And also capital demanded and supplied increases, that increases the level of capital. Then the interesting result, which I'm also validating with empirical results, is on the occupational choices. So what we see is that in terms of the labor share, on average, there is an increase in the labor share as you increase the amount of credit enforcement. And this is precisely driven by the wages. So as wages in the general equilibrium pace increases, individuals are now choosing to become workers over formal firm owners. But at the same time, so parallelly, I also see that on average, there is a decline in the formal firm ownership. But what is interesting to see is that now, even though in terms of the shares, formal firm owners have fallen, but it is the case that now whoever are left in the formal firm category, they are the most talented of entrepreneurs. So, I mean, that is the interesting result here, which is the general equilibrium result. In terms of calibration, I'll just discuss the two. So there, most of the parameters right now are directly from the literature. And I've calibrated the two key parameters which I've calibrated at the state level are the fee and the CHI parameter. Fee was a credit enforcement parameter. CHI is what determined whether you got a job opportunity or not. So I've calibrated this by matching the model outcome in external finance to GDP to credit by commercial and rural banks by GDP at the state level. This is from the RBI Handbook of Statistics on Indian States. And in terms of the worker share, on Chi, I match the worker share to the workers in the working population. This is from the labor force surveys. The NSS unemployment and employment surveys. And so what I do is now with these calibrated parameters, I solve the model for each state and I determine the variation in income per capita determined by implied by the model. And then in the end, I also compare the model calibrated fees with the state level data on judicial speed. Okay, so here are some results. So in my paper, I've done this exercise across all states in India. So here I've just shown 4 states. And if I look at this, so this is my model predicted outcome, and this is the data. And so here in Delhi, fee is higher, which means that the judiciaries are better. And Bihar, fee is very, very low, which means that the judicial system is very poor in Bihar. And similarly, it also seems to be the case that CAI is higher in Delhi, which means that there are less labor market frictions and you can easily find a job in Delhi versus, let's say, in Bihar. And then I compare the model outcomes with the data. I do a regression of Y data on Y model. I get R square of 19.74, which is trying to say that CHI and fee jointly explain this much percentage of the disparities in income per capita across states in India. And then and the other model outcomes, GDP per capita, occupational shares, formal firm shares, they also seem to be positively correlated, the model outcomes with the data outcomes. And then in the end, I also look at the correlation with the speed of judiciaries in the states. So this is from the NJDG data, which has data on the average age of disposed civil suit cases. And 1 by the average age of disposed civil suit cases is the measure of speed, 10 minutes. So it seems to me that this data is correlated with the model calibrated. So now I'll talk about the empirical exercise. So now this is based on the amendments to the Code of Civil Procedure in India. So this code essentially determines the rules with which the judicial system in states operate, especially the civil courts. And so there was this major reform in 2002. There were these new set of rules which were now applicable to all states. And there was several amendments to whatever were the rules in previous years. And there were many such amendments, such as encouraging out-of-court dispute settlement, setting mandatory time limits at each stage of litigation, limiting use of right to appeal, and so on. So all these amendments to improve the speed of the judicial system. But what brings in the variation across states is the idea that some of the states had already made amendments to the same rules in previous years to different degrees. So in a sense, in 2002, each state got a different policy dosage of this reform. And I exploit that variation in a definitive setup to look at the causal implication of this reform on occupational choices. Yeah.
Just let me ask you a little bit of the setup. Is there the way in this setup is with common law that expressing and then judges learn, people slowly start to get noticed about this? Or because you're making it sound like it was like, here it comes and everything changes.
No. So there is some change to every rule which is applicable. For example, setting different timelines for different set of things. For example, setting a different timeline by which a particular type of case gets settled. And let's say in some states it was 30 days, in some states it was 15 days, in some states it was, let's say, no time limit. And there is this reform that sets a new deadline. And now there is a net change to each state in terms of how much time it will take to resolve that particular type of case. So that's one example. Okay. So the outcomes which we are trying to look at are the occupational types, and which I'm taking from the NSS employment and unemployment surveys. So I have looked data from pre and post years. Right now I'm just showing one pre and post year, and I've also done exercises for future years, but they were slightly incomplete, so I'm not showing them here. So the reform was in 2002, pre-year is 2000, post-year is 2005. And in this data set, there is the key variable is the activity status. So within the activity status, there are these 3 important categories for us. The employer, the own account type, and the worker. Employers are those who are running a firm and they're employing other people. And this is my proxy for formal firm owner. In terms of informal firm owner, so I look at the own account type category. These are those individuals who are running the firm on their own, but they are not hiring someone else. So this definition is what is available in the data, but this is slightly different from the model. In which case there were involuntary entrepreneurs and you had to earn below the wage rate. And there's not good data on the wage rates in the data set. So this is the definition that I take. And the worker category are those who are working for someone. And then I have a bunch of controls. And then I've also used a proxy for entrepreneurial ability to look at the allocation. Yes.
Two things. First, if I understand correctly, there are like debt recovery tribunals in India. So
Yes,
that's
yes.
courts that are being used for the
Yes. So yeah,
Does that apply to these?
Yes, so the reason why I'm not used, so there were these debt recovery tribunals also, which were introduced in the late 90s and the early 2000s. There are two reasons why I haven't used it. One is, of course, the lack of data on employment at that time. The other is that they were applicable to only a very limited range of cases. So only cases which were given loans beyond, let's say, 10 lakh rupees could go to the debt recovery tribunals. And here,
But aren't those the really important ones?
no, because I also have the informal firms here, right? And they might be, taking smaller size loans. And the other reason is I don't even have data on occupational choices in those years where the debt recovery tribunals were introduced. So this is the best I could.
And the second thing is, so do you actually have evidence that these reforms did anything in the functioning of the courts? So my sense is that kind of the Indian judiciary did a lot of different things and tried a lot of different things, hiring, and in the end, nothing really did anything.
No. So there is direct evidence in the Shemin paper from which I've taken this identification strategy.
But he only looks at firm level outcomes, he doesn't look at.
He does look at the courts also. The improvement in the court speed. So that's the first thing that he does. Yeah.
But why is this allocation a proxy for entrepreneurial productivity specifically?
Because there's nothing else available. It's just
for workers there's because it could be also for worker productivity.
I wanted to do something.
Let's take 5 minutes so let's give some time to.
But I think it's not a very good proxy. And in the model, the wage, everybody gets the same wage and it's independent of the productivity. So I just took it as a proxy. I know it's not a very good proxy. So this is my occupational choice regressions. I'm trying to predict the log odds ratio. And here I is the individual. So this is individual level data on occupations. So I is for individual, S is for state, T is for time. And this is a multinomial logistic regression. There are two equations. The first one will have the log odds ratio of choosing to become a formal firm owner over a worker. The second equation will have log odds ratio of becoming informal firm owner over a worker. And so there are state fixed effects, time fixed effects, and this is your interaction term with the policy dosage that each state got with the amendment. And beta is the coefficient which is important to us, which looks at the causal impact of the reform on the occupational choices. And then I also control for education. And then there is a second interaction term, which looks at the, this term interacting with education, which is trying to capture what is the additional impact on somebody who's more educated versus less educated of this amendment. Per unit increase in education, per unit increase in the policy dose. And so I've controlled for individual factors, state level factors, important confounding factors. And this is my result. And if you look at here, so I've looked at the marginal effects. So, this is the coefficient of interest, this row, and this is the coefficient of interest of the interaction with education. So what you see here is that as judicial enforcement improves, the formal firm share, the probability of choosing to become a formal firm owner actually falls, and the probability of becoming a worker increases. So that's in line with the model results. In terms of education, this is like a clear, this is also in the model. So if you're, not for workers, but for these two categories, if you are more skilled, then you're more likely to become a formal firm owner. If you have, in the model you had entrepreneurial productivity, here it's just education. And if you are less skilled, you're less likely to become you're more, if you're more educated, you're less likely to become an informal firm. And this is your interaction with education, and what this says is that, so even if on average, the share of formal firm owners falls, it is the case that somebody who's more educated, his likelihood of becoming a formal firm owner increases, and somebody who's more educated, his likelihood of becoming an informal firm owner falls. So that's it. So I mean, my empirical results are kind of in line with the theoretical model. And yeah, so that's
So
my work.
you have data on credit intermediation, because you can look at the whether credit intermediation is increasing with the reform.
How do I measure that?
I don't know, measure credit to GDP in the state.
Yeah. So yeah, I can do that.
So that the reform lead to more credit intermediation.
I'll do that. I somehow not done that, yeah.
Like if you do that, then you can have a sense of by how much the fee is increasing. And then see whether the model increasing fee.
Right, so let's say at the state level, what's the aggregate credit bill?
Exactly.
Yeah, okay. So at the firm level, there are lots
That
of
would be a nice way
papers.
to connect with the model, because then you can see whether
Right.
the changes increase the variation, the implied.
Yeah.
You can also have a panel of firms, marginal product dispersion at firm at the state year level.
Yeah.
So panel reflection, just like one.
Yeah. Thank you very much.
Okay. Now we're lunch and comments and questions, conversations. You look at how, at the merit outcome, the GDP or investment of the.
Yeah,
You
what
guys-
is the aggregate amount?
This data,
No, it's the one.
Yeah,
The first one is, so I like this thing.
At the firm level, you do a lot of work, but at the
Separate risk.
aggregate.
because these regressions are at the firm level or the
It's a
regression?
firm level.
These are firm level regression.
No, these are individual level,
Because
not.
The individual level regression. So the variations are at the state
Yes.
and you're clustering at the state level. Well, speaking on the state of connected to is, you can do this with prior regression. What is the effect of the reform on the state level GDP? You can say the same for state level intermediation, the state to GDP. And then you can do.
Yeah, so what I'm wondering is this consistent with the model?
The implied change in
Measurement error.
on fee.
And just, yeah, exactly. But then.
The generate some a given change in.
Right. Right now, you're kind of just.
Intermediation to GDP in the model.
Focusing on the variation.
Lead to changes in output that are consistent with the micro evidence. And you can connect the two.
So like in a different distance.
No,
Just like a simple.
in a distant leaf, you can estimate the effect of the reform on GDP and the accredit to GDP. And there will be some relation between the
But you're saying just.
and then you can do in the model a change in fee that generate a given change in accredit to GDP at the state by state.
Oh, I've done that.
No, but you did in the model that as a change fee, you change GDP. That way you did.
Yeah.
But I wanna change in fee.
No, I did employment shares. But I didn't do capital.
No, but I didn't do the separate.
I'm saying the model you do state by state, this is the fee, state and this.
I just feel like what that right now is like
Like,
treating this
then
as
you compare that with
a bond would have like, it's like.
I'm saying that now you have a reform. The reform
You
generates
just
a
measure the
lead
effect
to
of this allocation.
Okay, you're saying like before and after the reform?
yeah.
Whereas I'm feeling
The reform
kind of
generates
like
some change in external financial.
writing on a model that just comes.
You can see, first you can see whether the reform is more.
And it just not sure this.
In the more intermediation, that is the kind of, the mechanism is the model, the reform is more credit. If you give more credit, Right, changing the computer choice, children can see as not
Out near aggregation and.
Right.
But you can use it, can you say, well, what is the
We're doing is we're having.
what is the exogenous changes in maximum GDP generated by reform?
Planners trying to optimize.
And how that changes GDP sales in each state.
The other way to think about
So
it.
that you get that from the data. You can plot
Right,
so
the
change, this is the causal change in compared to GDP, and that's now and the causal changes in GDP. And then you can say, so when in the model, I give you the change in fee, the change
Allocation.
for each state, I can do it for each state, what is the change
And
in?
then what is the lowest amount?
Yeah, I give you a change in fee
Allocation, I can
at the
do
state level,
last.
that is consistent with the one that you observe in the data.
Right.
No problem.
Time already.
Oh, it's awesome.
Oh, I'm sorry. Everyone.
It's not a response, you're responsible. I said
We
that.
finished the,
I
finished the
shout.
presentation.
And the young teacher, no way.
You could be late. I feel like I was late. Probably.
Yeah, no, I had to be here. Okay. Okay, and we're very happy to start our team, even though we started late. But we're gonna pay back.
All right, I'll take it. Thank you very much for coming. I appreciate everyone staying and for coming to this conference. I enjoyed your presentations and chatting with you, and of course, I'm happy to chat after this or email or whatever. Well, I'd like to present to you about a slightly different setting than most of the projects so far at this conference, which is the 19th century US. This is joint work with Shannon, who's on the market. I'm an Andrews and Records at the University of Chicago. Our big picture question is trying to understand the spread and the adoption of new technologies. A pattern which has been documented in a variety of settings, including by people in this room, is that often it takes like a really long time, just qualitatively. Where there's an old technology and a new technology, and they not just coexist, but they thrive alongside each other. And so a natural question is, what are the underlying mechanisms that are driving this, and these mechanisms reflect inefficiencies or not? And so we're going to try to think about these sort of big classic question in the context of an iconic example of a new technology, which is the transition from water to steam power in 19th century American manufacturing. In particular, we're focused on milling for reasons I'll discuss in a little bit. So steam is obviously great. It offers a variety of advantages. I understand the last few days we've heard lots of conversations about why burning coal is bad. It's really good for me, but as an entrepreneur, it's great. It's the reason why they use it. And so, it offers freedom of location. So if you want to use water power, you have to be on a river. The river has to be moving fast. The amount of power that you have access to is a function of how quickly it's moving. Depending on where you are, that river may or may not freeze. And so steam is much more flexible and much more focused, and that makes it attractive to a variety of entrepreneurs. But nevertheless, it takes about a century before the US sort of starts using steam, which is already late relative to the UK, to when it sort of reaches its steady state level of production. So in this project, we're going to try to understand what's going on. Broadly, there's a few key forces. The first one that you might have in mind is the US is blessed with excellent water power potential. It remains the case that hydropower is an important source of electricity. And so if you have good water power, you're an entrepreneur, you want to start an enterprise, and the river's just right there, it's moving kind of quickly, like you might as well just use it because it's not that difficult. And so that's going to lead to some static differences in why people are adopting one technology versus the other. And then part of the adoption of steam power over time is going to be that this technology is improved. And so the initial steam engines are very expensive, and that makes them unattractive to a wide variety of people. And so as they get cheaper, that's going to lead to the diffusion of this technology. So this is a picture of a Porter Allen engine, which turns out to be really important in this particular sector because it was relatively cheap and relatively easy to install. But there's a wide variety of tinkering in America where people figure out exactly how to improve this technology. That'll not only lead to variation across time, but it'll also lead to variation across space, obviously. because some places have good water power potential and other places don't, and those forces will interact. But the thing I want to emphasize today is that not only is there the static reason why you might adopt one technology versus the other, there's also going to be dynamics, because if yesterday I was choosing what to do and I chose to build a water wheel, today I have a water wheel. And so if I want to invest in steam, the returns for that need to be even larger because they need to make up for the fact that for free, I already have access to a good technology. So this doesn't happen in America, but being in the UK, a 45-minute drive away is Maple Durham, which is a 1,000-year-old water mill. You can still go to it. You can still buy flour using very ancient technologies. And so because these technologies persist, they're not, the depreciation rate's kind of low. That it's very natural that dynamics is really important in this setting. But there's one twist. This is a period of massive churn and expansion in the American economy. And so only around 2% of the mills that exist in 1880 exist in 1850. So even though this technology is relatively durable, it's still the case that there's lots of new entrants. And so in so much as inertia at the level of an enterprise matters, it can't be the only driver of slow adoption because there's just not that many initial incumbents who are still putting around by 18 years. Okay, and so that's going to be kind of the key question that I'm going to try to tackle over the course of the day. All right, so this relates to a wide literature that I won't try to touch on. The one thing I'll say is if you're interested in the economic history of what I'm chatting about, there's a series of books by Lewis Hunter that talk about water power and then steam power and then electricity, which are very interesting. Okay, so the way I want to start is I want to start by giving you like a broad overview of like conceptually how we're thinking about this problem of what millers are choosing to do statically across space and over time, right? And so you should think of firms as being associated with a particular baseline level of productivity. So there's some entrepreneurs that are better at talking to customers, they're better at dealing with inventory, they're just, no matter what technology they choose to use, they're just gonna be able to charge a lower price and be larger. There's going to be a productivity associated with the technology that they use, either water power or steam power. I'll show you later that steam is a relatively high productivity technology. It's easier to scale. And then potentially there might be spillovers associated with technology. So it might be the case that if I use the technology, that makes you better at using the technology because we chat with each other, as came up earlier today. And so those are going to be the things that determine firm productivity. And there's going to be a bundle of inputs on which I have nothing to say, and you just linearly convert those inputs into output that you sell on a local market. So now the key choice that you have access to, your productivity is something that's just granted to you based on your innate characteristics. And so the choice that you have access to is which power source do you use? Do you choose water power or do you choose steam power? This is think of like a very mechanized sector. And so the cost of the technology is going to be, let's say, nothing if you just keep what you have. It's going to be some purchase price if you're an entrant and you need to buy something new. And then if you're an incumbent and you want to switch technologies, then you have to pay that purchase price. You have to buy the thing, and then potentially you have to pay an additional cost relative to what an entrant has to pay. What does additional cost have to be? It could actually be a negative cost. So it could be potentially that I get to sell my existing technology and buy a different technology for cheaper, in which case the net price I pay is negative. It could be that there's a retrofitting cost, and so I have to change what exactly I'm doing, and so I have to pay an additional cost relative to an entrant, given that I have a structure, or it could be zero. So I don't know what it is ex ante, but even if this is zero, so even if entrants and incumbents pay the same actual cost for a new technology, there's still going to be inertia at the level of the enterprise, for the reasons that we discussed, which is when you're thinking about how to maximize your revenue, if you have water, the additional benefit of switching to steam is going to be less, even holding the cost fixed. Okay, and so firms are going to make forward-looking choices in order to maximize the net present value of their profits, which are going to be a function of what are the profits of each power source, what are the costs of switching each power source, and how long do I expect to work. And so it's going to generate some very simple predictions that we can then take to the data. So what are those predictions? So the first is the most natural one. We've known this for over 20 years, that the more productive firms, because they can amortize its higher fixed cost over more sales, they're going to choose steam. Less productive millers are going to choose water, and then the least productive ones are just going to produce it all because it's not going to be worth it for them. And then as water gets more expensive, so as I mentioned, there's a lot of variation across the US and water power potential. And so in so much as that makes it more expensive to access water, because you need to do more to interfere with the natural environment in order to be able to use it. What that's going to do is it's going to make it so that the least productive millers, like the sort of marginally least productive millers, don't enter at all. And sort of the marginal users of steam are gonna decide to use steam instead of not. So it's gonna squeeze the share of water use from both sides. Okay, so the underlying technology, the underlying geography is gonna affect what the distribution of power sources look like across space. Over time, what's happening is this technology is improving, for instance, through the Porter-Allen engine. And so if you hold prices fixed, which obviously is not what happens in the real world, but conceptually, if you hold prices fixed, that's going to mean that the water cutoff stays the same, but the steam cutoff falls because less and less productive entrepreneurs are able to say, oh, like I want to use steam because now it's relatively cheap. Previously, I was marginal. And GE, so later when I'll show you the full model, that's also this entry is going to affect the underlying prices, which is also going to affect the survival of the marginal water users. But for now, let's just think about holding prices fixed. So those are the choices.
Sorry, just a quick question, because before you were saying that there are these different machines that were developed over time, but right now you're kind of abstracting from this that maybe if I already do steam and then there's a new steam innovation, you don't model this as like another adopter cost, right? But it could be that now I have to install like a whole new thing.
Yeah, so it turns out that a lot of the innovations for steam power that we have, I'll show you some estimates for this, are that it changes the purchase price of the steam engine, but it doesn't actually change its like operating cost or its marginal cost.
Okay.
And so you wouldn't necessarily want to go from an old engine to a new engine.
Okay.
And so you don't need to like rebuy the technology. Like every period, if you want to switch technology, you buy whatever the frontier is. But like the vintage doesn't really matter from the perspective of what the production looks like today.
But you're gonna have prices and all that
We're gonna have price, yeah.
for the steam engines and all that.
I mean, I don't observe prices in steam engines. I'm gonna back out what they are given the path of technology adoption. Okay, so that's what the entrants are doing. So what's happening to the incumbents? So even if there's no switching costs, even if the retrofitting is free, even if like you can just buy the thing, because they already have the old technology, there's just gonna be this like locked-in area where an incumbent of a certain productivity, were they to be an entrant, would choose steam, but because they already have water power, are going to stick with water power. That's true not only in the first period, but that continues to be true over time. So as steam power improves, there's going to be new entrants, forward-looking new entrants. They're making the optimal choice. No one's confused. No one has uncertainty. No one has risk in this particular model. But they understand that even though the price of steam is falling, the optimal thing for them to do is to use water today and then be stuck with it tomorrow. If tomorrow they could have their factory burned down, they would rebuild with steam, but that's not what happens, and so they don't. Okay, and so what I want to emphasize for over the course of the presentation is this region, this recurring lock-in. That the reason why inertia matters for technology adoption isn't because some of it is the initial users who keep puttering along, but some of it is that there continue to be entrants who have access to a new technology, but instead choose to use the old technology. And this is going to happen in environments in which the new and the old technology are horizontally differentiated, which in this case is going to be that steam power is associated with a higher purchase price and higher operating costs, but a lower marginal cost.
Just the entrants are the ones that I got confused. The lock-in are the ones that choose not to change, no?
Yeah.
And the new entrants will enter between feed 3W and feed 3L, or?
Yeah, so these are the entrants. So over time, the entrants are making the slightly worse entrants are choosing to adopt steam as steam is improving. But this entrant understands that that steam is getting cheaper over time, and so this entrant then becomes locked in. They would have switched to steam,
But they already did.
but they've already chosen.
So this is exactly the error replacement effect in Chapelier growth models. That's why incumbents don't choose to innovate and entrants do. Exactly because they're locked in. By the way.
So okay, so the key forces that I want to chat about are these dynamic forces. Let's compare entrants to incumbents, and these geographical forces, what's happening across space. And so in order to do that, we're going to put together a variety of data. So the first is data on local water power potential of the United States. And so for that, we're going to use hydrographic models. So the US government estimates what water power, and particularly what flow rates, would have looked like in the 19th century in the absence of modern interventions, things like dams and industrial activity. And so this is what rivers would have looked like if you showed up in the US in 1850. But water power potential turns out to be the product of how much water there is and how fast it's moving, so what the fall height is. So the product of these two things is water power potential, which means there's a fair amount of spatial variation on both. There's some places that have rivers, but not fall height. Think of the Mississippi River. There's some places that have fall height, but not rivers, obviously, and there's some places that have both. And so forward looking, when you think about, in so much there's gonna be some identification in our regressions, we can think about water power potential as the interaction, and therefore we can control separately for all of the features that you get if you're rugged, and all of the features if you get if you have access to water. And so that's what this map's going to look like. The second thing that we need, which I think is the more useful contribution potentially for people in this room, is data on what it is that manufacturers in the 19th century were doing. And so in particular, we digitized the entire extant census of manufacturers. So we know for about 1 million enterprises over the course of these 40 years, what it is that they were doing. So we know their name, we know what industry they were in, we know how much they're selling, and in particular, because it was so important for activity at the time, the census asked, what is it that you're using for your power source? Okay. And so we entered this data, we cleaned this data. Obviously, industry codes don't exist yet, so we have to put it together. So there's some amount of choices that get made, which I've already chatted with you today about. And so what the rows are here, these are the sort of the sectors, sort of the aggregate sectors that we think exist in the US economy in manufacturing at the time. And the way I've ordered them is how mechanized they are. So the black area is the number, this is in terms of the number of establishments. You could do it by output, it doesn't look super different. So the black is steam use, the dark gray is water power use, and everything else is in the light line. Okay, yeah.
What do you mean how mechanized they are?
So this is the number of steam users, the number of water users, and the number that are basically not using mechanical power.
Okay.
Probably got the number of establishments doing.
And this is the total number of establishments, yeah. And so there are a few things I think jump out at you from this graph. The first is that there's like 2 large, extremely mechanized sectors in this economy, which are lumber mills and flour mills. And because I'm interested in the switching from one technology to the other, these are going to be the sectors that I'm going to focus on today. There's other sectors which are really interesting. So for instance, boots and shoes, new technology gets invented, which allows it to become complementary with steam power and just kind of leapfrogs. Boots are never made with water power in the United States. They go from being an artisan handcraft to being made in factories. Super interesting, not what I'm talking about today.
After that, no. Oh no, at the end you say.
Yeah.
And then what is iron and steel by hand? This is just.
So they have
like shops of doing.
Yeah, well, it's a blacksmith.
Blacksmith.
Yeah. So there's like a middle, like there's the smelting area, and then there's the blacksmith,
and there's hammer or whatever.
Yeah. The other key reason we're going to focus on lumber and flour is given the technologies that were available in the 19th century, you can't really trade them. They both perish really fast. And so the way these markets work is wood, like logs and whole grains, get shipped to the destination market, and then they get ground basically to order. And so you should think of these as like almost like local services, and so there's not a lot of cross location trade. Whereas something like textiles, which also is a very mechanized sector, obviously famously, but it's very tradable. And so if you're in a place that doesn't have very much water power potential, that's fine. You can just buy textiles from somewhere else, but that's not particularly true for lumber and flour in most of the United States. Yeah.
But in textiles, I'm surprised to see sort of a reversal over time.
Oh yeah, this is a really depressing crisis. So there's a few industries that you see collapse: textiles, chemicals, metallurgy, like a bunch of the important ones. What happened is in 1880, the census hired industry experts to do the surveying instead of basically like US Marshals. Because the industry experts were competent, they could do the tabulations themselves. And so they never sent the underlying data back to the US Census, and it's been lost. And so the reason why I said the entire extant census of manufacturers is the interesting sectors in 1880 don't exist. We don't know where they are. We've never found anywhere. No one's ever found any records. But like to the point that lumber and flour are local sectors, they were like, yeah, there's everywhere, but they're boring. Everyone has lumber and flour. We don't like, doesn't matter that much. And so that's why these weren't in those special schedules.
Can you weight by sales or quantity?
I can. There used to be a button. You get a similar picture. So lumber is the largest sector by output and the second largest by sales, and flour is the these are 2 largest sectors in the US economy.
In terms of like how these shares shift over time, does it matter whether it's sales weighted or just counts?
Oh yeah. So the sectors that are very mechanized but don't have that many enterprises by sales grow a lot. So like textiles by dollars is much bigger. than it is by number of establishments. But the key thing I want you to get from this picture is these are like incredibly mechanized sectors and they're very large. They're everywhere.
And lumber is just doing construction, no? Just input for construction lumber.
Yeah. And so actually for the rest of the talk, we've checked some of the hand powered ones. And typically I think it's just like measurement error. Like in fact, they were mechanized but they just, for whatever reason, they either left it blank or they recorded something bizarre. And so for the purpose of the talk, I'm just gonna ignore the hand powered mills because they don't work. Yeah.
It is a transportation course, does access to coal mines a bit matter to the oceans too?
Yeah, so places that have access to coal do adopt steam power faster. It matters a little for switching, but not in interesting ways, and so I'm not gonna talk about it today. If you're interested, lumber, they use sawdust a lot as a source of power, but actually we see similar patterns for lumber and flour, so I don't know coal access is important. But yeah, in the US, as in many other contexts, coal is an important driver of steam. Okay, and so because I want to think about both entrance and incumbents, and you have a panel, so just have a name, and so I'm gonna, for every single enterprise in the data, we checked every other enterprise in the following decade based on its name, and we link them by hand. We tried fancier things and they were like a horrible disaster, so we did it by hand. I mean, you guys might be more confident than me, you might be able to pull it off, but I could not. And so what that means is the example picture that I showed you before, I obviously didn't pick it randomly. It's a mill that we know from other sources, like the history of Warren County, Pennsylvania. We'll talk about this as an important mill. And so we can verify, in fact, that this mill continues to exist throughout the period. You probably can't see it, but if you squint. So in 1850, it's the Alston Rogers Mill. By hand, or the rules that we followed were such that this becomes the LP Rogers Mill. But LP Rogers, Alston Rogers, that seems close enough. And so Rogers to Rogers we link. In fact, from the sense of population, we know that what happens is that Lucian takes over from his father when his father passes away. And in fact, as is often the case in a variety of contexts. So Alston Rogers uses water power, Lucian takes over from his father and uses updated technologies as younger generations sometimes do. Okay, so that's going to be the data that we use. I've now told you the patterns that we want to find to see if the model sort of predicts what's going on in the data. And so now let's do it. Okay, so the first picture that I want to show you is what entrants are doing. And so in 1860, so I don't know who's an entrant in 1850, right? Because I can't link it to previous census. So I only know in 1860, did you exist before or not? Was I able to link you before or not? And so in 1860, around a third of the new enterprises are choosing to use steam power. So that means the remainder, the white bar, is choosing to use water power. And that share is increasing over time. Okay, so whatever's happening in the economy, it's got to be the case that steam power is getting more attractive, right? Because entrants become more likely to use steam over time. What's happening to incumbents? In any given period, the incumbents are substantially less likely to switch. So potentially something about history matters. There's some inertia. But also they're increasing more and more over time. So also the incumbents seem to be reflecting the fact that steam technology is improving. Okay. So how is it that steam technology could be improving? Well, there's kind of two dimensions. One dimension is that the costs of steam are improving, they're getting cheaper. And the other is that the benefits of steam are improving, like the marginal costs are improving. And so in order to think about which of those two forces is driving this adoption, we can turn to a variety of other moments in the data. And so the first is we can look at the firm size distribution. And so this is the distribution of sales for water powered mills. This is the distribution of sales for steam powered mills. I'm showing you pictures for like the whole US just because it's easier. If you want, you can also look within county, you get the same picture. So there is a lot of obviously geographic spread west of the US over the course of this time period, some of which might be driven by steam power, but all of this is true even within, everything I tell you is true within locations. And eventually when I estimate the model, I'm just going to use within location moments. And so you can see that steam powered mills are systematically larger than water powered mills. Okay, so what does that mean? Well, the natural thing is the story I already told you, which is that steam is easier to scale, you can charge a lower price, it must be associated with a higher productivity. Okay, so that's true in 1850. What happens over time? Over time, the firm size distributions converge. Okay, but we know that steam is getting better because it gets adopted more and more. Okay, so the firm size distributions converging implies that what's happening is not that the marginal cost of steam were improving, because if steam was just becoming more and more efficient, we got better at turning coal into power, then what we'd see is the biggest steam users get to be even more larger, because now they get to charge an even lower price. The fact that we see this convergence is consistent with the idea that the less productive people who are now attracted to steam, and so they're kind of smaller. That's going to lead to convergence in the firm size distribution. But you can see also there's a lot of overlap. You know, the simple model I showed you was one with very stark. There's like a region where you do one thing, there's a region where you do another thing. Obviously, that's not true in the data. There's tons of entrepreneurs who are choosing to use steam, even though they're kind of small, or choosing to use water, even though they're kind of big. And so when we fit the data, we're going to want to think about, you know, what are the sources of idiosyncratic variation that are driving it. Okay, so that's what's happening on the benefit side. What's happening on the cost side? In order to think about the relative costs of steam power and water power, we're going to look at exit rates. So for firms that exist in a particular census year, can we find them in the subsequent decade? And what we find is we get a match rate of around 20 to 25% decade to decade. This is a little bit low relative to what you'd expect in modern data. So it reflects an exit rate of around 10 to 15%, is around to like 7 to 8%. Some of that could be because we're just having trouble matching. Some of it could be true. I can't speak to that, but we're not getting crazy numbers, so we feel pretty good about that. And then consistent with there being a fixed cost of keeping the lights on, the larger you are, the more likely it is that you survive from one decade to the next. This is also a standard pattern that's found in modern data sets. Okay, but even though steam users are larger than water users, I just showed you that, they're less likely to survive one decade to the next. Why? Well, we think it's because steam is associated with high operating costs. What are those operating costs? Well, you might be thinking to yourself, this doesn't make any sense. Because I've seen a river, and rivers just flow for free. And I know what a steam engine looks like, and for a steam engine, you have to feed it with coal. And you need to hire a skilled worker to deal with it. So how could it be that steam has lower marginal costs than water is? Because water is free. And the answer is a lot of the things that come to mind when you think about the costs that are associated with steam but not water, those are basically fixed costs. You need to hire a skilled worker, but you can't just like hire that skilled worker for like the 2 hours a day you happen to have demand, like they're your employee. Similarly, ramping costs are really expensive with engines. And so when you turn on the engine, you kind of leave it on for the whole day. You know, like you can't be turning it on and off. And so that looks more like an operating cost. Similarly, this is true that we don't have depreciation in this model, but like there is depreciation. These are technologies which are associated with all sorts of disasters. And so we sort of think of depreciation as reflected in an operating cost, that in order to keep your engine running, you have to pay more every period in order to get it to keep working, okay? Those are gonna be the key forces that are in the main.
I guess I'm a little confused by the previous graph. Like, how is it if the marginal cost is lower for steam? How is it ever the case that water powered mills, that you end up getting the same size distribution?
Yeah, so it's still, I mean, like, this is a log scale and it's a very wide log scale. And so this is like, the typical steam mill is still like much larger than the typical water power mill. Like they're not overlapping. It's just because it goes from 6 to 12, like the gap isn't.
I see, so it's still.
But they're still like, I should know the number off the top of my head, but I don't, but they're still on average substantially larger.
So this logic that you just mentioned, it almost seems as if there's something intrinsically about scale that matters, right? It seems like with water, you could have very low marginal costs up to a certain capacity, and then you're stuck. So
Yeah.
it's the story of just fixed versus marginal costs. There's some tension there, right? Because I don't know whether for very small scales of operation, the marginal cost of water is really that high. It seems to me that once you get to a certain scale, it becomes binding. So just, it's not as simple, it may not be exactly just a simple fixed versus marginal. There's something about scale, but it's not.
Yeah, I totally agree with you. That one of the reasons why firms' behavior may reflect an effective high marginal cost of water power is because water is associated with a high shadow cost. That as you reach the constraint of how much horsepower is available on your river, you can just no longer expand beyond that. And so the correct model is not one where like everything is nice and linear. The correct model is probably one where for every particular water power site, we know how much power is available to you and we keep track of that. But I don't know where any particular enterprise is. And so I don't know for any particular enterprise where their constraint is. And so we're kind of modeling this effective shadow cost in the sort of reduced form way as a high marginal cost, even though in practice some of it might be the scale constraint.
Or the marginal cost of getting a flower to a city that is far away from a river.
Sorry, so they're not traded. There's very little.
But that's why, because then if you wanna get, you don't have a river, it could be traded, but it will be very high on the margin to get it. So it's a marginal cost for per location. If the location is far away from a river, the marginal cost of steam will be much lower.
So I'm yet to tell you about, I've told you how water power potential affects the marginal cost. I've told you how time affects the marginal cost of steam. I will get to how location affects the cost of water power, but I haven't shown you that yet, but that's also gonna be important because there is a lot of geography. So I'll get there in a soon.
But just one last point about this. So, but you can look at how much of this dispersion in size is happening within or across location within for each technology, right? It seems as if most of the dispersion of the size for farms that are using water should be across space, within space, there would be very little. You see that?
There's a ton of dispersion within space.
Even with water.
Even with water. But that's true, that's also true of water power sites. Like that's also true. So it's not that like if you have a county, everyone has access to the same sites. This isn't, I didn't say this explicitly, we're gonna focus on kind of the eastern part of the US. In the western part of the US, water rights become like super important, and who gets access to things first matters a lot. There's very little congestion here, but conceptually, like if I get the good water site, then you're left with like the second best water site. There's always a water site in almost any county, but there's rankings of them, and so some of that dispersion could be mechanical, and we just can't see it. Okay. And so as I mentioned, one reason why you might expect water to be more expensive is because of the shadow cost. Another reason why is in a few years, they asked how much horsepower was associated with the power source, and steam users systematically have more horsepower. There's a bunch of tasks that you do in milling, and some of them you can replace with mechanized power. So like either you have someone pick up the stuff and put it exactly on the grinder, or you have use the engine to move stuff around. You can use the engine to vacuum, to clean. And so there are a variety of tasks. And so even if the cost of power per se might be higher for steam because you can buy stuff, like the cost of production overall, it's going to be complementary with labor and make things cheaper. So I think that's why we're getting the patterns that we're finding. But some of it is exactly to Danielle's point that the river is just constraining you and we can't. Okay. So finally, as I already kind of previewed, and as you can imagine, if you look at the amount of water power potential there is, this is just a standardized version of how much water power potential there is, the sum available in the county normalized by the area, and the number of water powered mills. I'll show you a variety of patterns in a little bit. It's like shockingly log linear. That the more water power potential there is, the more people there are that are using water power. And now to get to Paco's question, like the natural question is what? Like, what is it about water power that makes it so that it becomes, the more that you have, it makes it more attractive? And again, the answer either has to be it's coming from the cost side or it's coming from the benefit side. And so we can compare firm size distributions in places that have lots of water power potential or not that much water power potential. And the places that have lots of water power potential, actually they don't have like really big mills, which would be the story of what water power potential does is it allows for like huge, cheap scale technologies. What high water power potential places have is they have relatively more really small mills. So why is this? It's because if you're in a low water power potential place, you need to intervene in your natural environment more. You need to build bigger dams, you need to build bigger river walls, you need to build mill ponds. All those are fixed costs associated with being able to marshal the underlying power available in your local river. And so it's not a marginal cost story for water power, it's a fixed cost story. Now I don't want to lie to you. Our data stops in 1880. In 1883, America imports a Hungarian technology which allows flour to be traded. And all of a sudden, almost all flour in the United States gets produced in Minneapolis. So those who've been to Minneapolis, they're still there, those buildings. And so eventually it becomes the case that like all milling in the United States or flour is water powered pretty much. But up until this point, that's not what's happening. So because this is like a sector in which stuff really isn't traded, you don't get these like huge mills in water powered sites until we figure out how to trade. So I think that sort of captures it. Okay, so now having shown you kind of like a few key moments about the distribution of power sources and sizes over space and over time, I want to focus a little bit more on what's going on over space, because of course it's like the key feature of steam power is that it's footloose, and so it's useful to understand, how does this matter for economic activity. And so first I'm going to show you some cross-sectional patterns like I just did in 1850. How does water power potential affect the economic activity that's going on in the place? And then I'll show you dynamically, how does water power potential matter? Okay, so I already showed you this in the graphic form. This is just a table form. The way I'm going to show you tables, just so we don't get confused, is I'm going to show you the effect of one standard deviation, less water power potential. So you have less water power potential, it's associated with having fewer mills. Makes sense. but it's associated with more steam share of mills. Okay, so even in 1850, where steam is relatively in its infancy, it's not new. Steam is not a new technology, but it's in its infancy. You see that places with less water power potential, there's already a higher share of economic activity that's being done with steam powered plants, right? So they're substituting from one technology to the other. Someone asked about revenue before. So if we look at the number of mills or the revenue of those mills, both for the sort of total, the number of water power using, or for the share that's using steam, it's pretty similar. Okay, but this fact that we're able to compensate in 1850 a little bit with steam power, it doesn't fully compensate. It doesn't even come close to the fact that just the underlying geography is worse. And so the total number of mills in places with less water power potential is lower as the total revenue. Some of this is because the price index is going to be higher, so there's going to be less demand. Some of this, of course, is going to be that places with less water power potential are the places that are less populated in the US, and so it might just be less demand overall. And so that's one reason why we're going to think about what happens in growth rates as well. Places with less water power potential, they grow faster in terms of population, but very little. And so the patterns I'm going to show you for growth rates, don't think that they're being driven by population, because population growth isn't that big. Population levels, it doesn't. Okay, so over time, what's happened? So I can show you pictures. I'll show you everything I show you me. I'm going to show you from 1850 to 1860, from 1860 to 1870, and then from 1870 to 1880. And so what happened? So the places that initially had or always had less water power potential, that initially had a higher steam share of mills, that steam share continues to grow between 1860 and to 1870. Okay, so that initial advantage continues to expand as steam becomes cheaper. These places with less water power potential are still the ones that find it relatively more attractive to adopt. Between 1870 and 1880, that's actually not the case. They're no longer growing faster. If you think about an S-shaped adoption curve, one way to think about this is that the places with less water power potential start reaching the flat part of the curve a little bit earlier. And so there's no longer that much like pent up supply of potential steam users. Similarly, the total number of mills in the places with less water power potential is growing rapidly over this time. And so even though initially they started out like way smaller, by 1880, they're still smaller, but they've like almost entirely caught up. Population is not almost entirely caught up, but the total number of mills and the total number of mill revenue has almost entirely caught up. So it's a little bit of like an advantage of backwards. Because you don't have access to good, cheap, old technology, you're able to adopt the new technology and it makes up for a lot of.
And this is the absolute number of mills, no?
This is the log of the total number of mills.
And if you do it per capita, you're gonna do it per capita or in the total?
So if you do this per capita,
I tend to understand if the places don't have mills, they have, is it because there are fewer people and they're proportionally the same, or is that they have to do something else to feed themselves?
So one standard deviation less water power potential is associated with like a 6% increase in population. So if you want to just subtract 0.06 from all of these numbers, that'll be per capita. So some of it's per capita, but very little. All right, so who's doing this? Who's the one that's making it so that we get more steam use? So we can split this into entrants and incumbents. And not surprisingly, given everything I've told you so far, it's the entrants that are driving this, this new use of steam. And so in every single period. But it's also the case that the water incumbents are adopting steam more. They're adopting it less than the entrants are. But even in the lower water power potential counties, the previous water using incumbents are attracted to switch to counties. Yeah.
Just clarification on. Are you worried that you're overestimating entrants just because you don't match them over time? Anyone that you cannot match, it shows up as an entrant, no?
So I'm worried about everything. So it's both going to be the case that we might falsely match incumbents to previous mills that actually weren't the same thing. So like we're matching Rogers to Rogers, but like there are many Rogers, so it could be a different person, and it could be that we're so.
Okay. So you're thinking that this okay.
So if that bias, whatever it is correlated with water power potential, then we're in trouble. And so the thing that we did do our best to estimate sort of a model to predict the matches. And the reason why we did this is then we can like when we do it by hand, we don't have a notion of like what's a marginal match or not. But when we have a predicted probability of a match, we can say like what happens is we move this predicted probability and we don't find that it's like particularly associated with water power potential. But it's like, yeah, keeps me up at night. Kind of concerned. Okay. So that's who's adopting steam power. It's mostly the entrants, but a little bit the incumbents. And similarly, because they're adopting more steam power, they're also the ones that are driving this economic growth. So this increase in total number of mills and total revenue. And so in every period, we see that the entry rate is substantially overall, water and steam is substantially higher in places with less water power. But a lot of what's happening is they're crowding out the incumbents. So the survival rate is actually negative. So this new technology makes it so that, you know, now the incumbent who previously was potentially enjoying some monopoly rents with very little competition is now getting crowded out of the market. Okay, and so this is, you know, the simple model that I showed you didn't have competition embedded in it, but this suggests that competition is actually a really important driver of what's going on. The other thing which is kind of at first perplexed us is the fact that water incumbents are switching technologies suggests that they're like feeling optimistic about this, that they want to pay a high fixed cost today, that they realize over future increased sales. So this picture with this pattern would be like things are going well for the incumbents and lower water power potentials. This pattern is things are going poorly in places with less water power potential. And the way to reconcile these two things is basically selection. That there's more competition that's going to crowd out a bunch of the sort of marginal water power users in places with less water power potential. But the typical user of water in a place with not that much, you know, beneficial geography is really productive. So that's the only way they can make it work. And so this really productive, sort of that high end, really productive ones, of whom there are relatively more, those are the ones who are attracted to switching to steam technology. And so that's how we reconcile the fact that some incumbents are very happy with the introduction of steam power, while others get crowded out.
Are there any firms that use both? So if you're a water incumbent and then, you know, you're not moving your entire plant presumably, so can you use steam to help you in cases where, you know, the water flow isn't strong enough or something like that? Is that what's happening, or are they just switching completely?
Yeah, so that's a great. So if you visit the Minnesota mills, they use both. They have little steam engine rooms, which they use kind of as a source of auxiliary power, exactly as you mentioned. In the data, you know, if they were about a quarter to a third of the switchers report both, some may actually have both and just don't bother reporting it. From our perspective, the way we think about this is you paid the fixed cost of a steam engine, and now you get the advantages of scale. And so the mills that have access to both kind of look from the perspective of a model as like, you get all the cost of steam and all the benefits of steam. In practice, that's probably not true, because in practice, you get a smaller steam engine and a bigger steam engine, and you get a smaller one if you have access to water. But because we don't know that in the data, we're just saying it's one steam thing, and so we're treating them as the same. Yeah, data that you just know. And that's one feature, that's worth highlighting now. That's one feature of these technologies, which are they're incredibly complementary. Like you can literally just switch from one to the other. Everything else about the factory is the same. And so in so much as inertia in technology choices at the level of the enterprise is important, it's gonna be like least important here. Because many technologies are not so complementary. Like if you use one, you can't just like flip a switch and just switch to the other one. That's not the way most technologies work. Okay. And finally, as I mentioned, we're interested in the potential for agglomeration. One person is using this technology, does that help others in their same local environment? Eventually in the model, we'll estimate it in a particular way that I'll talk about in a little bit. But the thing that I want to show you now is spillovers to other sectors. Just to, like, you know, we have this cool data, we've shared it with actually people in this room, we're happy to share it with you as well. And so let me show you some cool patterns that we can think about using the non-milling sources of the data. So the first is in places with less water power potential. We can look at the enterprises that are not mills, that are in sectors that were not using water power potential initially. And we see that in those sectors, even though there's really not much of a direct effect of water power, because they were never using it in the first place, they're also more likely to use steam power in places with less water power potential, which potentially reflects sort of learning from your peers or other local spillovers.
And in a region, how many mills are there in a locality?
So the typical county has between 8 and 10 lumber mills and flour mills each.
Then you can also do these across mills.
You can do what across them?
That the fact that there is a mill that adopted steam, are the other mills more likely to adopt it?
So that is true, but that could be like a correlated effect. So it could be you just happen to be in a place where the water was crappy for reasons that we don't quite understand, and so everyone switches. So the reason why I'm emphasizing,
you're already controlling for You say because you're not controlling perfectly for the potential or?
Yeah, I don't know, I know what the potential for water power is, but like, Niagara Falls is the most high water power potential place in the US. But no one uses the water power of Niagara Falls, so it's impossible.
No, but in a locality that all of them have the same potential.
Yeah,
And there are two localities, one there was one adopter, one there was not an adopter yet.
yeah.
But in fact, there was another one adopter that subsequently, you say.
So sorry,
Yeah,
it is true, we do see correlations that like, if I adopt steam, it makes it more likely that you adopt steam. Which I'll, in the model, will rationalize in a very particular way. But the reduced form evidence, I don't think would be that compelling, because it could also be consistent with just like correlative. Maybe you have access to coal, and then, we both have access to coal, we both switch, but it's not reflecting a spillover, it's reflecting some other unmodeled factor that affects us both. But that is gonna be.
It is the same, no, because it will be that all sectors have access to water.
No, because this is local water power potential affecting non-water using enterprises, conditional on things like coal. And so this is like, the water power potential itself is not correlated with coal, and yet we see them switching. And the other thing that we observe is in the data, we know what products you make. And so we know which blacksmiths are making steam engine parts and boilers. And we see in places with less water power potential, these are places that are small, they're like more rural, more remote places. But even in 1850 and throughout we don't have them in 1880 because there's no data. Because it got lost, as I mentioned, but they're more disproportionately in steam engine manufacturing in these local communities, because it turns out this is like a relatively local sector. One reason why is they did a lot of the repair work, because you need to be local. And so maybe it's the case that local water power potential is also correlated with some emitted factor that's driving this, but then we're like really in trouble, so
Those are the robot integrators.
I'm sorry?
The robot integrators.
So robot integrators, exactly. Good, yes, even though it's not on my history project, it has implications. Whatever modern technology you're interested in, it's just this. Okay. So now I actually don't know what time that is. So those are the key moments that we're going to use to estimate the data. Now let me tell you what the real model looks like without sort of a lot of implications that I showed you the first. So the first one is that there's demand, so that's going to lead to spillovers, and in particular, we're going to say that customers have some sort of CES demand, so they're competing across different millers to buy what they want. Why do we think this is reasonable? Well, obviously they're producing a homogeneous product, but space is really important. And so for flour milling in particular, one of the census questions, one of the decades asks how much of your customers literally came to your door in order to get their flour ground. And for most mills, it's most of their supply. And so because space really matters, that's going to create some differentiation across these otherwise homogeneous goods. And so that's why we think this is a reasonable approximation. The other, which I didn't show you, is when we see this crowd out of incumbents in places with less water power potential, it's actually happening evenly across initially water powered incumbents and initially steam powered incumbents. And so if it was like a Bertrand kind of story where the steam engine does, it can compete on price and it can like kick out all of the water powered incumbents, which is like a story that people tell of the first steam powered millers in London, then you wouldn't see this pattern. You see the steam powered incumbents would be fine, and it's the water incumbents who get kicked out. But because we see this homogeneity across the two initial power sources, we think it's more of a like aggregate price index competition story than a story about like who can charge the least. Okay, and so what is the path of you as a potential miller in this economy? So first you decide whether or not you want to enter, you draw productivity, incumbents update their productivity. Then you choose whether, given your productivity, whether or not you want to produce. And then if you decided you want to produce, you decide what power source you want to use. And of course, when you're making these choices, you're forward looking, so you understand like when I produce, what power source do I want to do. So what does that look like? So first you have to pay some cost of building a factory, and you build a factory, and that has some expected cost. You're only going to do that if it's worth it for you. Okay. Having sunk that cost, you figure out whether or not you're actually good at this sector or not. And so you draw your productivity, and incumbents update their productivity in a way that preserves the underlying innate set of productivity. So in so much as there's growth in this economy, in the model, we're not having that come at all from the fact that like people are learning how to mill in general. Okay, so some long-run distributed. Then given your productivity, you decide whether or not you want to produce. So you compare the value of producing to the value of just like closing and then selling your enterprise. And then having decided whether or not you want to produce, you decide what power source do I want to use? Do I want to use the one I already had, or do I want to switch to a different one? Where, as I mentioned, we see a lot of overlap. We see a lot of millers of similar sizes choosing both technologies. And so the reason why we think that's happening is there's just like idiosyncratic preference trends. And so, because I had a little bit more time than I thought I would, so in the 1880 census, they did like a qualitative survey, like why aren't you using this cool new technology? And a common answer that was given was basically like, it's loud, it's annoying, it's dirty. Those are idiosyncratic shocks. You're productive, but you don't like noise, and so you choose to use water power because that's just what your preference is, or the other way. Yeah.
I mean, so if I'm reading correctly, you're not letting the switching cost or the adoption cost vary across firms within location. But then you do have this error term. And I think of the error term as heterogeneity in the cost of using steam versus water.
So that's correct. So there's a sort of persistent cost that varies by location, but not within location. There's an idiosyncratic cost, but the way we model this is an idiosyncratic IID cost. And so if you think what's happening, which I mean, it's probably a little bit true, is there's just some sites that are idiosyncratically conducive to one power source relative to the other, then this would be persistent, which is not how we're modeling. So we're thinking of it as like an idiosyncratic shock. The reason why we don't think of it as a potentially persistent shock is actually the data doesn't seem like it's very persistent. And in particular, if you look at the switchers, so which there's not a ton of switchers, but there are some switchers. And so if you compare a water incumbent to a water entrant, okay, so what do we know? The water incumbent existed today and it existed yesterday. The water entrant only exists today. If we think of the shocks as being persistent, then the firm that we observe using water power twice, you'd be like, well, that's almost certainly someone that has a really high idiosyncratic preference for water power because they're sticking with it relative to the firm that we only observe once. It's maybe they just got one idiosyncratic shock, but they're equally likely to switch in the subsequent period, which is sort of inconsistent with persistent heterogeneity. But like, surely there is some persistent heterogeneity, it just doesn't jump out at us.
And then just one more clarifying question. The epsilon is only for continuous, so I don't have an epsilon when I initially make my decision of technology. Or
No, actually, when I initially choose what power source, because like you could think of your initial power source as an entrant. That's why the cost of switching from entry to the new technology is just the cost of new technology. Yeah, we're like, I was a little quick on the notation, but that's okay. And so given the moments that I had just chatted about, we try to estimate the model. It's nothing particularly fancy about that. And so let me tell you that it actually does a pretty good job of fitting the data. So in particular, we have external data is a very strong word. We have some external reports from basically the US government that for military purposes occasionally wanted to build some mechanized enterprises. And so we have from those reports what the costs of steam power were. And so the best estimate that we have is that a steam engine costs $2,500 in 1840. We estimate that it costs like $1,000. So we're the right order of magnitude, but we're like a little low. Actually, over time, the purchase prices of steam and water converge. So by 1880, both in like the reality and in our estimates, it's no longer the case that steam is more expensive to buy. Why is it the case that it's not the case that everyone's using steam? It's because it still has a higher operating cost. It's still the case that steam engines are more expensive to operate, but the purchase price is pretty similar. By how much is steam more expensive to operate? Their estimate, the contemporaneous estimates is around 2 times higher. Our estimate is like 3 times higher. So we're like a little low on what the purchase price is. We're a little high on what the operating costs are relative to like, I mean, the reports that we have.
And just make your data is all employment side distribution, or?
I'm sorry?
Your data for estimation is.
So we observe all enterprises with at least $500 worth of sales, which is like.
So you observe the sales and you observe the entry, the choice.
Yeah. So we know, so in 1860, we have home manufacturing, that's it, that's all we know. In like 1850, it's like 8% of US manufacturing, but 1880, it's like 0% of US manufacturing. So like, it's almost all, we like basically census. And you might be asking yourself, like, how much does it cost to enter at all? It costs around half of 1 year's sales. These aren't like incredibly ludicrous costs that we're estimating. So now what are the switching costs? So as I mentioned, the way that we estimate the model is there's a purchase price and there's an additional term, which I was like very vague on. It could be positive, it could be negative. Why was I a little bit vague on it? Well, because we don't know what the resale price is. My conjecture is that the resale price is 0. And the reason why is if you have a water mill, it's like physically attached to your factory. And so you can't just like sell it to someone else particularly. And so if that's the case, so if investments are completely irreversible, then sunk costs reflect 95% of that switching barrier. Okay, and it's around 4 months of revenue, which reflected the purchase price of water. Okay, so the reason why we observe inertia isn't because of something like risk aversion, it's not because of something like credit constraints. What those would do is they would make it so that, you know, the dollar value of switching seems relatively high relative to the actual physical costs, but that's just not what we observe. We observe that it seems like, you know, it's just the cost that's the thing that's deterring them from switching, just the fact that it's sunk. And finally, I showed you some reduced form evidence on some agglomeration. The way that we estimate agglomeration in the model is a little bit more complicated. So I can't show you reduced form pattern. But basically what it is we observe that steam engine users are larger than water power users are in general. In places with less water power potential, there's relatively more steam engine users. And so we could multiply the size premium of a steam engine by how many more steam engines there are to give us what the expected growth rate is of the county overall. That number is too small relative to the number that we actually observe in the data. And so in order to match the data, we need to allow for the fact that when one steam engine exists, other steam engines will be a little bit more productive to make it so that conditional on how the increase in steam use, you get a little bit more of a side boost. And so that's going to create increase in adoption as well. Because when you have more users who use this technology, now you're more productive, that's going to induce you to switch in a new way. So that's kind of the mechanism through which we have the spillover. But this spillover is relatively small relative to the amount of co-location of steam use that we actually observe, because I think some of that reflects other idiosyncratic factors that aren't against this. Okay, so those are the key forces. So it's not like a huge agglomeration benefit, but it doesn't. So my last few minutes, let me walk you through the sort of two key forces that are here, the switching cost and the agglomeration force. So first, let's think about some like kind of, you know, like not necessarily policy relevant, but, you know, actionable counterfactuals. So this is the actual adoption of steam power in the US over time. It looks like an S, it always looks like an S. Suppose we just got rid of the law. Suppose we introduced like a cash for clunkers kinds of policy that made it so we're just going to buy whatever your used technology is and whatever the fair price is and allow you to switch technologies. If we did that, you would get an increase in steam use throughout the period. You get it particularly as the technology is improving. Why is this? Well, as the technology is improving, that's when lock-in is particularly biting. Because it's particularly the case that the entrant today faces a relatively high price of steam and chooses water, and then tomorrow, because steam is so much better, would have liked to switch, but can't. Obviously, if the improvement of steam is infinity, you get no lock-in. And so it turns out the actual improvement of steam technology was such that you get this like really big lock-in along the path. You also get some lock-in in steady state. Why is that? That's due to the idiosyncratic shocks. Because some millers are becoming more productive, because some millers are becoming less productive. In steady state, you still have some lock-in millers, but that's not the big deal. It's really along the diffusion path that lock-in matters. The other force that I want to emphasize is this is not an environment in which lock-in is perfect. You can switch these technologies. Maybe some technologies you can't, but here you can. And so if we said, look, you're just sunk. Whatever technology you start with, that's the technology you have to fit with. Diffusion would be slower. It would end up in a lower place, but not like infinitely slower, not infinite. Like the full lock-in counterfactual is not what we actually observe in the data. Okay, so that's the nature of switching costs in this environment. And then finally, because there's agglomeration, a natural question might be like, is there multiple equilibria? Like, is this agglomeration force large enough to make it so that like some sort of conceptual policy could push us faster to the place we want to be, which is our steady state level of adoption, which was exactly the motivation of cash for clunkers. And so we can run that kind of policy experiment in our data. And we can say, suppose in a given year, let's just pick 1850, we offered firms to buy their old technology. Suppose we offered that and then tax them lump sum in order to pay for it. Okay, what would happen? In 1850, there'd be a big adoption of this technology, obviously, because now you get to switch. But over time, you see a decrease in the steam use. So there is agglomeration. So it is the case that some entrants are being induced to purchase the steam technology because it's now relatively better. But they're also being pushed away from it because there's relatively more competition. And so on that, what happens is even though steam use is still higher for a while, eventually kind of peters out. And so within like 10, 15 years, you go back to the steady state level of adoption. And so the agglomeration force, although it's qualitatively important, doesn't lead to multiple equilibria. Yeah. Oh, perfect. That's fine. And when I say qualitatively important, what I mean is when you do this substitute with this relatively small with this relatively small agglomeration benefit. When you do this subsidy, you kind of benefit two groups. You benefit the initial incumbents who get, to sell more from their perspective for free. You get to benefit customers who get to pay a lower price. You heard the entrants who now face more competition. On net, that value is positive. So it seems like in these environments, if there are positive spillovers, the economy is efficient. There's a role for government intervention. And that's all I have. Thank you very much.
We can get the questions and comments from the end, or let's start. Thanks.
We're not. Yeah, you should start.
Deliberate.
You can start.
I did something wrong. I mean, like, year 2025 still computed, but sharing on Zoom.
You can start.
Good. I'd like to thank Paco and Ezra for putting this in the program. I'm sure it was very rigorously vetted.
Choosing you to present the mistake.
Certainly the Paco and Jeremy and included, so Paco and Jeremy are here. Okay. So let me actually start a little bit differently. We saw a paper today, that Richie gave a paper about this collateral constraint entrepreneur models. So we are trying to bring in investment risk into these types of collateral constraint models, entrepreneurship models. So you may think, oh, but there's already risk because the productivity is changing, but that's consumption risk, not investment risk, in the sense that when these guys are actually choosing how much capital to use, they know their productivity. And then if I lose my productivity tomorrow, I just don't rent capital or return the capital and I just consume less. But in terms of investment, there's no risk. So these models have very strong the self-financing motive and save your way out dynamics. And as long as you have good productivity, but your capital is low, then because of collateral constraint, you save up and increase your capital so that your return to capital push the normal rate. And you do this because there's no investment risk. So what we are going to do a little bit differently is connected to what Martin just said. We are bringing irreversibility. So that partial irreversibility here to complete, but in our case, partial in the sense that you have capital, you sell 1 unit of capital you only get, say, 35 cents. So this is like a pretty big partial irreversibility. So even if you have big productivity today, you hesitate a little bit about investing a lot because what if I lose my productivity tomorrow? Then I'm going to be sitting on this useless capital and I cannot convert it to consumption without incurring big loss. So you actually have high marginal product. So that's sort of the idea behind it. And then, of course, we're not the first people to think about investment risk. We're doing a few things differently. For example, Angeletos says this old papers. His point was that typically these IRR type income market models have frequent saving and over accumulation. But then if you make actually capital the source of risk, then there could be underinvestment. You can give some conditions under which there's underinvestment or overinvestment. What we want to do differently is because those models here basically is a merchant portfolio choice model that you have a constant portfolio share. That's not interesting to us. We want to have a more interesting dynamics. Actually, your share of the risk asset changes depending on your situation. So that's one thing we want to do differently. Although actually we are working on a probably separate paper using CRS because it's easier to characterize things with linear technology to when we have actually overs on the investment, when you have partial reversibility. So that's something we're not going to talk about today. And the other thing is, Joy David and Benke has nice paper in it. So they're probably one of, not the first, but one of the first people to actually try to quantify how important this risk or uncertainty is, meaning you have to choose your input before you actually observe your productivity tomorrow. And then they are finding that, well, it's there, but it's actually not very important in terms of explaining the degree of measured mislocation and dispersion of marginal products in the US data. And the other thing those models have as a feature is that because basically you're making best prediction about your tomorrow's productivity, and then you make some investment and the things may be better and worse than what you expected. So this is like, that force alone will have this interesting pattern that this dispersion, like if you get follow a form, you're like a high or low marginal product, you're like basically kind of IID pattern. So which is not true actually, but they emphasize that, no, this is something very persistent. So that's something we are trying to generate. Then the other paper that I want to talk about is actually there are like a series of papers by Obik and Julia. They have this investment irreversibility models to talk about aggregate business cycle movements. But in those models, the big difference is that at the end of the day, they have complete market in the sense from the consumer side, so they're representative consumers, so there's not much interesting like a risk reaction you can talk about. And the other thing is, in those models, it's kind of interesting, they have a disputable model to talk about irreversibility and long investment, but then when you go to the quantification, because of the kind of things that they target, they always get calibration where the partial irreversibility is actually very small. So you have a model, but then they're looking at parameter space where irreversibility
is linear.
Yeah. So yeah, exactly. Forms are linear, and then adjustment cost is also they have very small adjustment costs. And then when you go to the consumer side, it's representative. So there are many different things we can actually talk about. So we're going to actually go to the model and then talk about visualize. There's no plot for this one. Okay, so infinite horizon entrepreneur's problem will be different. Sense that the time is continuous, but that we are not going to have a diffusion process. It's just going to be a constant process to keep things simple. And then this tau is endogenous choice variables because we are allowed for default. So this two asset model, you have this risk-free asset which you can save or borrow, but then there's capital which you accumulate. And then if you borrow, you can choose when you want to actually default. So I kind of come back to what happens if you default. So this is the budget constraint for the entrepreneur, for actually everybody, because there's no occupation choice in this model. So we are doing the simple version where you actually make profit from your business, but then you also work as a worker, make some wage. And then one thing we do is that the worst entrepreneur will actually have zero productivity, so they're not producing anything. But that's just for simplification to avoid occupation choice. And then there's return on your liquid asset, but then you consume, invest, and this is your adjustment cost, which I explained a little bit in the next period. And this is your capital, physical capital accumulation. And then for the measure with loan to value constraint, collateral constraint. Yes.
What are the zeros in the default value function?
So yeah, so I have to explain to you like what happens if you default. Is that basically you're losing your debt is discharged, but then you lose your capital. So
the debt and assets are two separate states.
Yeah, the two asset model. Okay. Yeah. So there's a liquid asset which could be negative, which is borrowing. Then there's a capital which is only non-assets. Yeah, assets. Two asset model. Okay. And then the idea is that you default, so your debt is discharged, but then your capital is gone too. So this is the loan to value constraint that if you have so A is liquid assets, so minus A is debt. If the debt that has to be bounded above by like lambda some fraction lambda times your capital star. Okay. And capital again is no negative. And then this is this, entrepreneurship has a static component. Once you have a K, you decide how much worker to hire, given wage, and that's your flow profit. And then of course there's this dynamic decision with how much investment you want to make. Then we actually have a credit spread. So because there's the competitive banking sector that make loans, and then some people default, and you have to make up for it by having credit spread. So the return on your liquid saving will be lower than the borrowing rate. And then productivity again is passed on. Okay. And what happens if you default? Well, so their tau was optimal stopping time. Here, big T is not optimal stopping time. That's the exciting. So we are having the simple trick. If you actually default, then okay, your debt is gone, but your capital, whatever capital you had, is gone too, and you will not be able to borrow for some time. Okay, so A cannot be negative if you're in this default region, but with some exogenous probability, you will actually gain access to this borrowing. So that's the T. That's the just random Poisson type, but it's not your choice. It just happens. So the exclusion is the punishment. That's the only punishment, and then there's some Poisson intensity with which you can actually access the credit market. And the adjustment cost, there are these quadratic terms that's actually not as important. That's just to keep things smooth. So let's not pay too much attention. These numbers will be actually pretty small. This kappa will be small, and yeah, k bar will be small. So the interesting part is this is a partial reversibility. So B is basically how many units you actually get if you sell 1 unit capital, includes consumption good. So we are going to use the Buera and Ma, sorry, not Buera and Ma, it's a Carmani and Ma paper. They get about 0.35-ish, but there's some variation across industries. So basically, on average, you sell 1 unit capital, you get only 35 cents worth you can use for consumption. That's the partial reversibility that we have. Okay, and there's value function. And this, I kind of told you already, but there's one thing I have to tell you here. So banks, again, they make zero profit. So they, deposit rate is like RB. That's actually, sorry, RA. Yeah, sorry. The deposit rate is RA. And then the lending rate is RB, so it's higher than the deposit rate. Yes, sir.
Is the market clear for the investment grade? Like, do I get to buy it for cheap?
Sorry, what?
Like, if you're selling, like, your evidence is like when I declare bankruptcy and I have to sell my capital at a really low price.
But there's no separate market for capital. It's going to be actually same thing. There's a consumption good and investment good is the same final good. It's just that when you actually sell like 1 unit of capital, basically only a 35% of that shows up in this goods market.
Yeah,
so
you have a model in which like value is earned.
Right.
But like in practice, what the partial reversibility is like the buyer gets a good deal.
Not here. Yeah, not here. So there's no price of capital. It's like the same as consumption good. It's just like a less physical unit gets into the goods market. They don't get better deal here. Same thing. Right. And then, so the one thing I have to tell you is that we actually restrict the loan contracts that everybody borrow at the same interest rate. So this is actually pretty big simplification. Why do we do that? Because that allows us the model to generate more default, right? So there's basically some subsidization. So if you actually have contract that depends on your debt and capital and productivity and everything, that what that means.
It's about default.
Yeah.
I know that, right, yeah.
Yeah,
Good.
stop saying default.
Yeah. Yeah, she was like, oh, that's right. So one thing we do is that, okay, so this is competitive equilibrium. And maybe it's useful to look at what the planner wants to do, but we're going to something a bit funny. So first of all, the planner, there's a simple part for the planner's problem, which is that, okay, given the distribution of the capital and productivity of one across country, even so capital, if you actually take that as given, the planner decides, okay, how should I allocate workers across them? So that's the easy part, static part. The difficult part is that as the planner as well, the planner is also subject to the irreversibility constraints that planner has to decide, okay, how much capital do I want to actually move around? Okay? If I actually, you have someone has a lot of capital but low productivity, do I want to take it away from this guy and give it to high productivity guy because I lose like 65%? Yeah. So this is different from the typical tennis problem, which again, we should be thinking about maximizing the representative household utility, but that's not what we do. And the reason why we're treating something a little bit different, which is output minus investment and adjustment costs, and then this is the labor part. We're trying to write down a planner problem that looks very similar to what in individual form blueprint the survey. Yeah, so this is the term that's a little bit less conventional. So that's what we are looking at. And then the planner also takes into account the irreversibility, and then solving the dynamic problem is not simple, not that simple for the planner either. Okay. So there's not much interesting to talk about in terms of numbers because these are like calibration is just mostly just numerical example at this point. Yes.
Sorry, just come back to Martin's question. So you're saying the planner doesn't have this option of taking assets that have been subject, say, to a fire sale and can be distributed to. That's not.
Yeah. So for the
feel like
so for the there's no notion of fire sale here.
Yeah.
So there's capital doesn't have a price. It's the same as consumption.
And then where in that objectives are preferences?
No, you can think about you maximize this notion of output, and then you can give it two step. Then you can maximize utility of the representative consumer. That's not what we are doing again. So this is kind of planner stuff that is trying to mimic what an individual entrepreneur is actually in terms of, but not in terms of utility. So they're maximizing this. So entrepreneurs profit net of the labor consumption. It's a very weird object. But I think the proper thing is just like, yeah, you maximize this representative consumer very easy.
So I think drawing from past papers, micro foundation, the fees from the asset specific forward, right? So whenever you reallocate capital from one point to the other, you're gonna destroy 65% of the value. Is that gonna be true even in planner reallocation?
Yeah, even the plan is subject to the executive constraint. So that's why the planner space about.
But my question is like, is general reallocation have this 65% discount or is only in liquidation value?
Any reallocation. Yeah. So yeah. Right. So one thing I missed. So yeah, thank you for asking that question, because one thing I actually missed is that when there's a default, then the banks actually take away your capital. But then that may be subject to different irreversibility number. But for what we are doing today, we make it equal so that the bank is like the exact same requisition technology as market as the planner. Right. So in theory, there's something that could be a bit different. I think it's based on
why doesn't intertemporal elasticity matter at all? Why do you maybe I'll just let you go on, I'm sorry. It's sort of like it's linear now. So.
Yeah, this is like into the linear. Yeah.
Right.
Now I understand what you're saying, because typically you actually think of the big U of C. So that's the one we are. So that's one, but that should be the actual planner's problem. What we're doing is okay, I don't care about the preference. That I want to have some notion of what looks like a profit.
GDP or something.
Yeah, but what looks like a notion of profit.
Yeah.
Net of the labor. So it's a bit non-standard, but so the only interesting I want to talk. So this is like a numerical example. The only thing I want to talk about is the number we got from Carmen and Mom. It may not be exactly the same thing, but we use that number. So you lose quite a bit. It's not 95%. Okay, and then there's some transition metrics. This is our Poisson chart, right? So this is in continuous time, you're in this state, and then with some per unit time, there's some probability that you can transit to different productivity levels. That we actually, here we just make things very persistent, especially the lowest productivity, we make it the most persistent. So for now, just forget about default. So like imagine there's perfect enforcement and there's no default. So this is just to isolate the role of irreversibility. And this is a stationary equilibrium. So for like figure 35, again, you lose 65% when you relocate. So this is the marginal distribution of the capital for each productivity type. So Z5, the light blue is the most productive guys. In the competitive equilibrium, they're everywhere. Some of them are like very little, and you have guys have a little bit, but they're everywhere. And then dark blue is the Z1. So these guys have zero productivity, so they have no business having capital, but of course, they don't want to lose 65% of the capital, so they hold on to it in the hope that they may become productive in the future. You see, like, yeah, so they have no useful capital, but then they're holding quite a bit of capital. Yeah, that contrasts with the planar solution in this case. Again, same thing. The planar is losing like 65% whenever he moves. But this is a case where actually the individuals actually don't want to change their capital, downsize their capital too much. But here, like in spite of paying that 65%, the planner is happy to actually move around. So that's why you see, so these are small tails at the quadratic adjustment cost part. The other thing you see is actually the planner actually wants to give capital to the really productive guys only. And then, of course, the next productive guy a little bit, but then if you have no productivity, zero productivity, and then planner is happy to actually take it away from the 65%. And then you know why? Because these guys, if I get rid of my capital, I just realize a 65% loss. That's what happens. But planner, yeah, I lose 65%, but then I gave it to these really productive guys, and then it's worthwhile for me. So they are doing something different here. Yeah? So the planner solution may be very different from the competitive equilibrium. So this is again no default option here, and this is the fully flexible case, and this is the partial reversibility case. And then you see that there's only one interest rate because there's no borrowing, no default, no credit spread. So lending and saving rate is exactly the same. We have a much lower interest rate there because actually, because of reversibility, people don't want to invest too much. And then because they don't want to invest too much, they don't want to borrow too much. So there's a less demand for loans, so lower interest rate. And what you see is that in this economy, this is steady state, stationary equilibrium, and then the K stars, Z stars, or the respective steady state value from the planet's economy. So what you see is that these guys have a lot of capital relative to the planet's economy. Not surprising, given what you actually saw in the previous video, that you have these less productive guys holding onto a lot of capital. But this is in the hand of the wrong people. So these are like a lot of low productive guys holding onto a lot of capital, so output is low, and if you measure the productivity of the economy, it's super low. The big TFP margin relative to when there's more flexibility, then actually you move around a lot. But the other thing is that because of irreversibility, you have this unproductive guy that's producing. So when computing the marginal product, of course, we are taking out the zero productivity guys. But there's a more dispersion of marginal product capital compared to when there's a flexibility. I think actually probably we should do standard deviation of low of the marginal products. But okay. And so welfare is this basically distance from the complete market. So it's being numbered because it's a distance from the complete market. And then you can see that actually with partial reversibility, you are much farther away from the complete market case when relative to when you actually have flexibility. Yeah. And this quick thing of now we are coming back to the model with default, we switch default zones and here we can show default. And some decision rules I show very quickly. So this is what you do with your capital, so your investment. So the red are the guys, so horizontal axis is the asset, liquid asset, vertical axis is the physical capital. And then what you see is actually the guys who are like rich and have less capital, they are the ones who actually invest and accumulate capital. And then this is the most productive guys, and this is the least productive guys. The most productive guys, they actually, of course, happy to actually invest quite a bit. And blue is when people actually get rid of capital when they divest. And what you see is actually a very small area. That's because it's big reasons of irreversibility. And then you may be asking, okay, if these guys are getting rid of capital, why don't these guys actually get rid of capital? That's because the collateral constraint, loan to value. So if you're here, it means that you're in debt and capital serves as a collateral. So if you actually remove your capital, then you have to repay your debt, which you don't want to do when you're in a low productivity case. That's why these guys are actually not getting rid of collateral. So yeah, that's sort of what you see here. So that here, blue is the guys actually who are de-saving. And then, so these productive guys, they are de-saving because they actually when they increase their capital by reducing their asset, liquid asset. And then these guys are de-saving because they have the low productivity shock, so they're a permanent income story. So they actually want to save, de-save and consume more. And then, yeah, there's some efforts, not here, but when they have really a lot of debt and a lot of capital, then they actually don't want to default because again, you have a lot of capital. So you don't want to actually default and lose your capital. So they're actually saving up, trying to move away from the boundary a little bit. But there's a lot of default. So what we call is, this figure has it shows two things. So let me actually go one by one. One is, imagine a guy whose state space is this is a liquid asset, your capital. So you are somewhere here. And then suddenly today, your productivity becomes the lowest one, Z1 becomes 0. So you lose wherever you were, this is where you are in terms of asset and capital, and you lose your productivity, you become productive. And then it's a stochastic, but let's say you're following a simple path that you're stuck there. And within 25 hours, 25 years, these guys are default. So this like light yellow is what we call default basin. So yeah, if you're here and then if actually I make you the least productive guy and you're stuck there, what happens to you? Do you default in 25 years or not? In most spaces, yes, they default. So there's a lot of generalize it. So that's one thing I want to show. The second thing I want to show is that the ability to default actually makes very different people because as you can imagine, default provides a good insurance option. Right? So if you actually have some capital, you lose your productivity, it's useless. Before then, it was all your loss. But now, if you have a debt finance your capital, then you just walk away from your debt. You lose your capital, but also your debt is discharged. So you're kind of sharing with other people, the bank and the other people in the economy. So you're happy to do it. So what happens is that this is blue is when there's no default option. So imagine a guy who has 0 asset, 0 capital, and then suddenly you get the highest, you're hit with the high productivity shock. Then this guy will actually go in debt a little bit to raise the capital because you're very productive and you have 0 assets, you actually borrow and then build up your capital. And then at some point once you become rich enough, you start like paying back your debt because actually the interest rate on debt is high because, sorry, not here, sorry, I take that back. So then actually you actually build your net worth both in terms of capital and liquid asset. So that's what you have, that's what you do. With default option, what you see is that so each study is 1 year. So you start from 0 and then it's 1 year, 2 years, and 3 years, 4 years. And then with default option, what you see that these guys are willing to go to debt, get into debt faster, and which means also they actually accumulating physical capital faster too, relative to the blue line. So these guys actually, the default option again is a nice insurance option. If you lose your productivity, it's not a good thing, but unless you can get rid of your debt and then lose your capital, so it's less costly than you only using the use of your capital. So then these guys actually borrowing and then increase their capital, but once their capital reaches a certain point, they start actually repaying their debt. Yeah, this is because of credit spread. That interest rate on their debt is high enough. They want to actually repay pretty much all the debt, and then after that they save in terms of physical capital and liquid asset. It's cool. Yeah, thanks. Okay. Okay. So this is both with default and partial reversibility. So this is a credit spread. So now this is the same fee. So the planar version of this economy is the same whether it's default or no default, same thing. So they're divided by the same numbers, planar location. What you see is actually, yeah, obviously there's just some credit spread. And then there's a little bit more output with a default option, or a bit less capital, because again, the reason is that you have low productive guys who are in debt. They are happy to get rid of capital and lose capital. But then here in no default reason, they hold on to their capital. So they actually, these are stationary, steady state comparisons. So we shouldn't actually read too much into welfare numbers. But there's, because of default option, the credit spread rate interest rate higher. So that actually limits borrowing. They can take an infinite amount of loans. So let me, so this is, yeah, so let me actually, so it has the interesting feature that, okay, so the debt, yeah, irreversibility have outcome that's very different from no irreversibility. So there was a previous table. And it could have a huge effect into the tier 3 because you have this capital held by the wrong guys who are not willing to get rid of their capital. But at the same time, once you have a default option, then that in some sense reverses the problem a little bit, but not dramatically. So
Is
here,
RS the same in both worlds? Is RS the same in both worlds?
no, they're different. This is lower here. Yeah, it's only lower here.
RB is the same in both. No.
No. Here, there's only RB equal RS, which is lower
But
than
what
the
about the actual level
RS.
of the,
The level of RS.
maybe RS is bigger in the default.
No. RS is lower here.
RS is lower.
Yeah. With the credit spread. So here's like only one interest rate, and then the saving rate is like.
RS is lower than RB. No, I understand
Yeah,
that.
but also comparing the two, yes, RS is lower.
What if you go to your cool blue and red picture?
Yeah. Sorry, this one?
Yeah, so because it's they're converged, it's almost the same point. And then just a little tiny bit of capital with a lower interest rate on it gives you this trajectory going up really fast.
No. So here, this guy has default, and the reason why actually they are not saving in terms of a liquid asset as much as this guy is because the return savings is lower.
I'm just saying that you see where the red and blue line get very close.
Yeah.
It's the exact same period of time. And so those guys are the same asset holdings.
No,
Just
but
a little bit more capital and then.
Right. But the price they face is different. So I have to think a little bit more about it, and it's the reason why actually these guys are more willing to invest in capital rather than liquid asset is because the return to liquid assets is lower in this economy. Yeah, with the default. I should actually show the levels, not just credit.
I see, okay, no, that's yeah.
Okay. So I'm running out of time, so let me just say one more thing. So actually these figures are not the correct ones, turns out, but actually it has some interesting idea. So you could say that, oh, the default option doesn't do much in the face of irreversibility. But we actually have some, not this figure, again, it's the wrong figure, but then the interesting possibility we found is actually you could have a very poverty trap-like features. You start from a very poor economy, like we have a very non-convex production technology. Everybody starts like very poor, but then you don't give a default option, then you're stuck there. Nobody wants to take the risk of having a really big capital stock only to lose their productivity. But actually, if you, in subparameter right, some numerical examples, what happens actually, if I give you actually a default option, then you actually are willing to borrow and move away from the poverty trap. So this is like, again, there's something wrong with the figure, but then just to give you ideas, actually, you could have a very divergent effect starting from particularly linear condition, whether you have a default or not, no default. So default could be actually a pretty good thing in some cases to transform the economy from poverty to better state. Okay, so we are thinking of uninsured investment risk, which has not been covered very well in this entrepreneurship collateral financial constraint literature. So actually we are doing that, and then we are doing so by not doing this one period ahead input commitment thing, but we are actually looking at this bigger irreversibility in capital, and that generates very interesting dynamics, especially when you have some non-standard production functions. And then there are many different things we can do, and everybody knows that equity financing could be a good thing, but then for whatever reason, equity finance doesn't get to use very easily in development. Thank you very much. I'll be happy to talk more about this.
Back and forth.
Sorry, I thought we wanted to anything. That's why I was
You can just go. Yes. Yeah. You can use right.
No, that's good. I didn't realize they should do a
Equation. Okay, so this is. One thing is even I guess you. So you estimate
at this point, we're estimating the time path to adoption. It's got to be something like that. So again, if you lose a predictive, well, we have one on the locations.
Within 25 years.
Fundamental models is one.
Okay, so at some point they're gonna.
It's not like default, let's say match.
Right, exactly. It happens within 25 years. Yes, I don't know how many years.
Version of productivity.
But no, But it's a good observation, but they're actually very.
Adoption. We have share using one technology rather than the other technology.
But they're facing different.
Start from.
With their.
Like they do something really good for us, like within firm versus across firm kind of thing.
Yeah, so we say that there's an underlying distribution of productivity that we estimate to be 15, 18.
No, it's direction. It's hedging the. This guy.
Estimate what.
Yeah, so in our case, we're not doing it, but it's the universe.
And then we just trace it back to the 30, which is like having that stuff.
Yeah, but in some cases, good, because these are high productivity, you know, friends and.
Okay, no, but.
But even those guys will eventually, if they.
Maybe should draw more.
So it's not a threshold, because it's idiosyncratic shocks. And so I might be productive, but I might think it's a negative.
No, equity is actually.
Yes.
Yeah, I mean, this was.
It's a.
I've not thought about that.
Yes. I mean, what I'm thinking is that. In areas where maybe like the one rationale for this could be like just an area. Where there's
Yes.
Regulation.
Yeah, that's right. Another shock is that.
So that's what I'm saying. If I were to implement this as like kind of separate firm and right, consumers, all.
Anything that I would like, I don't know exactly, but.
Even then.
No, I understand, but the point is.
So if they cannot take a product, they would list it as a new product.
Do you believe that the first well, you know, suppose we're in a first well.
No, but there's
But that's why I think at the moment we are not like.
The
The first thing that we are thinking is not necessarily.
Right, that will implement the first bit.
So for a given.
I agree, then that's
This
nice.
is.
Even
What is problem, that first problem.
Not just right now.
Base interest rate, this consumption.
Take that to like.
It's a dynamic, like.
Yeah. But that's.
This is an equilibrium interest rate.
Oh,
That's takes into account.
In stationary equilibrium, in stationary equilibrium, where you have perfect insurance.
Yeah, but where does the stationary go? How do I see?
Oh, it's not in there, it's just, we are studying the station.
So it is analog to something, that's right, but my.
You're smarter than them. You gotta move it slow.
I don't know about that.
Like it steadies.
I think it does, I think.
I suppose. Yeah, that's it, yeah, so along with that, like for any given period, right, I can plot.
It's problem.
Plot.
Yeah, you did. You can go, they can do the, I can do the long run, because what they can do is let's think of the long run.
Oh, but I thought that NPL's exogenous though.
Here,
it's treated as exogenous.
It is. The one way you can be, but that's not how.
Referee can be shown the day.
No, I think actually it's simpler to just write down.
Sure, I mean, it seems like it's unique, but I can.
No, but that's actually that we have the marks demonstrate.
That means a couple of things that are.
I know that I wrote this down for.
You're not troubled by it.
I'm not troubled by it because I think it's.
I remember having that conversation at some point, like, we're going to write down this way, but then I was like.
It's like.
That different from there, you only.
It's one command. Like any observed equilibrium matches one set of parameters, and a given set of parameters can match multiple equilibrium.
But that's.
No,
That's kind of crazy, so it's like, you can be here, you can be good or bad or good, but like, it goes like this, like the best bad equilibrium is worse than the.
No, it's more an issue that the given moment, in our case, you can choose given the state of moment.
Usually the way you get the credit spreads is like some kind of like cost of state verification or something like that. Usually the way you get credit spreads is like some kind of.
And in particular, we define your claim.
No, of course, right.
Each of those
Well,
ones.
so that means that every.
And you can do that uniquely.
It isn't a constraint optimizer, we're just forcing.
No,
Yeah.
they estimate it.
I mean, it seems like
They
there's.
give the parameters, they could
There's
be more
something
than
about
one equation. One that they observe you claim,
Yeah, but like,
It's-
you're saying
as
every.
and that probably the same will be true for you guys.
So that's like kind of crazy.
That's our unique default angle.
If they interpret-
But then multiply, there's
Well,
multiplicity,
I
but then
can't-
multiplicity doesn't overlap in some
Credit
sense.
constraints are
As the parameters
not an issue. Where's the inefficiency?
No, the reality has one set of parameters.
No, no, I'm saying.
And it's
Sure.
I was talking to some.
Yeah, but
with
usually
the
the penalty right down.
explaining this. It's not what happened for you
Oh,
guys.
sure.
Then you end up with credit
So
spreads.
You have to have some default cost.
One equation
have to
where
have some
some people
people.
are playing.
No, that's the cost of state verification.
Yeah,
Well,
but you're saying,
usually
we're just
enjoys-
assuming that the market
Usually
doesn't
many
need it.
market,
You would
each
want
market it could be the
us to
same.
write down a reason
Yeah, putting
why
all
the
that data
market
together.
doesn't exist. Or
They are really mad.
I don't think Ezra wants to,
Well,
wants to do anything.
When you use you play
What are the inefficiencies?
Well, no, but you guys are dependent, okay, it matters
I
to
think
you
it's,
guys.
there's no,
Depend, depending how you interpret the location.
it's at
You
least one
tell
of
me
the
the location of
inefficiencies,
the
obviously, there
one
could be a loan to value
same.
constraint as
Yeah.
well.
Whatever that is.
In
All
all
of
of those are treated as
by
just
considering
exogenous.
you can get unique.
So here, there's too much default. And
Much
default
depends
column,
on
yeah,
the question, but
like losing.
there are
big
other
part of
things,
capital.
not the one I observed.
Yeah.
Go down.
What are the parameters that I estimate? Is it
Let's
one
look at it.
real?
Right. But it's-
Or they could be,
it's a hard question.
they could be two. My
No,
claim
we
is
are
that
taking the shortcut.
you should take
Okay,
the
there's
position
no
like
choice of
US,
contract. This is
both
contract
the
for
regions
everybody.
operate in equilibrium.
Yeah.
Or
There is default and
the
then it's
integration
because
is
once there's different, everybody
No, no, I
has
understand.
liquidated their capital. And
then you can, then you have unique identification.
Exactly, the people.
Because that's very,
Too much.
more discussed this.
But for what it's
No, no, that makes sense.
Model of the dynamic that.
We're all on the same, we're all on the same delivery.
the welfare losses, you don't need.
I'm saying like, yeah, so
Like,
like, I understand your response, like,
has like cool
if
graph.
here they play one
but the
equilibrium,
actual
there they
welfare
play
loss
different
is-
equilibrium.
Then is a
And you
mess.
match them.
Just
You're playing,
for
you're
your
as the
ability
average
and the lack.
equilibrium.
Yeah, that's a mess. Then you have to have a center.
I guess my thing is like, usually being a limit liability is a problem.
With the solution too.
Well, yes, that's.
That's the point.
The point, right.
Exactly, it's a program insurance.
But then, I wanna make sure we're thinking right about what's the.
Yeah, no, we don't.
You're right, I said it.
Well, no, even in the models that have limit liability, it's like we're gonna impose limit liability and then I think about, overcoming limit liability for example. And if you're gonna,
We were, we like
I
messed
think
around.
that's what it is, that there's no
Thing that we could
foundation for what is limited liability.
create
problem.
some like,
Limited
so-
liability is.
yeah. And so
Yeah.
somehow,
I mean, I was very
I don't know, you're gonna make this point, you gotta like.
Nice, cool, I like it. And then the way the vision that you
No,
you
we're
use the account,
actually motivated by,
you have initially
there's this.
this by month.
Bandiera company paper.
That might well like be to
They
make
actually
those.
give
The
people.
model wide.
Like,
So your water, you have the
But then
distribution of water.
the return is like amazing. And then
Yeah,
very
initially.
Then the question is, why don't people actually do it? Is this like a relative borrowing constraint? I think actually it's more than that. Yeah, they don't know whether it'll be successful or not, a big chunk of money.
Yeah, so we just use the water
Village
users.
culture.
So
that's how we
I mean,
interpret it.
intuitively makes a lot of sense.
Yeah. And what happens is.
But I think I agree with you in the sense that
Cheaper.
is this always a good thing?
And,
bad thing? I mean, it really depends on what, yeah.
What exact market do you wanna shut
Yeah,
down?
the big stuff, part of the big
That's
stuff.
right, yeah, there's a lot of
That's what I-
complex types, things floating around.
Yeah.
And then also because of
I can
competition, you
start
can
in
wipe out
Second best world.
water
And
users.
then-
And so what you're left
And
with
that's
is like
what
relatively large water
exogenous, why the
users.
consumption
whose revenue
characteristics
discussed.
exist.
But then,
And then from there,
but is it overcoming the
And the
cheap
case
part of
thing
the
is that
test or the real part of
A
the?
decade afterward, we all what there is.
What do you mean?
And a decade after. And
Usually when you,
no, what, yeah.
when you have
That's
a,
great.
you have there's a real friction. That's because we do these shortcuts to overcome.
Well, sorry, this, yeah.
We have a
we're not-
policy
we're
that
never-
makes things better.
Number would be-
Sometimes
that's
it's.
fine. I mean, still, every county has
Even
a
if you
law.
did the full thing,
But I
it was
was-
proven, sometimes when you do the full thing, just the policy wouldn't be.
And the existing ones are coming out, design, much better.
No, actually,
Literally,
there's a statistic comparison, but here the default.
And then the one that you lost,
Makes
the data is
worse.
the sector is native.
Oh, okay, so it can get you out of, it can get you out of the.
Yeah, but then there's too much investment and too much
It's not-
too
there's
much
not-
loss and there's more inequality and everything, so.
I mean, there's a lot of interesting stuff floating around there.
But then it's a
So that's, I mean, that's not exactly why, but like, we have to try to write down a very simple paper. Like it's.
Yeah.
Technology, and then you can make sense of irreversibility alone and, yeah.
So before you define it, it's not to get to the.
But that comes up harder than we thought, because at the end of the day, we end up with like, we put things, for these things. If you boil down to one known indication in one unknown. So. There's hard to take it. Yeah, when you don't have a closed form.
Yeah, almost there, but.
You don't think about the credit angle, they're not interested.
Thanks for.
Credit, that's right.
Yeah.
But some of the. And I guess I should not question about that, I mean, it's really hard, like we have the same problem, huh?
I don't think it's a good place to
So
start.
market failure.
I think it really isn't, because it's like.
Hyperactivity, idiosyncratically low today. What we would like to do is you would like to pay me 35 cents
Yeah.
for my dollars worth of capital, even if it requires specificity, even if it has specificity. So like, because then I shrink, you have the value of capital for you. And so like, if we could bilaterally trade the capital, then that would get towards the planner solution.
Because they made them because they confused the answer. You make it bring where we
I
studied.
can for one of them,
Yeah,
For one.
or two.
What were the innovations Steve had, like, like what exactly they did over that period?
So the big one is, so the US and others use what's called high speed, high pressure engines. Which are really cheap and really dangerous. It never happens in.
Sorry, so that's good.
No, a lot is like really explosive. Like never. And so we're basically.
I'm sure.
Okay.
Can we?
Yes.
Start with that session.
Hi everyone, thanks a lot for having me. And speaking through to the last presentation. You might feel very exhausted, but I sincerely hope my paper can invigorate and refresh you. This is my new project. Any comments are more than welcome. Without further ado, let me get started. It is well accepted that in developed countries, technological innovation is crucial for long-run aggregate productivity growth. Developing countries also rely on technology diffusion from developed countries to grow, but as they converge to the global technology frontier, a transition to innovation-driven growth is necessary for sustainability. Both developed countries and developing countries have implemented numerous policies in various forms to promote firms' innovation, particularly focusing on encouraging firms' talent creation. Some policies subsidize all firms, some subsidize small firms and young firms, and some subsidize large incumbent firms. Because firms could have different innovation capabilities and have different growth potentials, the effects of policies in the end depend on which type of firms are subsidized. Okay. And we can classify all firms into 3 types based on their patent citations. A firm is non-innovative if it doesn't apply for patents, and a firm is incrementally innovative if it applies for patents but with limited citations. And a firm is radically innovative if it applies for patents but receives a significant amount of citations. And we have this classification because researchers find the citations firms have are closely correlated with the firm's growth potential. In fact, the aggregate productivity growth depends on firm type composition and each type.
You've actually totally sorted it.
And it types innovation, quality, and frequency. To see this point, let me do decomposition. The aggregate productivity growth is positively correlated with the economy-wide citations of all patents that newly filed by all types of firms in a year. And for each type of firm, its citations are product of two terms. The citations per patent the firm has and the number of patents the firm has. The citations per patent capture the innovation quality and the number of patents capture the innovation frequency. Because the firm's type, their innovation quality and innovation frequency can be changing over firm's life cycle, it's direct that the life cycle dynamics of firms matter for the aggregate productivity growth. And then to understand the aggregate growth and the effects of innovation policies, a natural follow-up question is, do firm types, innovation quality, and innovation frequency vary over their life cycle? And are there any cross-country differences? If so, why? And are there any country-specific policy implications? Are existing innovation policies effective? I realize that all of these questions are kind of underexplored, possibly due to data limitations. And in this project, I aim to answer these questions. So first, I document new facts on firm type and innovation over life cycle across countries. Using Orbis database, I find that in developed high-income countries, firm type, innovation quality, and innovation frequency are mostly determined at birth. To help you understand what I mean, let me show you two figures here. The left panel shows that high-income countries, represented by blue, have that the firm's probability of becoming an innovative firm is mostly constant over firm's life cycle. And the probability of becoming a radically innovative firm, conditional on that this firm is innovative, is also almost constant over firm's life cycle. Well, compared to high-income countries, middle-income countries, represented by red, shows that there are fewer innovative firms and fewer radically innovative firms. And I also find these firms in middle-income countries have lower radical innovation frequency, but there is no significant difference in terms of innovation quality. Next one.
Okay. So I think a small question might arrive that, all this is a very global coverage of the firm size distribution in European countries with a high income, and in countries like Peru. Yes, most of
I'm going to focus on European countries.
So what is enough middle income? You mentioned Peru.
No, we have Slovakia, Greece, and so on. Yeah.
Sorry, I want to understand how should I interpret differences in the level of citation across countries? I mean, I ask that because countries differ a lot in the institutional setting. I can understand comparing within country, but across countries, I don't know, 3 citations for a Brazilian firm, it's a lot of citations that they're received.
It's a fair point. So in the end, I can show you that even so among these European countries, and if I only focus on patents filed in the Europe, I still see the same pattern. Okay, I hope that can kind of address your concern. But in the end, I want to link these firms' innovation patterns to firms' size distribution and lifecycle growth in sales, employment, and so on. But in terms of the sales and other employment measures, I do see that my paper can be consistent with the literature, for example, Shanclino, but I focus on the firm's ex-ante difference because I show that lots of firms' innovation abilities determined at birth. Okay. I will discuss more details about these two figures later on. Okay. And I find that interestingly, most across-country differences are observed in high external financial dependence industries. Okay. And I also find have some additional formula effects to suggest that maybe financial frictions play a role in explaining these cross-country differences. And then to understand the effects of financial frictions and on innovation its macroeconomic implications, I built an endogenous growth model. And in the model, financial frictions are modeled by a capital constraint and a limited liability condition. Okay?
I find financial frictions reduce the TRP level and TRP growth rate in middle-income countries, mainly by affecting the composition of firms, by reducing the creation of innovative firms, and by reducing the growth of young radically innovative firms. Okay. And in terms of policy implications, I find that for developed high-income countries, creating more innovative firms is better than subsidizing existing ones, because firm type and innovation are mostly determined at birth. While for middle-income countries, I find creating more innovative firms and subsidizing young radically innovative firms are both important, because these young radically innovative firms are financially constrained. Okay. I feel the policy implication for high-income countries is interesting, because quite a few existing policies target large incumbent firms. But I show that maybe we should think more on the extensive margin. Okay.
Sorry, Shami, can you help me here? I'm trying to see how 2.2 correlates to 0.1, the empirical finding you showed us before. Can you just clarify that to me?
Sorry, which part?
So your main result 2, how does that correlate with the facts that you showed in the previous results? Yeah.
Financial frictions reduce the firm's probability of becoming an innovative firm. And the financial frictions reduce the probability of becoming a radically innovative, conditional on that this firm is an innovative firm. So firms can choose their innovation types, whether choose to do radical innovation or incremental innovation. And they also, on the extensive margin, even if firms in middle-income countries choose the radical innovation, their innovation frequency can also be lowered by more severe financial frictions. Okay. I will show you the decomposition later on. Okay. So I think the previous papers on innovation are mostly focused on the relationship between firm size and innovation, and I show a new comprehensive view to emphasize how firms' type and their innovation vary over their age. And I also highlight the importance of the extensive margin. The composition of firms across countries are different, and this would be important for us to understand the aggregate productivity difference and national income difference across countries. Okay. For the interest of time, let me jump to the data. I use obvious historical data merged with obvious intellectual property data. The benefit of using obvious is I have both public firms and private firms. As a benchmark, I focus on patents filed in the US Patent Office, because the literature documents the most important patents that are relevant for productivity growth are filed in the US, but I do check robustness using European Patent Office data. And I focus on industries with patenting activities to address the concern that some industries don't rely on patents to grow. And in the end, I have 24 countries, and they are all from Europe because they have good data coverage, and I classify all into 2 groups based on their GDP per capita level. As you can see, in middle-income countries, we have Bulgaria, Hungary, Croatia, Slovakia, Malta, Portugal, Greece, Spain, and so on. Okay. For simplicity, I classify firms into 2 groups, but I do see that the patterns hold even if I have I have 4 groups of countries or more. Okay. And for each country, I classify all firms into 3 groups based on the newly granted patents they apply for. A firm is, I do this year by year. Okay. In a year, a firm can be a non-innovative firm if it doesn't have any new patent. And the firm is a radically innovative firm if in this year the firm has at least 1 patent with citations above the median level. Otherwise, the firm is an incrementally innovative firm. Okay. And I want to highlight that I adjust citations to make sure that they are comparable across technology classes and they are comparable over years, because it takes more. Old patents have more years to receive citations than young patents.
Are you using a country-specific median? This is the same, like the European.
Oh.
1 median.
Yeah, 1 median.
So here, when you say firms without patents, what we really mean is firms without patents in the US Patent Office.
Yes,
So
yes. Or in the European Patent Office.
Yeah, I guess I'm wondering.
European or US Patent Office?
So this is my benchmark measure, but in the robustness, I only focus on European patent data.
I guess I'm wondering, some of the US Patent Office presumably only accepts patents in English. I'm wondering, is there a language barrier for some of these countries that makes them less likely to file in the US?
It's an interesting question. So if the innovation is quite good, usually they will go to they will apply for this patent in the US as well. But all of them are European countries. Maybe I can use European Patent Office data as the benchmark to address it.
But the European patent office thing would also be in English, of course.
Yes, yes.
Yeah.
All English.
Yeah, later in France.
And then with the data to understand how firms' innovation vary with their life cycle around the following regression. Okay. So from I in industry J, country C and EFT, I regress the variables of interest on age group dummies interacted with the country indicator. The first age group includes firms with age of 2 or less. The second age group includes firms with age between 2 and 4, and so on. Okay? And I have 3 key Y variables of interest: whether the firm is an innovative firm or not, whether the firm is a radically innovative firm, and the number of new patents the firm has, and citations per new patent the firm has. Okay? Here I have firm level control for firm size and their exit propensity to isolate the effect of age on firm's innovation. And I have country fixed effect, industry year fixed effect, and a firm fixed effect. Firm fixed effect here is important. It shows that I consider firms over time variation. Okay? Okay. And then I plot these alphas associated with these 2 country groups with a 90% confidence interval.
Okay, so what is, if you just plotted firm size on the left, what does that look like? The life cycle?
So if I only plot over size, I can see that larger firms can have more patents.
No, on the left, like what does the
Left.
life cycle of firm size?
Oh, I see. It is increasing over time. I'll show you later on. So basically, I can show you that the innovative firms are larger at birth and grow faster over life cycle than non-innovative firms. And we also have difference between the radically innovative firms and the incrementally innovative firms.
Yeah, that's the question.
Yeah, would your first graph look similar if you had size on the x-axis? And on the y-axis?
No, I will see a significant increase for
high income and for middle income countries?
I will say that firms in middle income countries have smaller life cycle growth compared to firms in high income countries. And within a country, the innovative firms have a larger life cycle growth than non-innovative firms. And in high income countries, radically innovative firms grow much faster than incrementally innovative countries, incrementally innovative firms. But in middle income countries, I cannot really see the size difference and life cycle difference between incrementally innovative firms and radically innovative firms, and I will use my model to explain that fact. Okay. So these 2 figures are from the introduction. Now I can discuss more details. So the x-axis is the age group. The y-axis on the left panel represents a firm's probability of being an innovative firm. The dots are alphas, the regression coefficients. The fitting line is this solid line is the fitting line of the dots, and the shadow area represents the confidence interval. You see that in high-income countries, the probability of becoming an innovative firm have a slight increase over the life cycle, but it's not that significant. And the probability of becoming a radically innovative firm have a slight decrease over the life cycle, but not that significant. And when I compare the high-income country and the middle-income country, I can see that the cross-country difference in probability of radical innovation shrinks as firms age, indicating that in middle income countries, these radically innovative firms can overcome some constraints to innovate.
My recollection from the previous slide is that you're controlling for size.
Yes.
Why do that?
The size in the last period.
Yeah.
Yeah, so because some people argue that firms in middle income countries are smaller than firms in high income countries. So if I don't control for size, the difference between the two countries can be due to not only the age difference, but also the size difference. Okay, but I want to say that, so first, even if I don't control for the size, the patterns are similar. Second, if I control for the size, I will see a more flat pattern. Okay, so basically, this can help me isolate the real true effect of age on firm's innovation.
I guess it's just age affects that, right? And so you're kind of conditioning.
Yeah, but this is a lag period. Maybe I think.
Yeah,
that's
still the age today is just a function of the age yesterday. And
yes, that's true. I think controlling for size makes more sense. So even given the same size of a firm in the past, firms in high income countries and middle income countries have different innovation probability, right? And I want to understand what contributes to this.
it seems to me if you want to do the age profile, do the age profile, but I don't know what this coefficient means as much once you're conditioning on something, the changes with age, but it's fine. That's what your model is matching.
Yeah, it's a fair point. Yeah, but if I do this in the data, I'll do the same thing in the model.
Well, this generally say if you can do this, the same regression, the two genes at the same time interact with yeah. Basically, you can take two sets of like genes and then
Let's move. Because the sales control for productivity in a sense, the cheapest well the age.
Yeah.
Okay. Yeah, and these two figures shows the innovation frequency difference across countries. The left panel shows the incremental innovation frequency difference. It shows there's no significant cross-country difference. And the right panel shows the in terms of the radical innovation frequency, the cross-country difference shrinks as firms age. Okay, and then you might want to ask what explains these facts. And my strategy is to utilize industry-level variation. I try several industry-level indicators. One is ICT intensity because it is related to the complexity of the knowledge. But in the end, I find it cannot really help me understand the cross-country difference. And what is striking to me is the external financial dependence shows that the cross-country difference in innovation is mainly in high external financial dependence industries. So basically, I use the indicator from Raja and Zingel's paper, which use US data, and given the assumption or the fact that the US has a very developed financial market and that the industries could be similar across countries, I think this indicator indicates that the financial frictions play a role in explaining the cross-country difference. So I run the same regression as before, but run for the high external financial dependence industries and low external financial dependence industries separately. Okay. And the takeaway of these two figures is the high external financial dependence industries in middle-income countries have much lower probability of having an innovative firm and a much lower probability of having a radically innovative firm. So these are in red. Okay.
I was wondering, sorry, I should have asked that before. So do you have R&D expenditures in
Good question. Because lots of them are private firms. I don't have R&D expenditure data, but I can observe the intangible capital and construct an intangible intensity measure. I find is highly correlated with these factors. Yeah, but it's not a perfect measure of innovation input. Yeah. And these two figures show that the high external financial dependence industries in middle income countries have higher incremental innovation frequency, but lower radical innovation frequency. And these two figures show that among the countries covered in my data sample, I do see that richer countries have more developed financial market measured by several different index. And these two several facts suggest that maybe the financial frictions play a role in explaining this cross-country difference. Of course, these are just suggestive evidence, and I cannot rule out alternative explanations. And I want to use the model to explain the fact, and in the model I can think about how to incorporate other possible explanations.
Yeah, so it would be interesting if you can show some exploration within these so-called middle income countries, in the sense that some of these have really high growth rates and some of them are stagnant. I'm thinking a lot about Portugal, because there's so much growth recently, and it would be so nice to see if what we think about high income country, maybe you see also that in high growth country.
Yeah, good question. So I do check the more variation even within the middle income country group or within the high income country group, and this scatter plots basically show that richer countries have more innovative firms and more radically innovative.
But high growth countries are innovating more. Can you say something about that in your?
I didn't check it yet.
But that's something that.
Yeah, it's doable.
Yeah.
Yeah, so one question about the data. So I guess a lot of innovation are made by multinationals, and then some of them are doing this R&D offshoring. So if I have a subsidiaries and I grant and I apply for a patent, so is that patent being allocated to the subsidiaries country or the headquarter country?
If they both show up in the applicant in the patent data, then I will record this twice. So every firm I will record once. Yeah, it's true that multinationals are important for aggregate innovation. Yeah, but in my data sample, I do see that lots of firms are not in multinational and they do innovation. And I tried once that I take out those multinational firms and the patents are still there.
Okay, because my worry is that it's more reflecting the internal credit market of multinationals, but if you take them out and make them places.
Okay. So before I go to the model, let me emphasize two things. So first, as I discussed, I can link the different types of firms to the sales, employment, fixed assets, and so on, which are the Euro variables of interest. I do see that they are different at birth and they have persistent difference over their life cycle. And second, my facts are robust to many different ways of looking at the data.
Why is it that you think that the firm type is determined at birth?
So good question. In my model, I'll interpret it as luck. So some firms are luck and they are very large at birth. So actually, I'm trying to see. I'm working on some different measures of firms to see what characteristics matter more for the size difference at birth to help us understand why these firms are exceptional as are very large, even when they are very young.
So just to clarify then, so firms do not switch type in the model, right?
Yes, I can make it switch, but the data tell me they barely switch. That's why I will say that in the model firm type is determined at birth.
I guess to Martin's point, there's this paper on the Barista that connects firm lifecycle growth to the education of the entrepreneurs. I think it's by Francisco Queiroz in the Portuguese setting. So you might be able to get some microeconomic support for the idea of, heterogeneity at birth being a huge driver of success.
Sure. Thanks for the suggestion. I think I know that paper.
Just one point. So I think your main story, the story that we want to tell is something of that financial constraints, the firm face financial constraints. that affect the type of innovation that firms make. So when you are making these sort of cross-country comparisons, that, many times are not very clean. But here, because you have balance sheet information in these firms, you can calculate at the firm level, sort of a metric of financial constraint at the firm. And you could show that that is true even within the country.
Yes, I do show it, but I make it as my auto sample moments to validate the model. I'll show you more details later. Yeah, I check the leverage and average avenue product capital. So the model is quite related to many of yours paper presented today. So the model has infinite horizon, discrete time, representing households. And as we discussed, firms determine types upon entry. For simplicity, I assume there is a unit mass of firms which is constant over time. So there is exogenous entry and exit rate. And once firms become non-innovative firms upon entry, they will draw productivity Z level forever. And once firms become innovative firms, they can make innovation investments throughout their life cycle. And all firms have a decreasing returns to scale technology to produce homogeneous goods. The Y here is output. A big Q here is the aggregate productivity, which essentially captures the knowledge spillovers. And small z here is individual firms' productivity level. And K here is capital. Okay. And all firms make production decisions, saving decisions, and innovation investment decisions. All of these decisions are subject to capital constraint and limited liability condition, which is a Euro way of introducing financial frictions in macro development literature. So the capital constraint says your one-period bond cannot exist a fraction of your capital input, and limited liability condition says your dividend cannot be negative. Your dividend is your output plus your capital stock minus your debt payment, capital investment, innovation investment, plus your new borrowings. Okay. And I define a net worth level A, which is the difference between capital and bond, and it will be a state variable in my model.
So it seems like the firm is maximizing profits from the membraning. Is the implication that, or I guess maybe the net present value dividend, is the implication that a financially constrained firm will always have zero dividends?
Yes. Yeah. If they're financially constrained, they will have a binding limited liability condition. Yeah. So for the entrance, I assume they draw a productivity level which is lower than the average incumbent level to be consistent with the data, and they also have a relatively low net worth level. But there could be some variations across firms, and this entrance will make some investment to become innovative firms with some probability E. The more they invest, the higher the probability of becoming an innovative firm. Okay. If they are unlucky, even if they make an investment, they will become non-innovative firms. And once firms become innovative firms with some exogenous probability, they will become a high-type innovative firm. Otherwise, they will become a low-type innovative firm. Okay. And financial frictions will reduce firms' probability of becoming innovative firm by reducing this investment. Okay. In the end, we can show that the mu here, the multiplier associated with the limited liability condition is binding, and it will reduce firms' probability of becoming innovative type, simply because they don't have enough resources for this type investment. Okay. And then we can discuss entrance setup, which is the key of the paper. So the incumbent setup. So once entrants become incumbents, they can make innovation investment. The low type firms will choose incremental innovation probability, which is the counterpart of innovation frequency in the data. And the high type firms will choose radical innovation probability Q or incremental innovation probability X. So here I assume they can only choose one type of innovation. Okay. And once firms innovate successfully, they will have productivity increase captured by the innovation step size, okay, which is counterpart of innovation quality in the data. And I assume radical innovation will lead to higher productivity increase compared to incremental innovation, but at the expense of higher cost. In particular, compared to incremental innovation, radical innovation will lead to higher fixed cost because, for example, this radical innovation will require new infrastructure or factory construction. For example, when Tesla decided to produce electric cars, it had to invest in building charging stations, a significant fixed cost. Okay? And in the end, I find that the presence of fixed cost will generate lots of interesting trade-offs between incremental innovation and radical innovation in the model. Okay? For the interest of time, let me only discuss the maximization problem of high-type innovative firms. These firms will choose to do either radical innovation or incremental innovation, and once they choose the innovation type, they will choose the innovation probability and also make their net worth level decision for the next period. This is essentially the saving decision of the firm. And they will also make capital accumulation decision. And these decisions will be subject to the limited liability condition and the capital constraint. Okay. So here, chi is the multiplier associated with the capital constraint, and mu, as we discussed, is the multiplier associated with the limited liability condition. Okay. And then we can define a balanced growth path equilibrium, and let me briefly discuss the mechanism in a detrended equilibrium. Okay. So first, let's think about what will happen if there are no financial friction. In this case, the firm's net worth level doesn't matter, and all firms can make decisions optimally. And in terms of innovation, we will see that all firms will have the same innovation rate by model construction. So I assume the benefit of doing innovation and the cost of innovation are both proportional to the firm's productivity level. So in the end, it doesn't matter. Okay? For the choice of innovation type, you will see there is a cutoff. Above a productivity level, these high-tech firms will choose to do radical innovation. Otherwise, they will choose to do incremental innovation. Because in this model, in this exponential growth model, the extra profit from doing radical innovation compared to incremental innovation is increasing in your firm's productivity level. And in the presence of fixed cost, the additional fixed radical innovation cost that is the same for everyone, you will see there is a cutoff. And then we can discuss what will happen if we have financial frictions. Okay. In the model, we will see that consistent with most firm dynamics models with financial frictions, low net worth firms and high productivity firms are more likely to be financially constrained. In this case, collaterally constrained. Low net worth firms don't have enough collaterals, and high productivity firms typically want to borrow more to expand their production scale. So they are more likely to be constrained. And then, given financial frictions, we can discuss how firms' decisions are affected. So first, we will see that financial frictions will incentivize firms to accumulate net worth. Okay? And high productive firms and low net worth firms, which are more financially constrained, will accumulate net worth at a faster speed because they are more financially constrained. Okay? The red panel shows the decision rules under a tighter capital constraint modeled by a lower theta. Okay? Tighter constraint to slower speed of accumulating net worth. Okay? In terms of innovation probability, we will see that financial frictions will reduce innovation probability, and especially for low net worth firms and high productive firms. Okay? So the high productive firms have lower innovation probability compared to low productive firms, given the same net worth level, simply because they are financially constrained and they really want to borrow to accumulate more capital to relax their borrowing constraints to expand their production scale, utilizing their existing high productivity level. Okay. And I have these two equations here to highlight this mechanism. Okay. If you know you will face a binding constraint in the future, you will know that you have a binding limited liability condition today, because you know in the future you will face high shallow cost of external finance, and you'll be very cautious about your borrowing today. And then you will allocate fewer resources for doing innovation investment. Once you invest less, you will have a lower innovation probability. That's the mechanism. And then we can discuss how financial frictions reduce firms' probability of choosing radical innovation versus incremental innovation. Let's first look at the left panel. Okay, I have 3 lines. So the black line represents high net worth firms that are not financially constrained. You will see there's a cutoff. The x-axis is the productivity level. About the cutoff, above productivity level, these firms do radical innovation. Otherwise, they do incremental innovation. And the red line represents firms with mid net worth level. Okay? You will see there are 2 cutoffs. Okay? If these firms are very productive, they will choose to do incremental innovation instead of radical innovation. This is because these firms are financially constrained. When they are very productive, they still want to accumulate capital, accumulate net worth first to expand their production skill. And then in this case, they will think radical innovation will be too costly. So they want to have a safer choice to do incremental innovation. Okay. And the last line, the blue line, represents firms with very low net worth level. They are very financially constrained. And in this case, you will see that they will never choose to do radical innovation. Okay. And the red panel shows the decision rules when firms face a much tighter collateral constraint. And the takeaway of the red panel is you will see much less probability of choosing radical innovation because they're very financially constrained.
Still want to do the introduction figure with net worth on the horizontal axis for the income country.
I can do it.
That sounds more direct.
Sure. Thank you. So this is the mechanism. And then we can take the model to the data to evaluate the macroeconomic implications of financial frictions. I have some parameters determined outside the model, which are standard parameters, and I also have parameters that determined using simulated meta moments. Okay. I first target estimate parameters to target the data moments in high income countries. I then vary the financial friction parameters, the constraint parameter, to match the leverage in middle income countries to isolate the effects of financial frictions. And I also try alternative ways to estimate parameters in middle income countries, basically re-estimating every parameter, okay, to show the robustness. Okay. For the data moments I target, I have 3 types of moments. I have innovation-related moments, industry distribution-related moments, and financial friction-related moments. Okay. The model targets the data relatively well, and I use non-targeted moments to validate the model. So first, I have moments related to firms' financing patterns over the life cycle. As I discussed, I use leverage and average ARPK. I also check the growth rate difference between capital and the sales. And the takeaway of these numbers is in both the model and the data, firms in middle income countries accumulate capital at a faster speed compared to firms in high income countries. And firms that have a relatively high leverage level and a low ARPK level are more likely to become innovative firms in middle income countries. But in high income countries, the premium of having a high leverage and the low MRP and ARPK is small, okay? Indicating that financial frictions matter more in middle income. Okay. I also show that in both the model and data, these different types of firms have different size, not only at birth, but also along their life cycle. Okay. So basically, the model can generate that in middle income countries, the radically innovative firms are no larger than incrementally innovative firms, because some very productive firms will choose to do incremental innovation instead of radical innovation, just taking it a saving price. Okay. So basically, in high income countries, if you want to identify firms type, you can just look at the size of the firm. But in middle income countries, it's more complicated. Yeah. And this table shows the aggregate effects of financial frictions on TRP level and the growth rate. I also do a decomposition, and I find that the key channel that financial frictions work is by affecting the composition of firms. It also matters for the growth of young firms, especially those radically innovative firms, because they are more sensitive to the borrowing constraints. And I think the key difference of my model compared to the previous literature is we have this heterogeneous firm types and innovation types. And I shut down these additional elements to see what will happen, to highlight the role of these new model elements. I find that without these heterogeneous types, the model would overestimate the growth contribution of small and unproductive. Okay? Because
just a comment on the growth effects are, you said the model implies 4 percentage point growth effects.
0.04. It's a small number.
Was it's a small, but the TFP effects are the order of 15%.
12%. So this number means the TFP level in middle income countries is 12% lower than that in high income countries.
But the growth is 0.04 percentage.
Yeah. Yeah. In terms of the growth rate is a little bit off of the data, but I'm trying to understand why I have this result.
We're trying to make the semi-endogenous growth models in which there will be no growth effects. You say it's kind of the same. There are small growth effects.
Yes. Yeah, so this quantitative analysis is it's not the final version, so I will try to think more about this.
Do you have a sense of how these numbers compare to Ottonell and Winberry's numbers?
Yes, I did the counterfactual because their model can be nested in my framework. But sorry, I forgot the number, but I will double check. Yeah. Yeah, so basically one important takeaway compared to their work is their work would overestimate the growth contribution of these small firms because they assume all firms can be large over time. But once we consider that only a certain fraction of firms can be very large over time, you will see that the relaxing constraints of these incumbent firms may not have a large effect on productivity inputs.
Just also to understand what the columns mean. So are you?
These columns?
It's you're changing the model and you're keeping the parameters the same except for those parameters, or you're re-estimating the model?
I re-estimate the model. Yeah, and also, sorry. I also think this is like a comparison with previous allocation literature with the everything is part.
And you just, since you have some time, I think, can you tell us the main difference between Antonello and Wimbury in your model? I mean, what sense your model is more general?
So I assume only certain firms can be innovative, can make innovation investment.
There's heterogeneity, something about that.
Yeah, but they assume all firms can make innovation investment. I think this is the key difference.
Like the model facts, they stress and the fact that you stress.
So
Looking
they
at US data.
yeah, they look at US data and they show that when firms are very large, they will become innovative for sure. But I'm showing that as firms age, they cannot really change their types. So I here basically in their data facts believe all firms can become innovative. I think one important reason is to look at US compute stack firms, which are already very large. Yeah, but here I incorporate many different small firms.
And also they have this kind of corner solution or innovation, no? You also have the corner solution when you are.
So interestingly, I don't have because
Exactly, that's what you understand that feature.
so they have a very like a large region that firms will have zero innovation probability, but I don't have because I don't have a fixed cost of doing innovation. So otherwise, I will also see this in action region. The reason why I don't have a fixed cost is because in the data I see that once firms enter the market, many innovative firms will keep doing innovation. So I don't have to have this.
You just calibrate that to be.
Yeah.
And can you also tell us in that last table, like,
Sorry.
the last table, like the TFP level versus TFP growth effect, like how much do those contribute each to welfare? Like net present value?
I can do this. Thank you.
So what, I don't understand how you compare TFP levels on growth rates different.
Oh. So because the firm size, the distribution can be different. Right. So in a world with relatively low financial frictions, firms draw this distribution of this productivity level. And then I lower the financial friction, reduce financial friction, and I can still plot firms in the same space, but they have a fatter left tail. They have more unproductive firms compared to a world with fewer financial frictions, and then I can compute the.
Are you doing a calculation of it? Taking away mislocation, what's the effect of that, or it's just a TFP calculation? Yeah, in that case, I agree with Ezra. See that if you look at the balance growth path, the levels should be diverging infinitely.
Compare two balance growth paths with different growth rates, you compare the levels when they.
I see your point.
But I guess you might be doing say, let me take away mislocation. Are you doing a Peter and Sue calculation of what happens if I take away mislocation in one case and the other? I mean, that one I can imagine doing it and saying,
yeah,
was the contribution of mislocation to TFP?
Yeah, so I think a more like a fair way is to assume all countries are on the same balance growth path.
I would just do a semi-endogenous growth model. And then you just again, you're not going to talk about growth. Anyway, the effects on growth are small.
Yeah. That's a fair point. Yeah, it's not hard to make it a semi-endogenous growth.
And that's it. You take that away, and then we can talk about TFP levels.
Yeah,
that's what we care about the cross, right?
Right.
No, different.
Yeah, it's very sensitive.
Yeah. So in the real world, when we look at the practice or policies, we see lots of policies about innovation, especially today. And usually we know that there are lots of distortions in the real world, and that the policymakers will just take these distortions as given and provide innovation subsidies. So basically, innovation subsidies very common, and I want to see how it works in my model and whether existing policies are effective. In high-income countries, so I tried two different policies. One is to provide subsidy for all entrants, or say provide subsidy to entrants' investment in their firm types. And the other policy is just to subsidize incumbent innovative firms. Okay? And I consider a risk-neutral policy. So all policies are comparable in the sense that they are equivalent to a 10% innovation cost reduction for innovative firms in high-income countries. And I find that in high-income countries, creating more innovative firms by subsidizing entrants can lead to a larger increase in TRP level and growth compared to firms in middle-income countries. Yeah. But in middle-income countries, we should also care incumbent innovative firms because they are not doing innovation optimally. That's all from my paper. Any comments are more than welcome.
So one thing that I didn't really get is, right now, do you show anything causal for the effect of financial frictions on innovation? Because I guess at least what I was thinking is you could just have reverse causality, that you're basically showing that less financially developed countries have less innovation, but it could just be that it is less financially developed precisely because there's just less innovation there. They're worse at innovation, so it's just less profitable to do a lot of financing.
That's a fair
And I guess you
point.
want to show something.
Is it Russian?
And the Singalis thing is not enough, no? It doesn't give you causal.
So actually, when I work on the data facts, I didn't expect it's a story of financial frictions. Yeah, but the data tells me the finance plays a role. Yeah, but I do
But is there
want
for
to.
one of the countries maybe something where you can show some kind of a change in the financial frictions, and then you see an effect in the direction that your model would predict?
Yeah, I think.
Just to get kind of to the dynamic effect, right?
Yeah, in the model is kind of indulgence in the sense that even give the same level of financial development, suppose firms in middle-income countries are small due to different reasons, they will also prefer to do more capital accumulation because they are small and they are not large enough to have enough collateral and to expand their production scale.
Right.
Yeah, fair point. I'll think about it.
So, regarding the distinction between the types are very important. So, what fraction of average goal are driven by radical innovation? Is it 90%, 80%?
In the current quantitative analysis, I didn't compute that number, but but I can show the relevance in terms of sales share. So all innovative firms account for 10% sales share in the data. If I remember correctly, yes, 10%, and half of the firms are radically innovative. But only 21% of firms are innovative firms. So there are very few innovative firms, but they really account for a large share.
Okay. Thank you very much.
Thank you, everyone. Thanks all to all the presenters. I had a great session. Thanks for coming.
So I think I might do something wrong because I just changed the thing in tiny countries like Finland, the level of productivity in tiny countries like Finland.
So it's like a time zero.
Outstanding grades.
Then
I see.
Yeah, that's what I was thinking. So like the first column was just like the underneath triangle, moving triangle.
Got it.
And the other one is like the.
Got it.
Just the last couple of years.
Yeah, you should, yeah.
And so I guess that's, yeah, what they want to see is that you give the second one, so you just.
Well, I know well, there are people, there's people who really like growth effects, some people don't care about the growth effects. I think it's you'll lose some of your audience just being with the growth stuff.
Yeah, that's like, what you want to emphasize is like the 12, probably as. I think it's a don't engage.
That's what I need to understand. I mean, one way to do it is to do both versions and say, if you sometimes it's 12, the growth rate is this tiny growth rate thing, we also get this. I think that's probably the way I would do it. Usually, I don't think you want to